Hey guys, we received multiple grievances about the sound quality of many of our previous videos from multiple viewers over a long period of time. We paid serious attention and as a solution, we are republishing all the episodes from our PERL in VLSI series all together in this marathon episode by digitally remastering the audio. In this marathon episode, you will learn the PERL basics, including simple and complex form of data structures. You will learn about string processing using regular expressions, which is used widely in VLSI, CAD automation, and QC/QA flows. You will learn about PERL automation using simple reproducible example, including log file creation using file::t module, which we will learn to install prior using it in the PERL automation. Finally, we will dive into object-oriented PERL using the native features in PERL. Also, we will show you how this can be done using advanced PERL module Moose.pm, which we will learn to install prior using it. At the end, we have bonus interview preparation episodes on PERL, and you will learn about advanced module to handle Excel file in PERL for reports generation purpose. This is a must-have marathon for all the VLSI aspirants, either in the front end or in back end. So, stay tuned, stay focused. Welcome to the very first episode of PERL programming in VLSI. In this episode, we are going to discuss where PERL is used in VLSI, introduction to PERL scripting language, installation guide, Hello World in PERL, defining a variable in PERL, variable type declaration in PERL, my, local, our variables, special variables in PERL, special literals, and bare word. So, let's begin. Where PERL is used in VLSI. This is the thing you first need to get aware so that your motivation of learning PERL is in the right direction. Apart from VLSI, the PERL is also used in web hosting and web applications. But for VLSI, PERL is a very widely used language and it is used in automation to run batch jobs in local or remote machines such as LSF, quality check and quality analysis, that is QC/QA, of text outputs of VLSI tools, data intensive comparison between two different large output data files, regression automation of test cases, regression quality analysis. So basically regression is a thing where there are a set of test cases and there is an automation engine there which runs a particular software for testing on all the set of test cases. So this automation suite can be developed with PERL, and once this regression has run and all the runs has stopped, right, the output that has come across all the test cases, the quality analysis also can be done with the PERL. These are 2 points just mentioned. The next point is VLSI CAD infrastructure building and maintenance. So what is VLSI CAD? VLSI CAD is basically, it's an automation environment. So most of the design houses, they have their internal setups where they use internal PERL engines to create the whole suite that includes from designing to the tape out. So this entire suite is developed in the cases where it is used in PERL, right? So there it will have a vast multiple packages of PERL. So they will be used, and this is how it makes the life easy for a designer. And most of these VLSI tools are in Linux. So this PERL automation suite that helps to call all the command line based tools that are used in VLSI appropriately with a set of appropriate inputs and all. So that is the purpose of the PERL automation in VLSI, to make life easier for a designer. And here I would like to mention one point, because one particular stage of design has to be repeated multiple number of times. That's why automation helps the designer to just keep all the batch things that has to be run in that particular set of initialization and launching the tool and execution of the tool. So this point is done. The next point is modular or object-oriented programming to protect sensitive data. So in VLSI, when global team works, right, they encapsulate their information through object-oriented programming in PERL, so that the entire design, when it is worked on from different physical geographies, right, the sensitive data stay hidden. That is one particular area where OOPS is used in PERL. And there are many more. So these are few points that I have discussed with you, which are the areas in VLSI which VLSI engineer might face where he or she can use the Perl. But it is not limited to all of these options, because Perl is a programming language and you can write your own script to serve your own purpose. So the usage of Perl is not limited. Once you learn Perl, you can create your shorthand task in Perl. Okay, we are done with this particular slide. Let's move on to the next slide. So before we begin, let's introduce ourselves to the different parts of the Perl. Perl is the abbreviation of Practical Extraction and Reporting Language. So this is abbreviation, that is Perl, and Perl is not something that is we have in the jewelry shop. Every Perl script in Linux or Unix must begin with hash bang user bin Perl. There is a path of the Perl, and -w is used for warning. Perl is case sensitive. That is, $C is a completely different variable than $C. So when you code in Perl, keep it in mind, whatever variables you are declaring or whatever nomenclature you are using, you must be consistent in that, so that stick to a particular type of nomenclature and particular case sensitivity. It is highly recommended that you use the ustrict directive at the top of your all programs. This forces to declare all your variables and causes Perl to complain when it sees a variable which has not been declared, or even it could be a misspelling. Because of this case sensitivity thing, it is always suggested that you use strict this pragma at the beginning of your code. It also checks the variable scopes in different blocks of a long code. Okay. Hash starts a comment in Perl. So whatever comment you have to give in Perl, whether it is a full line comment or it's an inline comment, both can be started with a hash. Okay. If there is a multi-line comment, you have to use multiple hashes at each line. Okay. So each line will start with a hash, and that's how you make a multi-line comment. Every line of code ends with a semicolon. So in Perl, this is very strict. So this is the very short and sweet thing that you must know about the Perl before you start coding in Perl or before you jump into anything in Perl. So these are the few basic necessary things. We are done with this particular slide. Let's move on to the next. Installation. So here is a website. So perl.org/gethtml. So here if you go, whether you are using Linux or you are using Unix or you are using Mac or you are using Windows, you can get your particular Perl here. So once you go to this page, you can see Linux. Mostly in the cases of Linux, we can see that Perl comes preloaded. It may not be the latest version. For your sake of your learning, you can go with it. Mostly whenever you are downloading and installing a Linux on your home PC, right, it will be from the latest version of the Linux distro. So basically Perl will be most updated there. If it is not, you can always have option to update. The same thing for Mac, it comes included. In this particular page, you will see these symbols, right? And if you have to download, you can click on the get started of each of this one. Windows, whereas compared to the Mac or Linux, do not have the Perl inbuilt. Perl do not come as an inbuilt installation in Windows. So to circumvent that situation, either you can use a Strawberry Perl, which is a software, or Active State Perl, which is another software. So you can click on the get started there and download this Strawberry Perl or Active Perl setup.exe files. Okay, and you can click the setup.exe file and install like any other programs that you install in Windows. So this is a summary. So whether you are using Linux, Mac, or Windows, you can use Perl any one of them. And this is another beauty of the Perl, that Perl scripts can be ported. Obviously, these are not automation scripts, because in different Windows, your automation might become different and your tool might become different. But for your programming and learning purpose, your code can be ported to any of from in between, and where it do not involve explicit disk access or any disk files. Okay, where it's just pure program, procedure oriented programming. So in that case, this code can be ported. So done with this particular section. Let's move on to the next. Hello World programming in Perl. So this section, I'm writing the code here. So start the code with hashbang user bin Perl w. Use strict. This must be used. So keep it in mind whenever you are writing. These two lines should be there. Obviously, in your machine, the Perl may be installed in a different path if you are using Linux, right? There you might use the which command to find the Perl path and then include like this. Okay. So just replace the /user/bin/Perl with your Perl path, installation path in your machine. Okay. So rest of the things remain same. For Windows, it will not be there. Definitely there to use the instructions of Strawberry Perl or Active State Perl. Okay. So here the first two lines go, and the third line print \n hello world, then \n. So this is very easy to write. So it will print the hello world. This is the inside text of the file. Now once this you have written, save the above text file as hello.pl. Here one thing is to be mentioned. PERL file generally we save with the extension .pl. So it clearly identifies the PERL file. Give executable permission to it, chmod +x hello.pl. Then execute it as /hello.pl. Output is hello world. So this comes to your Linux shell when you execute it. This is the way you can write any PERL program. You just have to have a text editor. Whatever text editor you are using, you can use that, and you can save it and then change the permission to executable, and then you can execute like this. So this is the way. Inline PERL coding. This is another important feature of PERL. You do not have the right permission or need a very short PERL script. So it may happen that you are working on a network machine, right? You are using a SSH or remote access, right? So in that particular machine, you don't have explicit disk space where you can save a PERL script. In that case, what happens, right? You can run an inline code. Here, I'll show how you print a hello world code. So your code could be very short. For long code, it is suggested you write in a PERL file and execute. But for quick things like where you don't have a right permission, you can use the inline PERL execution. So this is the syntax. Okay, so in the command line you will write PERL, then space, then -e, then within single quotes you will include print, then comes the double quote. So the entire command should go up to the semicolon inside single quotes, and whatever inside there should be in the double quotes. And for print it will be double quotes. Any other command will follow as its syntax. Okay, so here print hello world will be there. So this will execute the hello world. So the code is not saved, but it can be executed. Okay, so this is the way you can execute PERL. So another important factor, PERL is not a compiled language and PERL is an interpreted language. So that is the best thing, that it acts very much faster, and that's why PERL is used in many cases. Here it is not compiled and it is interpreted. So that is the beauty of the PERL. Let's move on to the next one. Defining a variable in PERL. So here we are talking about a scalar variable. A scalar variable means a variable which has a single value. It is neither an array nor a hash. Hash and array will be described in the later sections. Here we will talk about only scalar, which is a single variable. So let's see. To declare a variable, we use the my operator, like my $var equal to 32. So it will define my. And why we are using my? Because the beginning I have mentioned that we are using the use strict pragma. So that will force you to use my. And it is a good practice. Even if you missed out the use strict, you put a habit of writing my. This defines a scope which we will see later, okay, in the later part of this video. To declare multiple variable at once, we are not initializing any value. We can write my, then within parentheses we can write $var1, $var2, $var3, and we hit semicolon after that. So this is where we can define multiple variable at once. PERL has a special undefined value, often written as undef. So undef is a predefined keyword in PERL. In the lines, okay, you see that I have written that my $var1, $var2, $var3. So these are not having any value initialized. So they will be initialized with undef. Declared but not assigned variables have the value of undef. I just mentioned about this, okay. So you have declared a variable but do not assign any value. So that will by default contains the undef. Explicitly, a variable can also be defined. So $var equal to undef. If you define $my var equal to 32, and the next line if you define $var equal to undef, right, that will make the variable undefined. The initialization is gone from there. There is no Boolean type as such in PERL. Boolean type means true, false, okay. Instead, PERL has a notion of truth or falsity of any other scalar. So let's see how it is done in PERL. 0, the number itself is false. The empty string within single quotes and the string 0 within single quotes are false. If we have a if condition, right, both of them will return a false. Undef itself is false. Anything else is true. So here we have defined the false. There are 3 cases, 3 bullets we have discussed, right, which are the false, and anything else is true. Floating point values include the special values. Okay, we have, say, floating point means we have real values. So they contain inf, that is infinity, and nan is a not a number for infinity and not a number. The infinity can also be negative. So these are more things that you have in PERL. Here in this slide we have discussed when using a scalar, that is a single variable, not an array of variable. of any kind or list, not those cases, but only a single variable, that is scalar. The details of a scalar we have discussed here. So we are done with this section. Let's move on to the next. Type declaration in PERL. PERL do not have explicit separate data type declarations such as integer, real, double or float. So those of you who have already learned C in their colleges, right, you might say that okay, there is a type declaration, integer, real, but in PERL you have this flexibility. You do not explicitly, you have to define each of them. So PERL takes care of them automatically. However, a scalar can accommodate all the below types as $int is equal to 42. It is treated as an integer. PERL automatically takes care internally. $pi is equal to $3.14159265. So it's a real number. $data is equal to 6.02e23. So it's an exponential notation. $animal is within double quotes camel. It's a string. $sign is equal to within double quotes I love my $pet. So $pet is replaced with camel, which if we have initialized, so animal, or we can write here the animal $animal, right? We have just in previous time we have written $animal. So if we have written I love my $animal, right, it would have replaced with camel. $cost within single quote, it cost $100, string without interpolation. So here this will be as is, so nothing will be replaced. So $100 remains $100. But in the previous case, when it is used within double quotes, $pet get replaced. In space of $pet, if we have written $animal, it would have replaced to camel. Or if we have written any of the above, right, $int, $pi, $data, right, it would have replaced that particular variable. So these two are called string with interpolation for the double quoted and string without interpolation. It is called without interpolation. So double quotes, it changes the variable value to contain value, but in the second case without interpolation, it remains as is. $number1 is equal to $var2. Another variable value, it gets assigned to $number1. $ab is equal to $a star $b. So it's a mathematical operation we are multiplying. So these are okay. Mathematical operation like plus, minus, division, modulus, all these are okay and permitted in the scalar values. So $out is within double backtick pwd. So pwd is a shell command, right? And that shell command will execute in shell. So if we include in dollar within the backtick pwd, it executes in the shell and output from that command is stored in $out. So this is a way that we can capture any shell commands output in a scalar. $exit, we have to use a system, then dollar within the first bracket we have used vi$x. This will execute $vi$x in the Unix shell, and the numeric return status of this command will be stored in $exit. $apple is equal to new user defined class name. So here comes your class name. It's a oops part of the PERL, that is object oriented PERL here, and then name fruits. So this will become an object of the particular class. Okay, so these are the all data types that can go into a particular scalar, and PERL internally takes care all of them. So you can be rest assured that separately you do not have to do the type declaration, and PERL will take care all of the types that I have shown here. In case I have missed anything, that also. So all of these data types will be contained in the scalar. My, local and our variable. A my declares the listed variables to be the local to the enclosing block, file or eval. If more than one variable is listed, the list must be placed in parentheses. This is the purpose of the my that I was mentioning, that whenever we are using use strict, we must exclusively use the my, and whenever we are using a block of code, this my will make that variable for that particular scope of that code. Local modifies the listed variable to be local to the enclosing block or file or eval. More than one listed value, the list must be placed in parentheses. So here local does what? It makes temporary values. We have a global value and making a local value of it by using the local. And our creates the package variable. Here our will create a package variable. It declares an alias for the package variable that will be visible across the entire lexical scope, even across the package boundaries. So let's see. Later part of this entire series will come to the package, but here for a short and sweet example, we are showing this one. Package foo, and then we write our bar. So it declares the foo : bar. So package is nothing but a namespace. So in that namespace, bar is defined. So this bar is our bar, means it means for the package foo. Then we assign bar equal to 20. Next we define package bar and then we say our bar equal to 30. So it declares the bar colon bar. So the next namespace, okay, this bar goes to the next namespace. Here, if we print bar, it prints 30. Our bar emits the warning but has no effect. So if you repeat, it doesn't do anything, okay, because it will issue a warning. Then again we print bar, it still prints 30. Basically, our ties a variable to that particular namespace, which we have just preceded before that variable. So these are my, local, and our. So my makes a variable particular private to a code block. Local makes a, we have used any global value, and we have to define a local temporary value. We use local, and our is a completely different usage, right? It related with the namespace. So these are the three main types of variable declaration: my, local, and our. So we are done with this particular slide. Let's move on. Special variables in PERL. So far we have discussed the general purpose or general way of creating a variable and different values. But PERL as a programming language does have a lot of special variables in it. In this section, we are discussing about all these variables. $_, the default input and pattern searching space. It is a global variable. So you need not to define it. In this section, whatever variables we are discussing, right, they are already predefined in PERL, rather say. And we have to see what are those one. It's a default input and pattern searching space. It's a global variable. The following function use $_ as a default argument. Abs, alarm, chomp, cost, define, eval, experience, fc, glob, hex, int, lc, log, oct, org, pos, print, printf. Okay, all these things you can see here, all these predefined functions in PERL, they use $_ as a default argument. Say in previous line you have just assigned something to $_ and then in the next line you are using any of all these predefined functions. So these functions will take the argument which we have set for the $_ even we do not specify any argument to them. So this is the way this $_ is used. Another use, the pattern matching. This is a regular expression in PERL. Okay, we'll have an episode on this. Okay, but here, just for your sake of knowledge, you know that matching, string replacement, or transliterate. In these three cases, or the equal to tilde, that is a matching operator. In these cases, $_ is the default variable to which these all matchings will be done. This is a regular expression. The default iterator variable in a Foreach loop with no other variables applied. So if we are using a Foreach loop and we have not declared a iterating variable on which we are rotating the Foreach counter. So in that case, $_ becomes our predefined iterator variable. The implicit iterator variable for grep and map functions. These are two another functions. In this case also, it's the implicit iterator. The implicit variable of given. It is another PERL function. The default place to put the next value or the input record when a file handle is used. For the file IO, right, we also have these $_ defined. So read line, read dir, or each operation result is tested by itself and the sole criterion of the while test. Outside a while test, this will not happen. So inside the while loop, when we are opening a file, right, the lines which we are reading from the file using the file handle will come to the $_ by default. So if you have not defined any particular variable to get the lines will automatically come into $_ So this is for file IO. So this is how special variables in PERL. So we have more special variables. Let's move on to the next slide to see them. @_ within a subroutine. @ contains parameters passed to that particular subroutine. So when we are using subroutine, that is functions in PERL, this will contain all the arguments. Okay, inside a subroutine, @ is the default array for the array operators pop and shift. Okay, $A and $B, these are special package variables when we are using sort function. Sort does all kind of sorting. It could be numerical, it could be ASCII, okay? But $A and $B, these are special variables that are tied with sort function. Because of these specialness, $A and $B don't need to be declared to used using the vars or using the strict vars pragma. Don't lexicalize them with $my_A or $my_B if you want to be able to use them in the sort comparison block. So these $A, $B are very much don't need any declaration to be used in the sort function. So they are very default. We'll see later on. We'll use the sort function. And here $A and $B have a special meaning when we are using the sort function. %env. So this is a hash, okay, it's a hash table or an associative array, right? That contains your current system variables and their values can be manipulated by hash or associative array. Okay, so we can add a value or change a value using our hash operators or the associative array operators. So %env, where we get all the environment variables when we are using inside the Perl script. We can set an environment variable using this particular data structure, or we can get a particular system variable using %env. So @inc, the next one is the array contains the list of places to do expr, require or use construct blocks. Okay, it is initially consists the arguments of any -i command of the lines which is followed by the default Perl library probably used by local libper. So @inc contains all the Perl library path. This is very simple. Perl library means when you run a script, right, it will use its default function and all those are stored in different Perl libraries. So those Perl libraries can be found in @inc. Okay, this array. @isa, this comes in the object-oriented Perl part. So @isa, each package contains a special array called @isa, which consists a list of that class's parent classes, if any. This array is simply a list of scalars, each of which is a string that corresponds to a package name. The array examined when Perl does method resolution, which is covered in Perl object. Okay, so @isa, it is very much tied to the object-oriented Perl. We'll see the use also there. So these are some more special variables we have discussed. So we are done with this particular slide. Let's move on. Oh, there are some more special variables. Let's see them. $, the process number of the Perl running your present script itself. So if you are running a Perl script, right, it has also a process number. So $, gives that. These are inside your Perl script, not outside. So inside your Perl script, if you want to print, you can use these particular variables. $0 contains the name of the Perl program that is being executed. So when you execute a Perl program, so $0, if you print, right, it will print the file name which you are running. $digits, $1, $2, etc. contains the sub-pattern form corresponding to the set of capturing parentheses from the last successful parent match. So this comes from the part of the regular expression. We'll see later. $1, $2, these matched groups. Okay, basically not counting patterns matched with the nested blocks that have been exited already. Okay, so these $1, $2, they give you the matched substrings. Okay. $and %, the string matched by the last successful pattern matching, and any matches is within a block or eval enclosed by the current block. And % gives you the last pattern matching. $argv contains the name of the current file we are reading from the Angular operator. @argv, the array @argv contains the command line arguments intended for the script. So when we are running a Perl script with set of arguments apart from the file name, say /myprogram.pl, and then we have some arguments, all those arguments will be saved in @argv. For exhaustive list of these all variables, special variables, predefined variables, you can go to this link. This is https://perldoc.org/perlvar. If you go there, if you have a thirst to know what are many other variables that are predefined in variable in Perl, so you can go and learn about them. In this particular video, I have shown couple of them which are more frequently used and come to you, but still there is a list remaining. If you want to get that list, go to this particular URL. So there you can go into this particular page and you can learn about them. So we are done with this particular slide. Let's move on. Special literals and bare word. Special literals like this file, line and package, you can see how differently they are written. Okay, they are written in caps and they have before and after they have underscores. These represent the current file name, the line number and the package name that point in your program. So these have special meanings. So that is why these are called special literals. This file, this line and the package. Literals have the file name, the line number and the package name. Similarly, sub, this special literal gives a reference to the current subroutine. Bare words, a word that has no other interpretation will be treated as a coded string. These are known as bare words. So generally where we see the bare words in hash table or the associative array, key can be bare words. So bare words we'll see there once we discuss. A bare word that consists entirely the lowercase letters risks conflict with the future reserved keyword, and if you use the use warnings or the -w switch, Perl will warn about any such words. So bare word that is clashing with any of the pre-reserved keywords in Perl, like undef or something, so write it in somewhere, right? It will issue a warning. So use warning is another thing that you can use with the use strict, or if you have included the -w, that will serve the purpose. So be aware of the bare words. If you use the use strict, then any of the bare word that would not be interpreted as a compile time error. Only bare word are allowed as a hash key, not the value. So, and I just mentioned that where we are using, right? Hash key can be a bare word, but not its value. So we are done with this particular slide. Let's move on. Hey guys, welcome to another episode of free and open source software installation. In today's episode, we are going to install and use Geany IDE in Ubuntu Linux. The best thing of Geany is the tabbed interface, which helps you to open and edit 7 to 8 independent or interdependent files side by side. This is the free and lightest IDE out there. Stay tuned till the end of this video to get ready with this integrated development environment. Hey guys, welcome back to the computer screen. Today we are installing one very useful and lightweight integrated development environment. As you can see here, we are on the URL geany.org. This is our IDE, integrated development environment. That means you can code here and at the same time you can run the code in the same window. So you don't have to switch in between a text editor and the command terminal to do the coding and running the code. The beauty of Geany is that it is free of cost, it is a free and open source software, and it is very much lightweight. That means it do not eats up your resources while running. Here you can see it is written Geany the lightweight IDE. And you can see it is compatible to multiple OSs like Linux, Windows and Mac OS. So in any of the OS you can download it. So here in the top row you can see that it is Geany, the base, then about, then download. If you click it, you will go to the download page. Alternatively, you can click here and go to the download page. So here you can see the source code is also here, the Windows binary is there, Mac OS is there, and in Linux, other than the Ubuntu or Debian, you can go ahead and use the source code to build it. For Ubuntu today, I will show you how you can install it from the command line. If you go here, you can see the manual, and here there is a wiki. So if I go to the manual, download the manual here in HTML format as well as in the text format. If you go to the wiki, you will get a lot of articles here. How to do things are here, and you can find out a lot of tips and tricks here about using the Geany. Now let me go back and go to the main page. So this is the general interface of Geany, and color can be switched. It can have multiple themes. So that's why these are there. And here, as you can see, it is very much fast and small, and it has a community support. That means you can have all the bugs and related info from there. And here you can see that multiple plugins are there, like here PCS plugin. And here if you go, you can find that different plugins. So here you can see different plugins are available. Let me go back again to the home page. You can see here it is supporting multiple type of programming language. That means once you install Geany, in the same window you can play with multiple codes. And if you want to go to this, let me go ahead and open in a tab. So there are a lot of available themes you can download, and you can switch to your desired look and feel for the Geany theme. Today I'll just showing you this thing. I will today only install the basic thing so that you can go ahead and start using the Geany. So without any further delay, let me go to the terminal. So here I will type sudo apt-get you must spell this correct. Geany is Geany. So I have written the command here, sudo apt-get install Geany, and I'll hit enter. I am connected to the internet right now and it is communicating with the repositories to fetch the required files. So here you can see that it has installed. So here I was logged in with the sudo password, so it did not ask and it go ahead and install the package right away. Let me clear the screen. I'll invoke Geany. But now we have come to the interface. Here you can see file. From here you can save or save as the file. The most common operation, and you can find and replace operations. You can do it from here. Replace is here. You can change the view from here. You can do multiple document related stuffs here. In case of language like C or programming language or C++, you can do the build here. This interface is very useful. First left here you will see the files, which files we are saving and writing. Here is the editor window. Here you will see the editing. If you go down, right, there are a lot of other things are here like status. Here things will be messages, and here is the beauty. Once you are working in any text editor which gives you a syntax highlighting, the trouble with that is that you have to continuously switch between your text editor and the terminal. Here in Geany you don't have to do that. If you go down below here the terminal is available to you. So this is basically shell. If I type echo $shell, you can see is the actual Linux shell, and it is not an emulated shell. It is actual Linux shell, similar to the terminal here. It's the same thing. Now let me write a PERL file. I have done the touch here and I'll open the file from here. So here you can see I'm opening the hello.pl that I have created with the touch command, and it has 0 bytes. So let me open it. One thing, whenever you are writing a file, you must give the extension of that file name properly so that Geany can recognize what kind of syntax you are writing and it can highlight. Now I come back here and I type. So I type and I hit Ctrl S, save the file. And here I type I again hit S. You can see once I hit S, the star goes from here and it is saved. You can see I'm continuously interchanging between the terminal and the text editor. However, my screen is static. I don't have to change anything. So I am changing the execution permission of the hello.pl here. I do a Ctrl S again in the editor and I run it here. So you can see hello world, it is shown. So the PERL file has executed and here you can see the syntax is highlighted. So today we have used Geany. You can see a fast and lightweight IDE, and here is the website I have just shown you in the beginning. I'll provide the link in the description so that you can go ahead and access the manuals, the themes, etc., which I have already shown to you. And you can see it's under GNU GPL. So it's a free and open source software, and hence you don't have to pay any price. That's all, folks. Thanks for watching. Hey guys, welcome to the second episode of PERL programming in VLSI. In this episode, we are going to talk about various operators in PERL, control structure, if, else, if, else, file test conditions. These can be used inside the if. Control structures, unless, if versus unless comparison, loops, for loop and foreach loops, while and do while loops, again loops, until and do until loops, loop control, that is next and last. This is the menu for today. Let's begin the episode. First, we start with operators. So in Perl, there are different category of operators. In this particular section, we are going to talk about them. Here, we start with assignment operator. Equal to is the assignment operator. Plus equal to, minus equal to, star equal to, slash equal to, plus plus, minus minus, percent equal to are all same as they were in C++. I hope you folks know about C and C++ operators. So these are same as you have used in C or C++. Numeric. Plus, minus, multiplication, division. These are numeric. That is arithmetic operator. These are same as they were in C and C++. Star is an exponential operator. That is a to the power operator. Percentage is the mod operator, very much same as C or C++. Now we come to the relational operator. The numeric comparisons can be done with equal to, not equal to, less than equal to, greater than equal to. These are all same as they were in C and C++. String comparisons. Now this is a new thing that in Perl we are going to discuss. For string, if we are comparing two strings, if they are equal, we use EQ. Not equal to is NE. Less than is LT. Less than equal to is LE. Greater than is equal to GT and greater than equal to is GE. So these are all comparison operators between two strings, unlike the numeric comparisons. These are very much similar things, but these are applicable to the string comparison. The next one is regular expression matching or not matching operator. So equal to tilde is the matching operator and not matching is bang tilde. So we will in later sections when we discuss about the regular expressions, we will see the use of these operators. So there are more. So let's move on. Logical operator. So these like two pipes, then two ands and a bang. These are or, and not. These are logical operators. String. So in Perl, we have a very wide flexibility of using strings. In string, we can use the operator dot. This is a concatenation or joining operator. So when we have more than one string, we can just join two strings with this dot operator. And the resultant will be another string, which will contain the two strings in sequence. X is a repetition operator. Again, this comes under string. So how it operates? If we say have $var is equal to within quotes ABC, which is a string x3, it will result about in the var that ABC. So 3 times ABC. So it is a repetition operator. Okay, for strings. Interpolation operator. $name is equal to Howard. Say we assign this variable and we use another variable that is gen. Within that we use double quotes and then we write $name then university. I think here there is a typo here. So this will be Harvard University instead of Harding. So there came a typo and this $name variable actually got replaced within the double quotes. So that's why the double quotes is called the interpolation operator. So these are a couple of operators. Let's move to the next set of operators. These are file input-output operators. So this will be when we are saving a file in a disk or reading a file from the disk. These operators will be used. There will be a separate section on this particular file IO, but let's have a look into the operators. This less than operator acts as a read operator in file IO. The greater than operator acts as a write operator. Then 2 of the greater than operator acts as an append operator. Pipe then dash acts as an output pipe operator. And dash then pipe acts as an input pipe operator. These are the 5 input-output operators for file operations. So we'll see details in the file IO sections. We are done with the operator section. So let's move on. Next, this section comes as our control structures. So let's begin. First control structure is if-elsif-else. So if you look the spelling carefully, here you will see that here we have written if then dash else if, ELS if, not ELSE, E is missing. So this is the syntax. So don't make a typo here. Be very much cautious that E is missing in the else if block. And the else is as usual ELSE. So here, when one of the condition is found to be true, the block is executed and all the remaining branches are skipped. We are talking about if-elsif-else block. So one particular block becomes true, others become irrelevant. Okay. So here is an format. If condition 1 is true, we have the statement to be executed here. And if you look carefully in the syntax, so the condition comes under the first bracket, while the curly braces, that is a second bracket, will contain the statements. Else if, similar way, we'll have the second condition. If condition 2 is true, then we execute some more statement, else we execute some other statement. And here we close the else block. This is how our if-elsif-else structure we write. So we can write a single if and else, that is okay. And if we want to have more than one if condition, we can increase the number of else if blocks. So the first one will be the if, next block will be else if, and it will continue with more else if. So this can be increased any number of times based on your logics needed. Okay. And else will be a single. So if will be a single and else will be a single, else if can be many number of times. So we are done with this, and there is one more thing in this page, that is single if condition statement. So here writing style is different. So the statement comes at first if the condition is true. So this statement will be executed if the condition is true. Remember, sometime we need to use this just to make our code very sleek and beautiful. So in this case, we cannot use any else. So this is inline if condition and we can use it. But there will be no else if, there will be no else in this case. So we are done with this section. Let's move on. We are seeing some example here. If-Elsif-Else example. First line goes our hashbang user bin PERL-w. W is for warning. We use usestrict. So we write my price is equal to 21000, that is 21k. If price is greater than 30,000, we print high. Else if the price is greater than 20,000 and the price is less than 30,000, we print medium. Else if the price is less than 20,000, we print low. Else we print price is out of range and we close the else. So guys, here you can see that I have just mentioned that the else if blocks can be used many number of times, and here we have used 2 times because we have 3 conditions to be checked, and so they can go in 3 if blocks. Instead of 3 if, we have used if, 1 if and 2 else if, and the rest of the default message where we will go where the price is out of range goes to the else. So this is how we are going to use this if-Elsif-Else. I hope this gives you a quite good example. You try at your end and experiment, and please don't forget to comment. We are done with this example. Let's move on to the next one. Here, the file test conditions. These can be used in if. Let me bring my mouse pointer so that I can exactly point out. Okay. So here, these are R, W, X, and O. So these we know from our Unix concept that file or directory is readable, writable, executable, or owned by a user. We can use inside the if condition block with the respective file name. File name maybe we contain in a variable, that is a scalar, or it could be the direct file name. How we were programming, that is up to us. And here this is -e. The file or directory exists, -z, file exists and has 0 file size. So these are quite useful because why I'm sharing this, because in VLSI, whenever you are using PERL, many times you have to open a file and check it and close it. So you have to multiple times use these things to make your code perfect. Otherwise, what happens that there is a file that doesn't exist and your code will stop there. So that is very bad code. So these file test things will be very much in use in VLSI. Yes, now let's come to the S is file or directory size exists and has a non-zero size. And F-F is, it's a plain file. Now, if we want to check is a directory, -d is there for us. -L is entry is a symbolic link. So symbolic link, we know from Unix that we can create symbolic link, and if we want to check whether the file name which we have got is a symbolic link, we can use this -L to check inside if. The -T is the file is with text and -B is file is binary. So these all file test operators are used in the automation process in VLSI. When you are executing one particular command, then you are opening its result file which has come as the output, and you have to check how it is. So sometimes this file could be a binary, or it could be a text file, or whether you check whether it at all exists. So these file test conditions will be very much necessary. Have a note on these particular file tests. So I kept my screen static so that you can write or take a snapshot. Okay, we are done with this section. Let's move on to the next one. Unless. Sometime you want to stay idle if the condition is true. Now we have used if block there. What we use, that we use execute the statement when the condition is true. But if the scenario is exactly negated and we want to do nothing if the condition is true, then unless block comes into the picture. Do something only the condition is false. The unless block serves this particular purpose. This block of code execute only provided condition is false. So it is exactly the negated condition of the if. So let's see the syntax. Unless the condition is false, statements or one statement, whatever we have, and then we close the block. So it do not have any else or something. It just have unless. Another way we can use it is a inline unless. In that case, the statement goes at the first place, the statement, then unless, and then the condition is false. Okay, it is called one line unless condition or inline unless condition. So this is also used for beauty of the code. So this is the description. So let's see some unless example. Here in the pink box, our code will go, and in the black box, I'll show the outputs. First line always is the hashbang user bin PERL, where the PERL is installed. The next, we know it's just a generic comment that unless block executes only the condition is false. Use strict. We are using the strict module. My $a is equal to 1. We set the variable or initialize the variable with 1 while declaring it. Inline unless check. So here first we'll check the inline unless condition. Print PERL unless is used with a very simple condition only. Unless $a less than 0. So now if you look into the condition, $a we have written less than 0, and just before it we have set $a equal to 1. So this particular condition, a less than 0, become false just immediately after the declaration in previous line. So it output comes as printed PERL unless used with a very simple condition. This is how the false condition works. Let's see some more example. Again we set the value of a to be 10. Unless $a is greater than equal to 0, print condition 1. First unless is closed. We write the second unless. If $a less than equal to 0, print condition 2. Now, if this second part of the code is executed, $a is equal to 10. So which particular block of condition is true and which block is false? So $a greater than equal to 0 is true, and $a less than equal to 0 is false. Theoretically, when we execute, condition 2 should become there, and once we execute, what we see? Condition 2 is printed. So this is how you can use a unless. The condition depends upon your test case where you are using it. Okay, but this is a generic example, and in this example we have just elaborated how the unless can be used, or the code inside the unless block can be used or executed once the condition is false. And we have also checked in the second part of this code that if the condition is true, nothing happens. Okay, so that is the definition, that if the condition is true, nothing will happen. If the condition is false, it will happen. We are done with this example. Let's move on to the next slide. If versus unless comparison example. So here our code will go into the pink background while our output will go to the black box. Okay, let's begin. So first goes our PERL installation, that is hashbang user bin PERL. Use strict. We are using here single line if and unless condition side by side. If is printed, if 0 print, then we write if block 1. Block 1 will be a code of block, a pair of if and unless. So now we write the next unless 1. So for the same condition 0, unless block 1. Why I am giving this example? Because maybe in C you have not seen such unless condition, but here it is new. So you have to know the usage, and hence this elaborative example will make your mind very much clear when to use the unless. So here each of the two line I have marked as block 1. First one belongs to if and second belongs to unless. Now I put the same condition in if and unless. Here I have put 0. So technically this is a false condition. Which one comes here? Unless block 1. So print happens for the unless block. The next set of pair of the commands are if 1 minus 1, it is block 2, and if unless 1 minus 1, unless block 2. So which one will be printed? 1 minus 1 executed 0. I think unless will be printed here because 0 is false. If within double quotes, it's a blank, nothing is in between, comes in the block 3. So unless, again double quotes, block 3. So I think this is false. So the unless will be there. Yes, I'm correct. So unless will be in the third block executed. So guys, when all these codes are executed, right, both if and unless are checked, and only which is false, in that case unless code is executed, and once that condition is true, if is executed. The next one I write if 1 print block 4, unless 1 print unless block 4. So here the condition 1 means true, if will be printed, correct? We have printed if. Next we print 0 0 and block 5 and unless 0 0. So in this case again we have 0 unless block 5 is printed. Again goes if 0.00. So this is a real number. So again if we put this, let's see what happens. Again unless is printed. So because 0.00 is false. So block 7 we put undef. We definitely know this is a false. Undef is false. So unless will be executed, and that's correct. Now comes a good question that is going to tease your mind. If false, print if block 8, and unless false, print unless block 8. So this can come as an interview question to you. What happened in this case? Because it's special. Here, this quote within false is not actually a false. If you have come across the previous episode, there I have explained why. So in this case, the if block is executed. Okay, this false string is not actually a false. Okay, so that's why if block executed. And unless with true, block 9 will be executed. So here in both the last two pair of if and unless, here the string is valued true. Only a null string, which is a blank double quote, become false. Okay, that we have seen earlier. I'll ask you to try out such examples. So here also I have given the throughout example how we can use the true and false conditions in PERL. Okay, so all of these things, all of these individual blocks can come as interview questions. So we are done with this example. Let's move on to the next slide. We are entering the next section, which is loops. Here we'll talk about different loops in PERL. So first is a for loop. So this is very similar to the for loop that you have used in C. Okay, I assume that you have learned C because that is the very first language people generally learn. And in case you have not, I think this particular description is sufficient for you. So if you have any question, don't forget to put in the comment section. So here in this kilo block, we are going to the description. So the for loop has 3 counters. It is very much C style. Initialization counter, first counter. The next counter is the condition checking counter. Third one is the increment or decrement counter. So the counter, when we mention that counter must be increased or decreased. Otherwise it's not a counter, right? And the condition should be checked at each iteration or each step. Okay. This each iteration, the condition is checked at the condition checking counter. So the format is like this. We are using a code example here. Here we use strict, and before that we have the PERL installation, hashbang user bin PERL, my $I. Here we are defined the counter variable. Okay, for $I equal to 1, $I less than equal to 10, I plus plus, and we print I and we close it. So I'll ask you to try out this code at your end. Okay, in the similar way that the hello world has been shown in the previous episode. So in the same way, you write this code in a text and then make it executable and execute in your shell. In case you are using a Windows system, there you source it as a PERL, then space, then the PERL file name in the Windows PERL shell. Okay, so here it's very much similar to the C structure, C for loop structure, and here we have 3 counters. We are done with this slide. Next we come for each loop. So guys, if you have you have not came across the for each loop, so here you will see the for each loop, which is very different. For loop is very similar to the C programming for loop, but here it is different. For each loop operates on each element of an array. I have not discussed the array or any part of the data structure till now. It will be discussed in upcoming episodes. So here the for each operates on each element of the array. This array may come from the keys of the hash, which is also called as the associative array. Some array operations, that is reverse or sort, are allowed in the for each loop itself. So when we are using the brackets, we are using the array, we can do some array operations like reverse or sort, okay. Default variable can take place if the element is not specified. So this array may be default array of arguments. So when we are having arguments, right, @ can be the argument. So that can be used as an array in the for each loop. So the structure of the for each loop is like for each, then element of array. So the element is a variable here. So it will be a $element when we are writing the for each loop. We will see in the next example, okay. And array means this is a @array. Some array will be there, okay. Statements on each element. So on each element, whatever we want to do, we will do here. Here we are printing it, print $element, okay. We close it here. And the next format is for each of array. So here we have omitted the element. Here what we see in previous episode, we have shared that there is a default variable. So $_ takes the place of the element here. And here we print $_ and we close it. This is the second type of application, helps your program to be much more faster because there are less number of variables, which means that you are consuming less amount of memory. So if the default variable is used, default variable anyhow there it is, but it is not used. But if you use it, so you are using less amount of memory. This is one more thing that you have learned in this particular slide, and let's see some examples. Here starts our code in this pink block. Hashbang user bin PERL. We are using strict my $le. We have defined it but not initiated it. Here the array comes from the output command of ls. So ls is a Unix command. Output of the ls will give the resultant array. Foreach $le, and within the first bracket we write backtick, within backtick, 2 backticks, ls star.pl. So this, if we execute in a Linux shell, will list out all the PERL files, .pl files in that particular directory. For your testing purpose, you can use any file extension that you presently have in your directory. And here then we do what? We print $le and then \n. So this will print at each new line the particular file name, and then we close the for each. So this is a very simple example of the for each loop where the array is generating from the system command. So why I have given this particular example, because in VLSI automation, multiple times you have to use this kind of arrays which are coming from your Unix shell, so that you have the files and you are operating on each file. Say you are sourcing or changing some Verilog files, there is a number of Verilog files in a design, so you are operating on the entire directory. So one by one they will be called by this example. So this is quite of application oriented example, so that's why I have given here. We're done with this particular slide and let's move on to the next one. Here again we have another example, starts with the hashbang user bin PERL. So use strict. So here just before starting the code, sometimes I mentioned -w and sometimes not. So it's not specific to the particular code. Okay. So general practice, it's good that you always mention the -w. That PERL will warn you if there is some compilation error or something. Okay. So here let's come back to the code here. And here we have defined our custom array. So that is my @fruits is equal to, then array elements are orange, apple and mango. I'll go in detail in the array in the data structure part or episode. Okay. But for now you just live with it. Okay. $myFruit and then for each $fruit from @fruits. Okay. So from the array of fruits, each element will come to the $fruit and we can then print it and then we close it. So this is a very simple, that you have defined the array with proper structure and then you are one by one iterating on the array element. So the beauty of this for each loop is that when you use the for loop, right, you generally operate on an index of an array. But here once you use this, right, you don't have to care about the index. If there is a case where you have to iterate by index, you have to use the for loop instead of for each loop. And if you have no restriction of moving by the index, then you can use the for each loop. So this is the basic difference of for and for each loop. Why I have said that, because in C you don't have this concept, but in PERL you have this concept. So that's why I have mentioned here. Okay, we are done with this particular example. Let's move on to the next one. While. Here goes our code. So first, while the condition is true, the block executes the statements. Use next or last as needed. In the later part of this tutorial, okay, we'll show that how next and last are used. So until then you just live with it. in today's episode only this will be discussed. So here goes our closure of the while block, okay, and this way we can use the while. Another way of there is a condition true and there is a counter if there is a exhaustive counter, right? So this is typically associated when you are operating on a file line by line basis, okay? We have a file handler until that has exhausted. That's why generically I have written until the counter has exhausted the execute statements, okay? Increment or decrement the counter as needed and use next or last as needed. So and we close it. So these are the two type of while application. Here I have just generically said that specific example will come later. So you can see the structure of while is very much similar to the C structure. Let's move on to the next slide. Here we are done. Do while. So do while happens that do comes at first, then we execute some statements while the condition is true. So this is very similar to the C structure. So nothing more to talk about, and you try out with different condition at your end. So do execute some statements at increment, decrement, and while the counter has not exhausted. So this is a second type of the do. So you know the basic difference of do and do while. So here it is the same philosophy. I have mentioned the formats. We are done with this slide. Let's move on. So until and do until. The until loop continues executing as long as the test condition is false. Some slides back we have seen a negated condition of if, right? Here, if we have a negated condition of while, that will be the until loop, okay? The until means this loop continues executing until the condition becomes true. So here, until the condition is false, once the condition becomes true, it will stop. It executes statement, next or last can be used here. Do until is like this, execute statement, next or last, and until the condition, okay? So this is a very much negated condition of while. These things will execute until the condition becomes true. Here we are done with this section. Let's move on. Loop control. Here we'll talk about next and last. So if you have learned C, you will you know that we have two keywords, break and continue. Here these are the very much similar thing, because we know that we have full control over for loop, but in while loop we may somehow enter into an infinite condition. Sometimes we need to break into the loop. We need to, or in any of the loops we need to go to the next iteration by skipping one particular iteration. For these purposes, this next and last easily mapped with the continue and break. So these feature comes from C. So let's see the definitions, okay? So the next and the last operator allow you to modify the flow of your loop. It is not uncommon to have a special case which you may want to skip, then use next. Or you have a special case which you want to quit. When you encounter it, use last. So these are the basic definitions of next and last. So let's see how these are used. So here I have generically written for each, while, until. So any of them can be there. And if condition 1, next. So control goes back to the loop counter. Else if condition 2, second condition is there, last. The loop is broken, you have come out of the loop. Else, print $element. And we close it here. So here we have seen how the next and last can be used inside any of the loop for each, while, until. So you just have to couple it with the if-else condition to test the condition accordingly. As we have the inline if condition, if there could be an inline next condition. So there will be next, but in that case we cannot combine both, okay? To combine both next and last, we have to use it in this way. You have unique cases where you want to have the control as per the requirement of the next and last, you can use the inline. Here we have closed the entire loop here. So we are done with this section. Welcome to the third episode of Perl programming in VLSI. In this episode, we will discuss about basic data structures in Perl, array, also called list in Perl, various way of array creation, accessing the array or the list, array of array, sub-array, also known as array slicing, various array operators, context, concept of scalar and list context, and context examples. This is a menu for today. Let's begin. Data structure in Perl. So beginning here, I would like to emphasize one thing. In Perl, basically the data structures generically called list. Specifically, let us see what are they. So the data structure in Perl are subcategorized in two particular parts. The first one is array or list. It is most of the time called list or array. Array is the more generic term. In some text you will find it is referred to as a list. And the other one is associative array or hash. It is more like a hash table from general data structure. So it is a mapped key and its corresponding value are mapped. So this is called associative array. In today's episode, we'll be mostly discussing about the array or list. In next episode, we'll explore the associative array or hash. The list or array. Let's begin knowing about the array or the list in Perl. Array or list variables always start with the @ symbol. Like scalars start with the $ symbol, always array variables start with @ symbol. Array or list are variable length. Unlike C, in C language where you see your array, when you define it, it has a fixed length. But in Perl, you do not have any such restrictions. So when you declare an array, it remains variable length. So you don't have to declare any length of it. Okay, you just define it and you can go on. Array can be declared without length, just mentioned. Okay. This length can vary even after creation. So that's why I mentioned that you just define an array and dynamically it can increase. Array or list can contain any sort of scalars. So the first episode we have discussed about the different types of scalars. So they can be all packed together. So even a combination of strings, numeric, etc. So that means different types of scalars can be packed into one array. Array elements are written in parentheses. I am not talking about here the array variable, but the contents of the array, they can be written in parentheses. Use my whenever creating the array or list. So we use useStrict module, right? So that restrict ourselves to use my every time whenever we are creating any new variable. This slide is complete, so move on. Creation of list or array. The first line here we have written my @array 1, 2, 3 in the parentheses, and we hit a semicolon here to terminate the line. So this is homogeneous type of data. Now in the second line we have the same array name, my @array. We have orange and 2.7. So this is a heterogeneous type of elements in the array. One is a string, another one is a real number. Both type of arrays can exist. Okay. And here the third one is my @array equal to, within parentheses is $B 21 then $C. Now these $B and $C are scalars which we assume we have already defined before we are declaring this array. And once we do that, this array will contain the corresponding values of $B and $C. My @array is equal to empty parenthesis. So this is basically an empty list. This mentioned, so this can come as an interview question. Good to know about it. The next one is my @array is equal to, within parentheses we use 1.5. So this means this will expand it as within parentheses 1, 2, 3, 4, 5. The next one here is my @array. The first element is 1.3. That means 1 up to 3 will be here. Then 7, then 11.13. So the whole array will come out as 1, 2, 3, 7, 11, 12, 13. So this is another way of creating an array. My @array is equal to $B $C. The range determined by the values of the variables B and C. The next one is my @array. Within double quotes we are writing apple, comma, orange, then comma, then jackfruit, and then grapes. So this is another type of array where the elements are strings. Now my @array is equal to QW. QW is a function called quoted word function, which will break whatever is given as an argument with any of the white spaces. So here the arguments are apple, orange, jackfruit, and grapes. So each of them are space separated. So it will create the same array just we have written in the before line. So we are done with this particular set of examples where we have shown how to create an array. Let's move on to the next section. Accessing an array or list. Each array element is accessed as $array, then the index. So when we are defining the array, we are not using any fixed index, but these array values can be accessed with index. Okay, and this is how, because each array element is a scalar, so we start with $, and then use the array variable name, and then we within the rectangular bracket mention the index. Index is not the word index, rather than 1, 2, 3, 4, 0, whatever the index in integer form, they will be used. my $ref equal to \array. This gives the reference, or better we know as a pointer to an array. $ref will contain the pointer to this array or the reference to an array. My $length is equal to scalar. Scalar is a function basically, and within parentheses we write @array. So this gives the array length. That means how many elements are there in this array. My $last index equal to $hash, then the name of the array variable, that is ARR here. So this gives the index of this last element of the array. So in this line I have just a typo. I missed the semicolon here. There should be a semicolon here when you are writing this statement. So this gives the last element index of the array. $ARR, and within rectangular bracket we mention -1. This gives the last element of the array. Negative indices count backward from the end of the array. If you increase the negative indices, right, so they will give you the array elements one by one from the end point towards the beginning. My @array is equal to 1, 2, 3, 4. 4 variables in array. My $LE1 is equal to $array0. So LE1, that is this particular scalar variable, gets 1. So this is how you access one array element and save the same value into another scalar. My $LE2 is equal to $array index is 1. So in the same way it will get 2. Now, if I write the thing here, in parentheses, I write $array0 and $array1. And then in the right hand side of the equal to, in the parentheses, I reverse the position here, $array1 and $array0. This will swap the two elements in the array. So these are a few ways to access the array elements. So we're done with this section. So let's move on. Array of array. So here we will talk about the very simple way of nesting arrays. Very, very simple format. Obviously, there are different depths of these things. They will come at the later episodes, not here, because the purpose of this episode to make you aware of the basics of the array, and the advanced level nesting will be covered later episodes. So let's begin with the basics array of array here. So my @array1 is equal to 1, 2, 3. This is the first array. And then we write array2 is 4, 5, 6. Okay, easy. Okay, so now we write my @array3 is equal to, within parentheses, array1 @array2. So command merges array1 and array2. They are array of array. So array3 is array of array in a very simplistic format, where array3 is the merged format of array1 and array2. Again, here my list1 is 1, 2, 3, 3 values. And my list2 list1, all 3 values are copied. So this is another, I think, operation here. What we can do directly, you can copy one array into another in this way. Okay. Now, what we are doing at list3, so we are writing list3 equal to 4, 5, then comma, then @list, and then comma 6. So at the third position, here we have inserted another array, that is list2. Here it will get expanded and they will contain 6 values. Okay, list2 will be expanded. Since this is a very simplistic manner of array, the expansion will happen here. So we are done with this particular section. Let's move on to the next one. Subarray, or sometimes it's called slicing. Let's see. My $array is equal to, within that is quoted word function, and within parentheses we write apple, orange, jackfruit, grape, and mango. In the first line, I think there is a typo here. It should be, I think, @ symbol rather than a scalar. So @array24 is, when we write, it's not a 2-dimensional array. It is $A2, that is array2, and $array4. This is, I think, called subarray, right? Here, when we write 2 and 4, it contains indices points 2 and 4 of the original array. So when we write my @subarray1 is equal to @array24, that means it will pick up jackfruit and mango. Okay, the subarray will contain jackfruit and a mango. So this example actually clears out the concept. And then here, where we do the subarray2, okay, my subarray2, and we write @add, then within the rectangular bracket we write 2.4. It is actually expands as a jackfruit, grape, and mango. So you can see the first line there, and here you can see how these subarrays are defined. So as the first line contain a typo, instead of $add, there will be @add. So make sure that is corrected when you are typing the code in your text. Okay, that's all with this particular section. So let's move on to the next one. Various array operations. So here, the first one is push. Push is a function that is operated on any array. And how we operate that the first argument is the array itself. Here it is at the list, and then there is a new scalar value. It could be a variable or it could be the value of the variable. Okay, so $new we have written here generically. So this adds one element, that is $new, at the end of the list or the array. So here the entry is from the backside. Now if we want to do the reverse action of it, we do $old is equal to pop, then at the list. The value which was entered from the backside now will come back to the $old. Okay, push and pop are exactly opposite in usage. So one helps to insert one element from the last point and another one removes the last element. These two are done, and let's move on to the next. Unshift. So here what we do, we mention the $list and then we write the new scalar. Okay, so $new. So here the new element, the $new element is added from the beginning in front of the 0th position. So that's how a new list will be created when we assign this to a new array. Okay, so it actually operates on the list itself, and at the 0th position there is a shift and one new element is added. Now, if we want to do the exact opposite action of this, what we do old equal to shift at the list. So it exerts, okay, or removes the leftmost value. Fine. This also can be achieved with the notation written at right hand side, that $old, comma, $list is equal to at the $list. And the previous one also could be done with the at the list equal to $new at the list. So these are another way of doing the same thing. It's up to you which one you use. The next one is reverse. We write array is equal to reverse, then at the array2. So array is at the array becomes the reverse of the array2. So all the elements, the order from beginning to end is reversed. At that array is equal to sort array2. This sort happens on the array elements and the outcome is ASCII or alphabetic sort order. So later we have an example, we'll see how things happen here. So here at the rate sorted is equal to sort $, then within the curly braces we have $A less than equal to greater than $B. So this is special notation or called a script to the sort, and this $A and $B need not to be declared in before. So these are reserved variables. In the first episode I have talked about these variables, and now I am showing the usage here. And then at the right hand side we have unsorted array. So this sorts the integer or the real values in ascending order. Now, if we want to do reverse order of this, so we do what? Sorted equal to sort $B less than equal to greater than $A, and then the unsorted. This sorts the integer or real values in descending order. So these are two very good questions, and they can come as an interview question sometimes. Okay. The next one is chomp at the array. So this chomps each element of the array. So it's worth of trying out. So you define and try out all these options. We are done with this particular slide. Let's move on to the next slide. An example. Here the array of portions, I have summed up them in a particular example, and I'll be showing you. In this pink box the code goes, and the black box the output will be displayed. Start our code with the first line with the PERL installation hashbang user in PERL. Then we use useTrect, and then my list at that. Then I write the values 1, 3, 6, 2, 5, 4. So they are in a jumbled up order. Now I print this, it comes as the same. Okay. Now what we do, list sort at the list. Now what we are doing here, we are sorting the list and taking the outcome in the list. We again print this. Now what we see is that they are sorted in orderly manner, 1, 2, 3, 4, 5, 6. Now this sort is, I mentioned ASCII sort, right? Now you may confuse, okay, these are sorted numerically. No, so you will see later. Here we have list equal to quoted word small, medium, big, and we print it, it says small, medium, big. And here when we use sort on this list and outcome again we save on the list, what happens? Print out big, medium, small. So you see they are now arranged alphabetically, that is in the ASCII order. B comes first, then M, and then S. So the first letters are there. If we have a different kind of dictionary words, they will be sorted as per the alphabetical or the dictionary way. Okay. So here another list is fine as 1, 2, 4, 16, 22, 13. So now just before I was pointing out at this point, in this example we'll see. So now we print it. It comes as a jumbled up order. Now we apply sort. what happens? Let's see. Now it sorts the ASCII order 1, then 13, then 16, then 2, then 22, then 4. So you can see 1, after that comes 1, 3, then after then it comes as 1, 6, then comes 2, then comes 2, 2, and then 4. So this is a ASCII order sorting. If you get confused by the first example of this code that the code is sorted in a numerical way, no. This is actually this sort only does in ASCII order. Okay. In this case, our values were such that they were sorted like that. But once we change the values here, we see that it is operating in a different fashion. So this is ASCII sorting. Now for numerical sorting, what we do? We introduce this particular method. So here at the list equal to sort, and then the script comes here $A less than equal to greater than $B. And again mentioning these $A, $B are reserved variables and need not to be declared any point. Okay, at the list. So what happens when I print this? It sorts in a numerical order, in an ascending order. Okay, 1, 2, 4, 13, 16, 22. Now if we want to sort it in a decreasing order, what we have to do? Or descending order. Okay. So we write list sort where $B less than equal to greater than $A. So we switch the position of $A and $B. Okay, this is the script at the list, and then we print. Now we see 22, 16, 13, 4, 2, 1. So these all the integers now sorted in a descending order. With this example, we have clarified the different sorting functions, and it is worth to try out. And let's move on to the next slide. This section will talk about context. So another thing before beginning here, context here is very important, this section, because this is a very crucial aspect of PERL variables, how they are used. So that's why this section I have included. So in between the array and the hash, let's start the section to see how it is important. Scalar and list context. In the yellow box, our definition and code will be there, and black box, the output of the particular code will be shown. Here, PERL has a notion of different context in which evaluation can take place. So in PERL, when we are evaluating, there could be different contexts. Which are these contexts? Number 1 is scalar context and number 2 is list context. Now when I mention list can contain either array or hash. Okay, so scalar list and list context, these are two contexts. One is a scalar and the list context. Okay. Things behave differently depending on what context they are in. I will exemplify later in this particular slide only, so you will see that. Okay, an expression is in scalar context if the value it generates will be used as a scalar. An expression is a list context if the value it generates will be used as a list, that is array or hash. It depends how we are storing the outcome, that is called context. My @things, here one array is defined, heterogeneous array here, peach, then 2, then apple, then 3.14, that is the value of pi. So this is a heterogeneous array. So what do we do? Now we define 3 different variables, thing 1, thing 2 and 3. First we are at thing 1, which we equate with things. Second, $thing2 is @things. The third is we write within parenthesis $thing3 is equal to @things. Now, why we have given these 3 things, I'll print them one by one and I'll explain. The first one, thing 1 is a list context. The outcome is here stored as a list. Next one is a scalar, but here it gets the count of the elements. How many elements are there? It gets the count. And the third one here, it gets a subarray, that is the peach, the first element here, when we use it in parenthesis. So here we are taking the outcome of the same array in 3 different fashion, and in 3 different cases we are getting the 3 different values. So this is the importance of the context. So that means how we are storing the outcome. At different context, the value will be different. Keep this in mind. This can come as an interview question. That will be very helpful to you. So we are done with this particular slide. Let's move on. More on context. Here, so we write my, then within parentheses I write first, comma, second. There are 2 scalar variables here equal to @array. What it will do? The $first and the $second are assigned to the first and second element of the array. So this will happen that those values will go into the first and the second index point values of the @array will go into $first and $second. Now, if we change the second one with @ symbol and name it with a different array variable, that is @array, that is rest, @rest. Okay. So here the second one changes and the right hand side is same here. What it will do? $first is assigned to the first element of @array, and @rest will get the rest of the elements of the array @array. This is how the thing will behave. So now you can understand the context in much more clarity. Now the third one, here we have swapped the types here. First one we keep a array @copy, and the second position we keep $dummy. Okay. Now what will happen at the array? Any guess what will happen? The immediate thing that comes as a derivation of the first one is not going to happen here. In this case, the dummy is not assigned. Array are variable length in Perl. This is the first thing that in this episode I have mentioned. So copy has no reason to stop for copying the array which is in right hand side. Now what will happen to $dummy? The $dummy ends up with the undef value since @copy eats up the entire available array. This is the usage of the context. So how we are placing things in the left hand side when the right hand side is a array on list. Things will be different at different cases. So these are different contexts. You have to remember them very carefully when you are coding in Perl. And these context related things comes as a very frequent interview questions. I think that also covered in this particular episode. Welcome to the fourth episode of Perl programming in VLSI. In this episode, we are going to discuss overview of associative array, that is also called hash, creation of associative array or hash, accessing hash key and value, hash functions for various operations, array and hash mutual conversion, reference in Perl, backslash operator and ref function, referencing and dereferencing, creation of unnamed hash. So that's the menu for today. Let's begin. Associative array or hash. An associative array or hash is an array of scalar values associated with subscripts or index that are not 0, 1, 2, 3, 4. Now, this is very different from the regular array that you might have seen in C programming language, because there array only has index starting from 0 and increasing by integer. Here, the index could be anything. Let's see how it is. Here, subscript or indexes are any scalar values with no particular order. That means there could be integers, they could be jumbled up. There could be strings also, or mix of integer and strings. So anything could be there as an index. These subscript values are called keys. Corresponding array elements are called values. So here we map one key to one value. So the mapped data is called value and the index is called keys. A value is mapped to its corresponding key only. Thus, a hash is a table of uniquely mapped key value pairs. Generically, it is called a hash table or hash. This means when you have a hash, you cannot have two entries with the same index. Okay, you can have only one entry with one particular index, whether this index is scalar or this index is integer or any mix up of these two. Next point, hash variables always start with a percentage symbol. So when we are declaring a hash variable, obviously this is a variable and we have to define at the beginning. So when we define at the beginning, we use the percentage symbol for identifying it and as per the Perl syntaxes. So this slide is done. Let's move on to the next slide. Creation of an associative array. So how do we create an associative array? Let's see. Entire hash variables, key and value, can be referenced using the percentage. So the first type, how we create a hash, we'll see how we create an entire hash. We write my percentage hash, then write equal to, then open a first bracket, that is, and then we put a pair. First one here, name within double quotes is the key and Billy is the value. The similar way, we put more pairs, age 21. Then occupation student, and then we close. Okay, so here this is one way we can create an entire hash at once. Similarly, another syntax we can use here is my %hash is name. Then we use the mapping. This is a mapping symbol that is equal to, and then there is a right arrow. Okay, this is a mapping symbol. Name is the key and Billy is the value, mapped value. So name arrow Billy, and then age arrow 21, then occupation arrow student, and we close the hash. So this is another representation of to create the hash at once. Now let's see how we can create a hash with individual hash variable entries. So to create a hash by declaring individual entries, this way we can do it. We write $hash, then within the curly bracket or the second bracket, we put within quotes the key name, and we put a equal to sign and then equal to Billy. So this, now we are using the second bracket and not using the third bracket. That is a rectangular bracket. This is a bit different. Why I am talking about the third bracket here? If you recall, in array, when we are putting index, we put the third bracket there. This is a very much different from the regular array. So here the second bracket or the curly bracket comes into the picture, and we put the index. Here the index is name, the index is also called key, and the corresponding value is Billy. In the similar fashion, we write $hash, then the next key is age and its value is equal to 21. And then again, occupation key and value is student. So this way, when we define by each element, we can create the hash on the go. That means we are inside a program, we have declared a hash somewhere in the top with no value, but later on, we are getting this key value pair somewhere later in the code, and one by one we can populate the hash key. Okay, so this is a very useful thing. The previous one is also used in some cases, and you can use either of them as per your requirement. This slide is done. Let's move on to the next one. Accessing hash key value pair. When you know the key, so there could be two scenarios or three scenarios. So first scenario is when you know what the key or the index is, how you get the value. This is how. So you print $hash, then you put the key inside the second bracket or the curly bracket, and you can print it or store it in some other scalar value. Okay, so this is one way. Similarly, we can put the key age and it will print 21. The previous one, it will print Billy. Third one is we put occupation as the key here, $hash, then within the second bracket occupation, it prints this student. So if you remember last page where we have discussed just that how to create a hash, creating one by one a key value pair, in the similar way, we can access them in one by one manner. So this is one thing. Case 2, when you do not know the keys. Say you have in program, say one module is talking to another module, and that first module created the hash, but the second module do not know what are inside that hash. Or the hash is dynamically created and one by one it got populated. So you don't have idea of what all the keys are. Then how you access the key value pair of a hash? This is how. So first is that you write an array, my@array equal to keys %hash. This will return all the keys into the array. You define on the left hand side. So keys is the function. It's operate on the hash. Now you write for each my $key, and in the for each counter we have @array. So one by one this array will be exhausted. That means key will come, every key will come to us, and we print $key equal to $key has a value equal to $hash, then within the second bracket or the curly bracket $key. So it will give the value, and we close the for each. So this will iterate and print the key value pairs one by one. So this is the case when you don't know the keys. We are done with the slide. Let's move on to the next. Third case, get the key value pair at once using each function. Each is another function for the hash table or the hash. Let's see how we can use it. We have to use while. While, then $key and $value. I am assuming here that I have used the my $key and $value expression defined earlier. Then here at inside while we write $key and $value within first bracket or braces is equal to each. Then we write %hash. Then we close the first bracket. And we start the while by the curly bracket. Inside that we print key equal to $key has value equal to $value, and we close it. So this is the way each function can be used in a very efficient manner, and this while loop will continue till to the last pair of the hash is exhausted. So this is another way when you do not know how many key value pairs you have inside the hash for a programming point of view. So this is the way you can access the key value pairs. So we are done with this section of accessing hash and key value. Let's move on to the next. associative array or hash functions. So far we have seen a couple of functions like keys, each I have just shown you in the previous slides. Let us see what all the hash functions are there and what purpose they are made for. Here we can see the keys returns a list of the keys. My @key array equal to keys %hash. So this will return all the keys. We have already seen that. I'm repeating again here because we are enlisting all the hash functions in this particular slide. Values return a list of values. Now we have used keys, but there is another function called values which can return the value in this way, that my @value array is equal to values %hash. So value array will now contain all the values. You can either extract keys or extract values. Okay, there are two different functions. Each returns a key value pair in sequence. So we have just seen that example only. Delete removes a key value pair. Now we have added a key value pair, but this delete command, if we use, it will remove the key value pair. Only we have to operate like this, that delete $hash, then within the curly bracket or the second bracket we put the key. So this will remove the key value pair from the hash. Another thing is that %b is equal to %a. %e is a hash which was created earlier and %b is a new one. So this copies one hash into another. In some cases we need to do such thing, for that we can use. This is one hash is directly copied into another hash. %a is equal to reverse %b. So this will do what? That swap the keys and values and they should be unique. Here when we reverse, whatever the key value pairs in B, they will be reversed. So the key and value places will be interchanged in the hash A, provided that each key value pair is unique. So we do not have a repetition. So that's what I mentioned, I think in the first slide, that in hash we cannot have a duplicate entry of index. That is the main theme always. So that will be applicable even if we do the reverse function. So that time values will become key and keys will become value. I think we are good to go to the next slide. Let's move on. Here we are talking about array and hash mutual conversion. So let's see. My @array %hash. This will convert a hash into an array. Not necessarily that in order, but always with the keys. Hash is a basically unsorted or unordered kind of associative array, right? So when we convert into an array, there will be no orders and values paired adjacently. Here, if you remember, initially we were placing one key and one value or to create a hash. When they are turned into an array, so keys and values will now reside side by side. So key 1 value 1, key 2 value 2 in this order. Then my new %hash is equal to array, converts an array back to a hash. So here one thing is that this array elements should be exist in pairs, so that we have pairs. So there should not be any unpaired thing. So there should be a pair, and the consecutive array elements will be treated as key value like that. So key 1 value 1, key 2 value 2 like that when creating the new hash from the array. So here if we write my %array is equal to then key 1 value 1, key 2 value 2, key 3 value 3. This is an explicit array, right? So and the left is hash. So it creates a hash from the list. It's an explicit example. Earlier was an implicit example. And my @array, okay, and another way is that then key 1, key 2, key 3 if we write, and then we write equal to at the right hand side we write value 1, value 2, value 3. It will create the same thing. Okay, these are the ways that we can convert hash into array and array into a hash. So I think we are done with this section. Let's move on to the next. Reference in PERL. Before beginning the entire section, this is a second section of this episode. Here we are talking about the reference. If you know the C language, right, there is a concept called pointer. In PERL, we can have the similar concept, reference. Let's see how we have. But in PERL, this thing is much more flexible to use. Reference in PERL. PERL allows you to have hard references to any piece of data or code. By this episode, we know that we have scalar, we have array, we have hash. So each can have one hard reference to each. Any scalar may hold a hard reference. One scalar can contain the pointer or a reference of another scalar or another hash or another array. Array and hashes contain scalars. So inside array or hash, there will be a list of scalars, as we know. The order is different in hash or array, but they contain combination of scalars in a different manner. Hence, one can now easily build a nested data structures. Why we are saying this? That when we have a hash element are now scalars. And if instead of those scalars, we have a reference presenting there, they could be pointed to another array or hash. That means we can create a complex nesting. Nesting in detail, I will discuss in the next episode. But before that, you must know how the references work in PERL in order to be able to do such nesting. Now, with the help of references, we can create array of arrays, array of hashes, hashes of arrays, an array of hashes of functions. Okay, so these all combinations and many other combinations can come into the picture. As we go on, we can have multiple combinations. Within third bracket items, if we put the items in a third bracket, makes a new anonymous array and returns a reference to that array. If we put array elements and left hand side we have a scalar, right, that will become a pointer to an anonymous array. If we use the second bracket and inside we put a list of things, left hand side of the equal to sign we have a scalar that makes an anonymous hash and it returns to reference to the hash. So if we have a left hand side we have a scalar, that scalar will contain the reference or the pointer to that particular array or hash, which is anonymous, that don't have a name. We have not explicitly declared it, but it exists. We are done with this particular slide. Let's move on. Backslash operator and ref function. Now, why we need a backslash operator? Here, I'll come to that point. Okay. By using the backslash operator on a variable or a subroutine or a value, typically creates another reference to that thing. So, backslash operator helps us to create a pointer or a reference of a variable, a subroutine or a value. Backslash operator is similar to the address of operator and % operator in C. So if you have covered the pointers in C, you know that and % operator, whenever we use that, it gives a pointer, right? So similar thing here we achieve with the backslash operator. So here, just for an example, $scalar ref, left hand side is our reference, is equal to backslash $foo, creates a reference of a scalar. Now, similarly, array ref is equal to backslash @argv. It creates a reference to an array. So argv, you know, already discussed in the previous episodes. It's a predefined array. And if we use the backslash in front of it and store it, want to store the reference, we at the left hand side, we have the array ref scalar. Next, we have the %env. And if we add in the backslash to the right hand side, it will give the reference to a hash. Constant ref. So here we have right hand side, we have written a constant 186_282.42. So we use the backslash operator here and we use the constant ref, reference to a constant. This will create a reference to a constant. Right hand side is not a variable. So it's not a scalar, it's not an array, not a hash, it's just a constant. So this will create the constant ref. The next one is the code reference. Okay, we have a code that is we have a subroutine which is named handler. Okay, and if we use this one backslash then the %& and handler, it will create a reference to the piece of code. This will create a code reference. Object reference. Object reference comes, okay, before explaining this line, I'll tell you something that in subsequent episode we'll cover the object-oriented PERL. If you know from C++ language object-oriented concept, particularly C++ or Java, so we have object-oriented concept. So there we need to create an object, right, of a class. So explain in detail of the concept, object-oriented concept later, but for quick know-how, this is how we can create an object. $object reference is equal to new. New is a function that will create an object of the class student with the specific arguments as name, surname and role. Okay, so this is how we create an object reference. There is an inbuilt function ref which PERL already have, which can check and return the type of the reference. So there are many types of the reference. For a programming purpose, when you explicitly writing these lines, you know what is there. But in case where you don't know, you want to check, you got a reference and what is the type of it. So that time you can use the ref function. Usage, how you can use, you just put ref and within the first bracket or the parenthesis, you use the $refvar. So $refvar could be any one of the above mentioned. I have mentioned 1, 2, 3, 4, 5, 6. Okay, 6 type of references here. So any of them, if you put right, this function will return the type of the reference. Okay, whether it is a scalar, it's an array or a hash, okay, or a constant, anything, it will display. So this is the general explanation. We are done with this slide. So let's move on to the next. Here I am discussing some of the examples. The reference function. Okay. In this pink, there goes our code, and in the black box, we'll have our output. Let's see our code. Starting with the hash bang user bin PERL. then use strict my $foo, and the scalar ref is $foo. Next comes the array ref $argv, and then next come hash ref %env, and then we have the constant ref. So this I have already just explained in previous slide, and in this code we are using. Now we print here, print \n ref scalar ref. You can see it prints in the right hand black box that ref then scalar. Okay, so you can see the scalar. Next we print the array ref, so it will print ref array. Okay, then we write print ref hash ref, it will print hash. So this ref function is one by one identifying each type of the reference, and then write constant ref. So here it is returning scalar because it's also a scalar value, the constant. Okay, so here this is how we are able to create any reference, and if we have a reference that we have not created, we can check the type. I have not shown about the object reference here because that needs a description of the object and the class to be created, so that will be done in the object oriented episode. So we are done with this section. Let's move on to the next. Anonymous referencing and dereferencing. We use a hashbang user bin PERL -w, use strict, then anonymous scalar, then we use $foo and two buddies. Okay, then we use the scalar ref, how I already explained, add a backslash on the right hand side of the equal sign, and then $foo. $dereference. Okay, now what is dereferencing? Dereferencing means we know the pointer, right, where it is pointed. We want to get the value inside that pointer. So this is how we are getting the value. This already for a scalar reference we have done. So now we put a $scalar ref. So $scalar ref is the pointer or the reference here, and we add another more dollar to it. Okay, so this $dereference, that is deref, is now contain two buddies. Okay, there is a small typo here because 2 came twice in the comment. Okay, sorry for the typo. Let's move on. Anonymous array. So guys, this for starting the anonymous array, I just want to explain that dereferencing means that by reference you will have an address which contains some type of data. You want to get that data, so you have to dereference. This is a simplistic explanation. Now, anonymous array is like we write $array ref is equal to, then within the rectangular bracket, right, we write 1, 2, then again we have a rectangular bracket within quotes A, B, C. Now, if we want to get the values of this anonymous array, we write my @array equal to, now we add @ symbol before the reference, okay, or the pointer, @ then $array ref. For anonymous hash, this is how the anonymous hash reference created. So my $hash reference then starts the curly bracket, and we have sky, then the arrow pointer, then the value is blue. Similarly, key value pair is rose and red, and we close that. And to dereference this hash, we use my %hash is equal to % then $hashref. So if I sum up, right, so whatever the reference type is, if we want to dereference it, we just add another, the similar type of symbol, $ for scalar, @ symbol for array, and % symbol for hash for dereferencing. So this is how we dereference an anonymous or a reference. Okay, anonymous array or hash could be we can say separately, but for scalar we have to say it's a reference. Okay, so any kind of reference we want to dereference, we have to use that particular % sign or @ sign or the $sign respective to each type of those reference. Done with this particular slide, let's move on. Dereferencing by arrow notation. So we have some more things to see in the dereferencing part. Accessing a value. So we can use $array ref, then array, then arrow, then 0. So this means that we have a array reference and we want to access the 0th index element of it. To print that, we can use a $array ref, then 1 dash and then 1 arrow. Okay, this is the two different keystrokes from your keyboard, and then within the rectangular bracket the index 0. It will print the anonymous array, the 0th index value. Okay, similarly for a hash, we write $hashref, then 1 dash, then 1 arrow, and then within the curly bracket, that is the second bracket, we put the key. So this will put the value corresponding to key of the anonymous hash. assigning a value. For assigning a value to the anonymous data structure, let's see. For array, we have $array_ref, then dash, then right hand arrow or right direction arrow. Then within rectangular bracket, we have 0 and we have set the value January. So this is for array. Similarly, for hash, $hash_ref, then $, then the arrow and then key and equal to value. So you see there is a striking difference. When we create a hash element for a general hash, we don't use this arrow operator. Okay, that is one dash and the right hand arrow. This is dash and not underscore. Keep it in mind. This is dash. This is how it is different for a anonymous array or hash and for a regular array or hash. Okay, so this is how things are different. This is why this pointer section or the reference section is getting covered, so that you can side by side compare the hash and array for the two type of its existence, right? One is the anonymous one, another is the regular one. So we are done with this particular slide. Let's move on. Unnamed associative array or hash. How we can have such array or hash? In pink box goes our code, in the right hand box goes our output. Start our script with hashbang user bin PERL, use script. We write ref hash, then we start it, and then we write apple, then we write the arrow direction. This arrow is different from in the previous page. Here we are explicitly creating, and then banana, then yellow. These are colors of the keys. Okay, so sky is blue and leaf is green. Okay, and then we close it. This anonymous hash is created. So you can see in left hand side, all these things do not have any code. So these are bare words. I have explained in the first episode. So these are bare words, can be used in keys. Now for each we have my $key, and then we have the keys. We directly actually creating here the array of the keys by using keys. Then we use %sign. Then we are using the dereferencing here. Then within the second bracket we put reference hash. And then we print $key and value will be printed as $ref hash, then arrow, then $key. So you see and compare, right? When we are declaring, we are using a different kind of arrow. When we are accessing or defining as anonymous, right? One by one, we are using a different arrow. Keep these notations in mind. This might come as an interview question. So we close the curly bracket here, and this is how we will be iterating over the hash. So if I execute the code, the values will be pop up as one by one like this. So key equal to and value equal to. So key value pairs will be printed like this. This is a tried and tested code. So try this at your end. We are done with this section as well as we are done with this episode. Welcome to the 5th episode of PERL programming in VLSI. In this episode, we are going to discuss nested arrays, nested reference array, equivalence of arrow operator, nested hash, nested referenced hash, hybrid data structure array of hash, hybrid data structure hash of array. And in all the above cases, why we should use the strict module. Okay, without any further delay, let's begin. So this episode is focused on the nested data structure. That means we have homogeneous nested data structure as well as heterogeneous nested data structure, as you have seen in the menu. So let's begin with the first case. Nested arrays. So this is a homogeneous case. Here, let's see. In the pink goes our code and in the black goes our output. So we start by the PERL installation. Hashbang user bin PERL-w. Okay, and then we use strict. So at the later stage, I'll show with an example why strict has to be used in all these cases. And another new module we are using here, use data : dumper. So this is very important module. Most of the time this comes as a pre-installed one. You can use it for all these nested data structures. How? I'll show in this example. My @nested array, we start writing and start a regular array with a open brace. That is the first bracket. And here inside it, the first element of the array is unnamed array. That is the referenced array, but there is no reference, which I have already explained in the previous episode, if you remember. Or in case you have not watched that particular episode, please go ahead and watch it. Here comes the next nested array, and it is also unnamed. The third one is also unnamed. So we can see there are different contents are there in the each of the unnamed arrays. And we close the array, the top level array, with this first bracket with the semicolon. We hit the end. So this is the way to define a nested array in very simple manner. Okay. Now, if we want to print this whole array, how we do it? We have used the print, then dump bar, then within the first bracket or braces, pair of braces, we used the @ nested array. So what this backslash operator do? We have already discussed in the previous episode, okay, in the references. So this instructs the dumper module to print entire nested data structure. This is the important. The dumper can be also used for any preliminary array or printing, okay? But it is much more needed in all of the nested, whether it is a homogeneous or it is a heterogeneous, we need this dumper module. So here, when we do this, the output as $var1 is equal to 3 different unnamed. They are very much printed in the fashion that we have declared it. This is the beauty of this dumper module. And many times you can use this dumper module for debugging such nested arrays or nested data structure. Now, if we want using a simple print command, now we know that each base killer. So we have to print it by $nested array, then 0, then 1. So these are the index numbers. 0 means 0th element. Okay, let me bring my mouse pointer here. This 0 belongs to the 0th element, means this first array. Okay, this first unnamed array. And then 1 means the 1th index. So 0, 1. So this comes into the picture. The next one, $nested array, this index 1 mentions that this points to this particular unknown or unnamed array, and here the 2 will print the 2th index. Similarly, we will print third one here and its third index. Okay, so once we execute it, we get the output as the 3 values. Let me bring my mouse pointer. So it is 0, 1, then this is 1, 2, and this is 2, 3. So this way we have printed these 3 elements. So this similar way we can print all the other elements. Here, one thing I have not shown in the code, that is how to use a for each loop to iterate through the entire nested array. So this is a task to you. You can try it at your end and keep me posted in the comment. So without any further delay, let's move on to the next slide. Nested referenced array. Previously, we have seen that we have 2 kinds of array as a simple array. One is a unnamed array, that is the reference array, and another one is the regular array. So here in the second structure, we will be using the nested array. Obviously, internally when we are declaring inside the array elements, they are always the unnamed arrays. In pink goes our code, in the black goes our output. So we start with the code with hashbang user bin PERL, and then use strict, use data : dumper, and we write as $reference nested array here. How we start it? Obviously with a rectangular bracket here or the third bracket. Now the first element is same as the previous example here. Second one is also same. Third one is also same. And we close it with a right-handed third bracket or the closing rectangular bracket. So this way we have defined a referenced nested array. So this is homogeneous nested data structure. This is absolutely okay to have such nested data structure. Now for printing the array as a whole, what we do? Yes, we use the print dumper command here. And here we don't have to use the backslash operator as we have defined it as a referenced array at the beginning. $ref nested array is pointing to a unnamed array, which is a array of array. So here it will print out the entire data structure in the way it has been defined. So to access them individually by element, similarly we do here as for the previous one. But here there is a difference. I would like to bring my mouse pointer into the picture to show you this point. So in previous episode we have discussed about this dereferencing arrow, which is very different from the declaration arrow operator. So this is a dereferencing arrow, and here we have to use in this fashion. So this is the referenced array and we are dereferencing by this arrowhead, and then third bracket we have the 0th index, and then for subsequent nested array we have the 1th index. So this way we are using. This would also again print the 1, 2, 3, these 3 elements here, and we get the output. But see the usage difference here, different from the previous example. Here we get Mumbai, then banana and printer, okay, as we have seen in the previous case. So here again your task remains that I have not shown how to use a for loop or a for each loop to iterate on the entire data structure. So that is a task to you. You can perform it at your end and try to create a similar output. Not has to be exactly similar, but it can go close to the dumper has been doing, okay. try out that. The order is not important. Whatever order you get is not important. If you see that we bring my mouse pointer here in the output, these go in the second one or these go in the first one, it's okay. But its order is not important. Whatever data is dumper is printing, try to do that with the for or the for each loop. Okay. So here we are done with this particular slide. Let's move on to the next slide. Equivalence of arrow operator. Here what we are doing, let me bring my mouse pointer. Here I have just discussed about this dereferencing arrow. So we have notation like this. So $array of array, then 2, then 2. Okay. So second index, okay, and then the second index is penetrating into the nested data structure. Equivalent is, so I have just changed the name, but the notation remains same. So then 2, then arrowhead 2. And again, if we see that here ref array of array, then 2, then 2. So here you get this, and the exact equivalent is if we put two dereferencing arrows here. Similarly, if we have this one 0 and 1 equal to 23, this is the getting the value and this is the setting the value. Okay, we are setting a value here, and we can do the same as this arrowhead operator. So now remarks is that this arrow notation which is shown in the right hand column easier to use for reading and visual interpretation. So it's up to you. You can choose in between any of them, whatever you feel comfortable. But as a general, the right hand, the equivalent column is mostly used in all of the cases. Okay, so we are done with this slide. Let's move on to the next one. Here in this particular slide, we are talking about nested hash. To start our code with hash bang user bin PERL -w, we use strict and then we use data : dumper. Then we use nested hash. We start the code with obviously it starts bare word key, and then we are using the arrow. This arrow is different. This is a declaration arrow. So Flintstone, there's an arrow, then we start the curly brace or the second bracket, and here we write again. We use bare word as keys. A lead is Fred, pal is Barney, and we close it. Okay. Next comes our next key, JSONs. Then we use the declaration arrow, and then we use lead as George and wife is Jane, and we use a quoted word here, that is his boy is Elroy. So key quotes needed here because there is a space in between his and boy. Okay. So we close this again. This is a typical structure of a nested hash. It is a very simple. Each key is pointing here to a new inside hash. Okay. So if you look here, let me bring my mouse pointer. So this is a hash itself. Okay. This itself is a hash. Now value to this key is not a single value. It's again a hash. Again, value to this key is not a single value. It's again a hash. So this is nested hash, and it's a simple declaration here. We are using % symbol for the declaration here. And we close the entire nested hash with the right hand first bracket or brace. Printing by element. There is a typo here, please excuse. And we have print $nested hash, then Flintstone, then dereferencing arrow, then lead. So this is the way we should write. Similarly, $nested hash, then JSONs, then dereferencing arrow, then lead. So this way we are accessing the nested elements. Okay. I would like to ask you to try out this code at your end. This is a tried and tested code. So you'll get the output. Printing as a whole, if we want to print the entire nested hash, this is a homogeneous nested hash or homogeneous data structure. Use print dumper, as we have seen. Use a backslash operator because here we are defining a named hash, not an unnamed hash. Okay. So this way we can declare and access a nested hash. Now let's look into the nested reference hash. So here we start our code by hash bang user bin PERL. We are using use strict and data dumper module, data : dumper module, and let's begin our code. Here, see the difference. Here we are defining the hash with a $ symbol. So this is a referenced hash, and here we are creating nested elements inside. So here again, this will be very same to the previous example. So Flintstone, then comes the internal hash, which is lead, and he is lead and Fred is the value. And similarly comes pal Barney, and we close the internal hash. Next comes the next key to the top level hash, and the lead and the George. We start here at the sub hash. Okay. And the wife is Jane and his boy is Elroy. Okay. And we close it, the internal hash, second hash, and we close the top level hash with a curly braces. So it's done here. And next, printing by element. So similarly, we have done this thing, and this is a tried and tested code. So try at your end. I'm not showing the output here. And printing by element, similarly here, because this is a referenced hash, we are using the dereferencing hash at the beginning. So let me bring my mouse pointer in. So here we can see that this dereferencing arrow is used at the beginning because this is a reference to a hash, okay, and we are dereferencing at the beginning to reach to the first key. In the previous example, it was not here because that time here it was a pure hash and it was not a reference, okay, it is named hash. And then we are again using the dereferencing arrow here again, so just to access the next sub key. This key again, then we are using this key. So this way we are printing this value red. So let me remove my mouse pointer and go to the next one. For the next internal hash, we access the elements again in the similar fashion here. And for printing the entire data structure, we use the dumper module and just use the $ref nested hash because here we know already we have declared it as a reference and we do not need to use the backslash operator. We are done with this particular example and this slide. So let's move on. Hybrid array of hash. So far, so good. We have shown that how homogeneous nested data structure can be created. So I have shown for hash of hash, an array of array in a nested format, and shown the two variants, named and another one is the unnamed. So that we have covered. Now I'll show you the hybrid array of hash. So we start our code here and write my @array of hash. This is just abbreviation AOH. Here I have just gone into the simple one, not the referenced one, but that can also be created. Here we start the internal hash here, then lead, then Fred. These are keys and values of the internal first hash. So the first hash completes here, then starts the second hash, and the lead is George and wife is Jen, son is Elroy, and we close it. Second is done. The third here, Homer, and then wife is Margie and son is Bart. Okay, so here close the third internal hash and here we close it. This is a concept of a hybrid data structure, that is array of hash. So here you can see, let me bring my mouse pointer here. Here at beginning we are declaring this as an array and we start the array and close the array as regular, and internally we are using unnamed hashes. The first one, the second one and the third one. There are three unnamed hashes which are the array elements. We are done with this particular example, first type of hybrid. Similar fashion, we can create the same structure by a referenced array of hash. Try it at your end. Have already the previous examples with you. And for printing, you can easily use the dumper so that you can check, dumper module so that you can check you are doing it correct or wrong. So we are done with this slide. Let's move on to the next one. Next hybrid structure is data structure is hash of array. So here we are declaring my percentage HOA, that is hash of array, and we are starting it. Here we are declaring the Flintstones, then equal to, then arrow. This is a declaration arrow, okay, not the dereferencing. This is a declaration arrow. Again, we define this as the next key and the value is array where the George, Jane and Elroy is there and the Simpson is there, Homer, Margie and Bart. And we close the array. So let me bring my mouse pointer in here for the clear explanation. Here we have declared a hash of array. This is a hash and we start an in like this. And internally we have these three keys, 1, 2, 3, and each of them is pointing to a unnamed array. The unnamed array, as we know, write like this and declare like this. Okay, so we have created three unnamed array. So this is the structure of hash of array. Try it at your end and don't forget to comment. The next one, I will recommend you for the further reading and further exploration, because data structure will be difficult to cover everything here in one particular tutorial. So I have shown you the very basic things, and for any further combinations, all this I will request you to do some further reading. All these links will be provided in the description. You can access from there, explore by yourself. Please don't forget to comment. So here we are done with this particular slide. Let's move on. At the beginning, I said that at the end we will explain why the use strict is very, very important for all this nested data structure, whether it is a homogeneous or it is a heterogeneous, okay, whether it is non-referenced or whether it is referenced. So any of the cases, why it is important to use strict module. In the first episode, I have explained the basic, the use strict module and all the things. That is a very basic. Here specifically, I'll put on focus on this nested data structure, the use of use strict. We start our code with the hashbang user bin PERL. This PERL code I have named in my hard disk that accident.pl. So by accident, if you do some mistake, you will come to know what this use strict can help you. So here we are defining $aref, and here we are defining the unnamed array of array structure, okay, here. And the second one goes here, third one goes here, and we close the top level array. And this is a basically referenced array of array. So here, if we do the print $aref, then 2, what the message comes in? The message comes in global symbol @aref requires the explicit package name. Did you forget to declare my @aref? Okay, but this is not what we have defined here. So for the print statement, we have done a mistake. In this particular case, is an intentional mistake. But if you do it in real time, this useStrict module will prompt you that you have done a wrong at line number 9. So if I bring my mouse pointer here, I have not declared the line numbers, but here this is the line number 9 as per my code. So here I have done some mistake. Here with all the previous examples, you know what to change. Execution, the next line comes in, execution of accident.pl got aborted due to compilation error. If you have done something wrong, this useStrict will point you in this nested data structure paradigm, and you change the print command to $print $aref, then we use the dereferencing arrow, then 2 and then 2. Okay, so this is the reason I kept this episode very simple. I did not complicate it too much so that you learn the basics. For advanced things, you can go and learn by yourself once you are habituated with the preliminary things. So this is a very common mistake, that you declare a referenced array of array, and when you are printing it, you are using it as a normal array of array, that is a named array of array, and here you are declaring an unnamed array of array. This strict module will point you out here that you have done the mistake, and where at which line it will also point. And if there is something mistake that you don't know, please check the PERL documentation. I think it will be there. And here we have rectified this with the dereferencing arrow operator, and then we are going like normal. We are done with this particular slide. Welcome to the 6th episode of PERL programming in VLSI. In this episode, we are going to discuss subroutines, also known as functions in PERL, declaration and definition of subroutines, passing and receiving arguments, call by value, call by reference, variable and fixed arguments, private and temporary variables, and finally, the built-in functions available in PERL. So, this is the menu for today, and without any further delay, let's begin. User-defined functions. Like many programming languages, PERL provides the user-defined subroutines. It is also known as function. These may be located anywhere in the main program. Subroutines defined in separate files can also be loaded via do, require, or use keywords. A function or subroutine can be called by reference using a code reference variable. Placement may be before or after the main program text. After is always preferred, but in that case, the definition should be done at the beginning. No type associated with the function name. So like if you remember that C, a function comes with the return type, but here PERL has a relaxation. You don't have to attach a type with the function. You don't have to attach. No argument list is given with the function definition. Unlike C, in C you have to provide the arguments in advance, what type of the arguments will be. In PERL, it is relaxed and you don't have to provide any arguments. No local subroutines. If there are two in the same name, then the first is overwritten. Okay, so there cannot be duplicate entries. In general, a function without an explicit return statement is called a subroutine. So this is a definition of a subroutine. And next point is there is really no difference in PERL's perspective in between a function or a subroutine. So PERL's provide the relaxation here too. Return statement is very similar to C++ or C language. Okay. Type of the data returned is relaxed, okay, as a function has no type associated. Few points earlier I said that PERL has relaxed the type of the function, and hence the return type variable is also relaxed. Both sides you are very much relaxed. So PERL function is this way, is very kind of in a flexible manner. You can define a function but don't define its types. Don't define its arguments. Later on you can increase or decrease the arguments as per your need. We'll see later on through examples. It may return a scalar or a list. As we have discussed the data structure, a function can return any kind of the value. So we are done with these slides. Let's move on. Declaration and definition. The subroutine declaration is done at the beginning of the code. I just mentioned in previous slide that you don't have to declare the entire body of the function at the beginning. Preferably you can do it later on after the main block. But what is necessary is that you define the function prototype at the beginning of the code. How? Let's see. It's our code is starting, so hashbang user bin perl -w sub do this. Okay, our subroutine name is here, do this. And how we are declaring the function is that sub, then space, the name of the function. And you can see here, there is no return type or any type like int, real, nothing is mentioned here. And there is no fixed amount of arguments are also declared at the beginning. So you are relaxed in two ways. That is, there is no return type or the function type, and there is no arguments here. So this is a very relaxed way, but this has to be declared at the beginning, the name at least. Okay. And then we use strict as usual, and then at a later part of the code, preferably after the main block of the code, the explicit or inflated definition is described. Now, how we differentiate a main and the subroutine blocks? Basically, we put a comment here and write the subroutines inside that comment block, and then we start writing the body of the subroutine. Okay, this is a general way. So once we reach to the subroutine block, we write sub, then do this. And here we are explicitly writing the function, or we are inflating it as whatever we have declared at the beginning. The sub, then do this, then there will be a pair of first bracket, and then we start the curly bracket here. And here we put all the necessary statements which are the function has to do inside this, and then we return the return value. So here even you can see that the return value has no type. So just a return function and then its return value. So you are very much relaxed if you remember your C lessons. So there you have to be very strict about writing all these things. Perl has given this relaxation. You can declare a function in very flexible way and later on inflate it as per your goal of the function. So we are done with this section. Let's move on to the next slide. Passing and receiving arguments. So this is a very, very important part of any function or subroutine. Here, arguments are passed in a form of list or array with parenthesis. If we provide 3-4 arguments, so it will reach inside the body as a array or list, whatever we call it. Example is how we provide the arguments here. My $sum is equal to and 2,7. So 2,7, two arguments provided, and here by nomenclature, it is shouting out loud that this is an addition function. So its purpose is to add. Okay. Inside the body of the function, arguments are received via special variable, which is @_. In the first episode, I have touched base all these special variables, and here I'm emphasizing on the usage. So when we split the @_, the elements are $_0 is the first argument, then $1 is the second, and it goes on. $hash and then underscore has the subscript of the last argument. So this is the way we deal with all the arguments. Once this list is exhausted, @_, any further values treated as undef. So undef is given to the values beyond the end of the @_ array. Means you are say accessing one by one and you reach the last element at the _, and then you try to proceed one more element, right? What you will get is undef. So this is the way you pass and receive argument. We are done with this section. I think it's very much straightforward. Let's move on to the next slide. Call by value examples. Here, few examples I'm showing. So hello, and then there is a pair of parentheses called as a void function. So this is a kind of void function. My $x is equal to first, my $y is equal to last, and then we use the function swap $x, $y. By the name, we can understand that it will swap the values. Okay, this is how we call by value. Okay. Another example is that my $a is max 2,3. So by name, we know that it will give the max value out of the two arguments. So that will come to $a. And another way of using it is that print, then max 2,3 plus max 4,5. So what are the two maximum numbers? 3 and 5. So if we add, this print statement will print 8. Okay. This is a way of calling a function by value. So in this example, however, I am not going in detail of the description because the functions, I think at this stage, you may you can write the code, okay, by yourself. And this is just for your knowledge purpose. I am sharing it here. And this is a very, very straightforward way. Now let's come to the call by reference. This is very important, and even this call by reference thing is very much popular also in C++ domain. So here, how in Perl we can call a function by reference. So here in this block our code goes, and here finally in the black box our output will come. So let's start our code. We start code with hashbang user bin PERL, and then we use strict module, then anonymous function. So here in this particular line I'll be showing the anonymous function, how to write an anonymous function. Here comes it. So my $coderef is equal to, we write the sub keyword, and then with the curly bracket we write print hello, and that's all. Only one statement is there. But here you can look that there is no name provided to this. So this is an anonymous function, and the reference variable, the coderef, okay, holds the pointer to this function. Okay. Now regular function. How we write a regular function and call it by reference. So this section will do that. So we write the function name sub, then new print, and then within the body we write my $x is equal to shift and print $x. So whatever argument we will give will come into the variable $x and we'll print $x. So instead of this we can directly use print $0 underscore, as we have just discussed a few slides back. So we close the body of the function. This is a normal subroutine is written here, and you can see there is no return value here. This is another relaxation in Perl. And here once we tie it with a particular reference variable, my $subref is the pointer, and that is equal to backslash ampersand then new print. So this variable now holds the pointer to this function. Okay. And how we call it by reference in both the cases. In first cases, we call it by reference ampersand $coderef. Coderef correspond to the first anonymous function, and then ampersand subref correspond to the pointer of the regular function. Okay, and there we have provided in the argument lol and then haha. So once the output comes, the first one gives the output hello, as we know it will execute by code, and the second one will give lol haha. So this is the way we do the call by reference. I'll request you to try out the regular function writing at your end, as I have explicitly described that by call by reference. So you do it by call by value. So in this section, we are going to talk about variable arguments in a function. As we have discussed in the beginning, that Perl gives a relaxation in how many numbers of arguments there will be provided. So we can flexibly write our code inside the body of the function to deal with such situations. So I'll exemplify here and start our code with hashbang user bin Perl, and then use strict and then sub add. Okay. And here we write my $sum is equal to 0, initiate with 0, and then we write a for each statement and operate on @_ and we pick each element in $le. And here we put a statement that sum is equal to $sum plus le, and we close the for each and we return $sum. So here we close the body of the subroutine. So here you can see that a subroutine add do not have any fixed number of arguments. So if there are 5 numbers are provided, it will add the 5 numbers, and if we provide only 2 numbers, then it will add 2 numbers. Okay, and if we provide 10 numbers, it will add 10 numbers. So all these arguments will be comma separated, as I have exemplified earlier. So this is a way Perl gives you a relaxation of variable arguments. Now if we write print, then we put a new line character and add, it will print 3. Here now we increased one argument as 3 and it prints 6, and here again we increased one another argument 1, 2, 3, 4 and it prints 10. This way we can play with the variable arguments in Perl. So we are done with this section. Let's move on to the next one. Fixed arguments and multiple return values. This is another variant. In the previous example, we have seen that we can vary the number of arguments. Now we have fixed number of arguments, but we can return multiple values. How? We will going to exemplify here. Here I start the code with the hashbang user bin Perl and then use strict. Then we write sub difference. Here we are making the difference in between 2 numbers. Okay. Then my $a, we write shift, and then my $b is equal to shift. So this will shift the 2 elements from the @_ array into a and b. And here we write if $a greater than $b, return $a minus $b. So this is the first return statement. Then else if $b greater than $a, then return $b minus $a. Else, the third case, return 0. That means here if it is equal, then return 0. So here we can see there are 3 different return statements provided inside one single subroutine. So this is how your arguments are fixed but multiple return values. So here we close the body of the subroutine, and now if we say print difference 4, 2 prints 2 and print difference 1, 5 prints 4. Similarly, if we give the print difference 1, 1, it will print 0. So this is how, guys, a Perl function can have fixed number of arguments, but we can vary the number of return values. So we're done with this section. Let's move on to the next one. Private variables by using my. Private means that these variables are very much private to the subroutine block and they do not exist anymore once we go outside the subroutine block. This is the intention of the private variables. So how we do that? When used inside a subroutine block, my $foo declares a foo lexically local. And similarly, my $wind or %get, they are declared list of variables very much local to the body of the subroutine. If we declare the scope of these kind of variables, whether it is scalar or an array or list, whatever, or a hash, so they are very much local to the subroutine. Once the execution exits the subroutine, these variables are no longer valid and they are lost. Okay. Similarly, we can initiate a scalar here, $foo, and then with a string, okay? And next we initiate my of OOS with bar. So these are different way of declaring a my variable. And here declaration with a my variable is not similar to that whatever we have done in the main block. It is very much here the purpose of my is to create private variables which are very much private to the subroutine block. So we're done with this slide. Let's move on. Temporary values by local. Now, private variables, they are created and destroyed within the particular scope. But if we have a variable already declared outside the subroutine block and we want to assign a local value to it, we can use the local keyword. And how, we are going to see in this section. When used inside a subroutine block, local $foo makes the foo dynamically local. Now, it could happen that this $foo has been declared already in the main block and it has some other value. But when we put a local word inside the subroutine block, it is very much local to that. And the values, whatever we manipulate here, are very much local. And similarly, we can deal with list or hashes, okay? Similarly, we can initiate local value. And also we can initiate local value of a list. And also we can initiate a local value of a hash key value. And we can also delete a local hash key value by using delete. Okay. So this is the way we can create a temporary variable inside the subroutine block using the local. Also, this can come as a question that tell us the difference between a my and a local. So at that time, you can exemplify using this one. I would request you to try out a code by yourself and print out the values in both the cases. So you can see that time how the outcome is different. Now let's move on to the next section, which is built-in functions. So Perl has a lot of inbuilt functions. Here in these slides, I'll touch base on couple of them, and there could be some further functions that are maybe development ongoing. So for that, you have to consult the official Perl doc. Built-in functions. Numeric function, what are these? Abs value, okay, and the cos, hex, int, oct, rand, sine, square root, etc. All these are numeric functions. These are already predefined in Perl. You can use them by consulting the Perl manual or Perl doc. Functions for list data. Grep, join, map, QW, reverse, sort, unpack, etc. For arrays. Each, keys, pop, push, ship, splice, unship values, etc. Function for hashes, okay? Delete each exist key value. So these, some of them you may have already encountered in previous episodes and some of them you are not. So it is difficult to cover each and every defined built-in function in Perl. But here I just touch base you so that you have a quick snapshot in your mind what type of functions you can expect there to be ready for your use in Perl. And later on when you need them quickly, you can consult the Perl manual and use them in your Perl code. Okay, so this is the purpose of this section. There are some more built-in functions. Functions for file handles, files or directories like chdir, chmod, chroot, glob, link, mkdir, open, rename, stat, unmask, unlink. So these are system commands, okay, and there are similar commands written inside Perl. So directly you can use them in Perl to serve the system commands. Those system commands which I am talking about, they are part of maybe your Linux, okay, or the operating system. Functions on scalar or strings. So we have chomp, chop, hex, length, oct, pack, reverse, sprintf, substr, transliterate. All these things are operable on strings. So they are also predefined. Okay. So you have the list here. I again emphasize that this is not the exhaustive list because that will be a huge thing to do. And here what I am doing is the touch basing on your mind. So I am anchoring into your mind what things are there in Perl and you can expect them to be ready for your use. Okay. For usage and the syntaxes, you have to consult the Perl manual or the Perl log. Perl log is very easily available online and you can also download a soft copy of it in your local use. For your PC or your office laptop, you can easily download it. Regular expressions and pattern matching. Okay. For regular expression pattern matching, you have m//pos, then qr//s/// then split, okay, then study. So all these things are for regular expression. So I have touch based couple of predefined inbuilt functions in Perl so that you can have a grip on them and they are on top of your mind. At the time of need, you can use them. Welcome to the 7th episode of Perl programming in VLSI. In this episode, we will be discussing all the file operations. And why the file operations is very important in VLSI is that when you are creating an automation, you have to run a tool and that tool will create some output. And you have to read that output file, check whether that file is existing at the disk, check that file has zero size or not. So these are the basic things. And an advanced side is that when you are writing a script, automation script in Perl for VLSI automation, you have to also dump an entire log like any of the EDA vendor tools which are run a command line tool and it gives output a log file, whether it is a plain log or it's an error log. Such kind of log you have to generate. So watch the episode till the end to cover all these topics. Okay, so without any further delay, let's begin. In this episode, we'll be discussing the basic file input output in Perl, shorthand file command, reading from a file two different ways, reading a file into an array, which is different from just what I have told. The next one is writing into a file, dealing with all the standard input-output handles, overall log files for a Perl script, globbing and Unix style file operation through Perl. So these are the topics that I am going to cover, and as I have briefed just starting this episode, that is the goal of this episode, and this is a very, very important episode. So watch carefully till the end. File IO in Perl. As you know, like in C language, you have some way of dealing with opening a file, writing something into disk rather than on your screen. So these you have come across only when you learned the C language. I assume you know the C language or any other basic language that you have learned. So in Perl, the file input output is very similar like that, but the syntaxes are different. Let's see how it is doing. A file handle is the name for an input-output connection between your Perl process and the input-output device. So what is an input-output device? Monitor is an input-output device where we see different outputs coming into our screen. Another is our hard disk where we are writing our files physically. So these are input-output device, and input device is the keyboard and the mouse. Both the standard outputs will go to the monitor, okay, while the standard input will come from the keyboard and the mouse. So these are all standard input-output. File handles are all uppercase to avoid all possible collisions with present or reserved future keywords. So whatever file handle we are going to use throughout the Perl are written in all caps. This is a convention. We have to follow it strictly. A file can be opened using the command open. Then within the arguments, what will be first will be the file handle, which is in uppercase. Then the mode of operation. So whether we are writing a file or we are reading a file or appending like that. The next one is the file name in the physical disk. It could be a full path of the file name also. Next, a file can be closed using the close command. As closed, then within the argument, only the argument will be file handle. So that will be sufficient. It's a good practice to always use a close to close the file handle so that you know that whatever memory or processes that you have involved regarding this file writing has been cleared once you exit the Perl script. Open returns non-zero on success, the undefined value otherwise. Okay, so this is just a return value of this open command. If the open involve a pipe, we'll see later what is a pipe. Then the return value happens to be the process ID of the sub-process. So these are return value. This you can check, okay, when you are running automation. So that's why I touch based here. when opening fails, it's never a good idea to continue. So you are trying to read a file and you got a jolt and you cannot open the file, you cannot proceed in automation. So you have to stop because there is some issue. Similarly, if you try to write and you cannot write, then it is not good to proceed, because if you proceed, all the processes and the LSF, all those will be blocked and resources will be blocked, and still your outcome is null because you cannot write anything. We will see how we can use the different file test conditions also, apart from the regular things that in Perl to tackle with such situation, to deal with such all these scenarios. Okay. Hence, we use die to terminate the program if the open fails. So this is a very useful function in Perl, that if you fail to open a file, whether you are reading, writing, or whatever you are doing with the file, so die will terminate the program if this operation, open operation, fails in any mode of opening. So we are done with the summary. Now let's go in details. Mode, here in this table I am describing that what are the mode strings. So you remember that I have shared 3 arguments in the open function. So there is one particular argument is opening a file in a particular mode. So here we are describing that. So the left arrow means we are reading a file, right arrow means that we are writing into a file, double right arrow means that we are appending to a file, and then pipe then dash means we are outputting a pipe, and then dash then pipe is inputting a pipe. And the final one is that plus then left arrow or plus then right arrow means we are both reading and writing a file. So these are the exhaustive list of file operation modes. So let's go to the next section. Shorthand open command. So let's see how we use the open. So generally we write open and then in. In I am writing because we are reading a input file here. That's why I am using the convention in. Then file name, read from existing file. The same thing we can write in a way, open in then left arrow, as we have shown this operator, right? This is a shorthand, so we are clubbing the 2 arguments. We can write this with a comma separated 3 arguments also. That is not an issue. But this is a shorthand people use. So that's why I'm showing it here. Then we write open, out, then right mode, that is right arrow, and then the file name. This file name could be not only the file name, and it could be that it's a full absolute path of the file in the disk. Okay. So here I have just shown that in when we are opening input file and out when we are writing a file. So this you can take as a convention, or say you are opening multiple input files, so you can use handle in1, in2, in3, and if you are outputting multiple files, so you can use handles out1, out2, out3, etc. So this way, by looking into the code manually, you can understand, okay, which are the kind of operation, whether it is input operation or it is output operation you are doing. So better you follow some such convention. If you have your own convention, you can use it, but otherwise you can follow this convention. The next one is that out double right arrow file name. This means that we are appending to an existing file. This is output pipe. This is how we write pipe, then the output pipe command. Okay. Or input pipe, in, then input pipe command here, then pipe. So these are all the shorthand open commands that we use. Okay. So we are done with this slide. Let's move on to the next one. Reading from a file. So how we do that? Let's see one example here. Reading from a file handle is accomplished by placing the file handle inside angle brackets. The line input operator are often called as the angle operator. How we write it? First we declare my $input. We declare the variable here. And then we write open input as a file handle. Then here we are not using the shorthand here. We are going explicit. So then comma, then open mode of operation, that is left arrow, and then input.txt. Carefully look that both are in the double quote. So you have to maintain this. Or is an operator, or is a conditional or, and then die. And we write in the message of the die is that cannot open the input.txt. In case you are opening from an explicit path, then you can mention the explicit path also. And $, will return the status. Okay, return status. Now we have done the first thing. Once the file is opened, in the handle is ready, what we will do? We can process every line. How? We write while, then my $line is equal to angle bracket, then the file handle input, and then we start the while body. And here we do whatever we want to do with the line, so that we want to split the line, we want to print the line, we want to dump it into another file, whatever we want. We want to print into the monitor, whatever we want. Next we close the block and we close the file handle, close input. You can see here when we are using the close, we are not using the first bracket or the parenthesis here. This is another kind of shorthand. But in the first case, when we are using open, there are multiple arguments, so we cannot do that in the similar way. This is just an explicit example how you can open a file in the input mode or the read mode. Okay, so let's move on to the next slide. As I have mentioned in the beginning of this episode that the file test conditions is very, very important. We can use die, but at least if we have used all the file test condition, all these conditions explicitly described in episode 2. So you can check out the episode 2. All these file test condition you can judiciously apply in your case. That's why touch-based, these if conditions, file test operators. So these are very important when you are dealing with actual file IO in PERL. These are important here. So I touch-based again. For details, you can go and see the description in episode 2. Let's move on to the next slide. Reading from a file. Here we just covered one example, and in this example we'll show another way how we can write the same thing, but there will be some shortcuts we will be using in this particular example. Not using any $line variable, so that is our goal. As usual, we start my $input and we use the 3 argument open, or we cannot open die, cannot open the input file, okay, and then we open our while. Now you can see that while, and we in the angular bracket we write input, and then we have the body. Here we can get the line in the $_, which is a default variable. So these default variables I have covered in episode 1. If you have not watched, please go and watch episode 1. And here practically we are using this special variable $_. And this actually lessens the number of variables and it actually makes the script faster. Okay. So here we are, this is how. And if we want to process further, we can operate on $_ in any way. Okay. And we close the while block. And then we can close the input file handle. So the file is closed. This is another less memory expensive file IO operation. So we are done with this slide. Let's move on. Reading a file into an array. So this is a very interesting thing. In data structure, we have discussed the array. Concept is here that each file is a collection of lines. Okay. So how we can put them as an array element? Let's see how. So as usual, we declare the infile variable and open the file handle here, $filename. So this is another way. $filename is a variable which contains the file name along with its path. So this is another way of opening file. Next, my $line is in file. We have stored the input file handle into $line, get the first line, and we write the @my@rest. Okay, in file is equal to get the rest of the file here. This is the way we can store entire file into an array. And then we close the in file. So this is the operation how you can get the file into an array. So we're done with this example. Let's move on. Writing to a file. So we write my $out as the convention we are using out when we are outputting a file. Open out, then the 3 argument operation, that is a right hand arrow is the middle. Okay, so this is a write operation, output.txt, or die cannot open the output file. Okay. For each my $i1 ... So this for each loop I have already described earlier. So this will start counting numbers from 1 up to 100 as an integer and with 1 at a time increment, plus 1 increment at a time. So we print out this line gets $i. Okay, so output file will get all these line numbers, and then at the end we place a \n operator so that the next output will go to the next line. Close here. All the output from this for each loop will be saved on the output file, and we close our file handle. This is a way simple, very simple to write a file in PERL. Opening the standard IO. So this is another important section, right? Why I am saying, because when we are dealing with a overall log of a PERL script, when we are doing the automation in VLSI, that time we have to be careful that we judiciously use the standard input output handle. So let's see how. Let's begin. Standard handles like STDIN, which comes from the keyboard, right? STDOUT or STDERR, these are the output display messages that goes to the monitor, right? Are opened by default. So these are predefined. So you don't have to define them. These 3 file handles are very, very predefined in PERL. Okay. So we can write print STDOUT, enter a number. So this will go to the monitor and print. It is same as print enter a name, but explicitly we can use STDOUT as a file handle. My $number, then within angular bracket we write STDIN, and once this line is executed in PERL, right, the prompt will wait for you to enter something from the keyboard. Print STDOUT, the number is that. Here it again goes back to the monitor and prints. Next, print STDERR, that is STDERR. The error has occurred. So this is for error and warnings, okay? So this is the way we can output the number. Now, when we try to create a overall log file, right? I'll be showing later how. These all handles can be efficiently used, especially the STDOUT and the STDERR. So we are done with this introduction here about the all stdio which are by default in Perl. Creating overall log file. This is a very important goal, right? When you are writing an automation script in Perl, you have done everything. The code contains everything that you need to do the automation. But one thing we lag is that we don't have a log file, and once there is a long execution happens, all the data that is displayed in the monitor is gone from your hand. So you do not know what happened. So if you give a debug print command, it is also gone. And more difficult factor, if you are launching your Perl script in an LSF, right? It's difficult for you to capture whatever is output. So how to deal with this situation? This is a very, very bugging thing when you are doing the VLSI automation. How? Let's see. It is necessary to create an overall log file when you run an automation script in VLSI that can capture the screen dump of messages. Well, these messages might come from the VLSI tools that you are running command line through Perl, or you are doing some Perl calculation and outputting something, anything, or something error has come out from the Perl script. So all these we need in a single log file or more than one log file, okay? Let's see how we can do that. So we want to capture all the errors and warnings. Use file :t QWT. So this file :t module is very important module. So if it is not by default with you, you can request your Unix administrator to install it from the cpan modules. This is the beauty of the Perl. So cpan contains hundreds and thousands of predefined Perl modules which you can readily use. So you don't have to invent the fire. So it is there. You can just use the fire to cook your food. So this is the very important. It does a T. So that means it's T like the Unix. So it also prints in your monitor and also dumps in the log file. Then T, open STDOUT, and then the operation is write operation, that's why here, and then my Perl script.log. So it will contain all the normal messages. And next we write T STDERR, then write, and then my Perl script.error.warning.log. So these two log file will capture the regular messages, the first one, and the second one will capture all the errors and warnings. So these errors and warnings can be from the VLSI tool that you are using also. So this is a very, very important thing that I have initiated in the beginning of this particular episode, right? You don't need to close them. They will be automatically closed. So once your Perl script execution finishes, all these log files will be there. Okay, so you can check in these log files in your text viewer, and you can interpret what has gone wrong or what has gone right. So this is the very important thing. Glob-ing, the next topic we are discussing here. What is glob-ing? Definition is the expansion of a file name argument patterns into a list of matching file names. So this is another kind of file operation. It's not the direct read or write, but we are dealing with files in a different way. How we do that in Perl? So my @files, then we provide the directory path inside the angular bracket, and then star.c. So wildcard searching. All the C files will be now go in the array files, okay? And then we can operate on each and open or close, whatever we want to do, okay? Another way do the same thing is that use the glob operator. So that is why we are seeing globbing. So glob, then entire path which goes in a double quote here, and then the wildcard. So home/docs, then star.c, all the C files will be saved inside the array. And then we can operate on each file. Say, just for an example, you are running a check on all the Verilog files that is inside in a particular design directory, and maybe you want to source them to some particular tool which they will be as input. So you can use this method to get all the Verilog files, including the top.v as well as the small blocks.v. All those will be captured. So you can then use the Perl to feed them into the actual tool. Okay. So this is why the globbing is very much important in file operations. So this is a different kind of file operation, but I am covering inside the episode because this is very much important in VLSI. Now, while my $file, then abc star.html. So this is another way of globbing. Output each .html file starting with abc. What we do? We print here. We can print like this. This is one way. So this is another kind of globbing, but here we are using the while. So this is not we are opening a file, that we are listing a list of file and printing them like that. Okay. And similarly here we can do the same thing with the for each loop, and here $file, each $file will contain each file, and we can print the name of the file. Okay, so here this is how we can do the globbing by different methods. This is how we get all the .b files inside a directory or .c files in a directory and iterate over them, and then for each file whether we want to open them or not open them or do some kind of sed or awk operation on them, that is up to you, that you can do. But this is the starting method how to deal with such situation when we have to do multiple things in Perl, deal with multiple similar type of files in Perl. So that's why globbing is important. So we are done enough talking on this slide. Let's move on. Unix style file operation in Perl. This is another way of file operation. I'm not talking about input output, but how we do. Let's see. So some commands are there in Unix we use for file manipulation, but the same thing we can do inside the Perl. How? Let's see. Unlink myfile.dat. This will remove the myfile.dat. Unlink star.o, then it will remove the star.o in Unix. So sometimes maybe we are compiling a C code and the object file comes, and the next run of the Perl script we may have to clean all the .o files there. So that time we may have to do that. Or you can use an unlink command at the beginning of your script. So you are using a static name of your log file. So if any previous log file is present, you want to delete it. So you can use this unlink command along with that log operation, log file operation I have just shown few slides back. This is one good thing of unlink. Rename old name and the new name. So maybe you want to rename your log file to the log.old, okay, or some other nomenclature you can use. So that time you can use rename. So I'm just giving a specific example, but it is not limited to that. But what is important in VLSI, I'm just emphasizing here. mkdir, then data files, then 077. So this is how you can create a directory and give a permission to it, okay, while you are creating. So this might be important because you might have to create a directory where all the outputs of a particular tool run will go. Okay, so you are running a tool which will create several files and they must go in a particular directory. So that time you can use the mkdir. RMDIR is another thing that previously created directory you want to remove, which is not important for this particular run of your Perl script. You can use RMDIR. And chmod, then the permission number, right? And then the program file. So it can give a permission. You are creating some kind of executable files and you want to change their permission to executable and run them. So you can use, okay? These all things will help you for the file operation. So whether directly opening a file or dealing with a file, all these things in the automation in Perl. I think we are done with these slides. Let's move on. Welcome to the 8th episode of Perl programming in VLSI. In this episode, we are going to discuss application of regular expression, that is regex, in VLSI, string operation in Perl, meta character and meta symbols in regular expression, pattern matching through regex in Perl, non-default delimiters, matched group and its extraction, split function and regex in Perl. And finally, search and replace in Perl, which is very similar to what we have learned in the said episode in bash programming. Without any further delay, let's begin. Before displaying anything in this slide, I would like to mention here that Perl regular expression is the most important feature while we use Perl in VLSI, data processing and automation purpose. Now, in this slide and the next slide, I am going to share these ideas how these things are done in VLSI through infographics. And watch till the end of this episode to know how the regular expression you can use, as well as these are very, very important if you are giving any interview for Perl or any particular role which has Perl. So let's begin. In VLSI, when we run any tool, it has dumped an output file. Generally, the output file is a text file and Perl can read a text file through the file operation. And here, generally these text output files will contain resistors, capacitors, etc. Okay, so there could be any other thing. It depends upon whatever tool you are using and whatever the output it is giving. This particular slide and sake of example, let us consider whatever output file is coming from a particular tool contains different resistors and capacitors. And when there are three things that is related to a particular resistor: current, voltage and slew. Okay, so this is for resistor 1. So there are maybe thousands of such resistors and each will contain this data. And the text file which is containing is not a way that you can manipulate the data for your need. So it is a kind of haphazard way it is written. Even for opening and reading in text, read reader, it may not give you a good option. Generally, this data, if it can be exported into Excel, will give you a good result. Now, sometimes this file may contain some other kind of comments and all, which may not be good for an Excel file. There might be several fields and you need maybe only 2 or 3 particular fields. Okay, so Perl regular expression can match these particular strings like current, voltage and slew. And you can store the data in a Perl hash. Few episodes back I have discussed for a simple hash as well as hash of hash. Okay, so if you have not watched, please go ahead and watch them. Now this Perl hash will contain all the registers. So this data structure will contain all the data coming out from that particular text file. Okay, and here whatever I have shown is that race1 is the key, and again inside this key the value is there is another hash. So where the current is the key 1, voltage is the key 2 and slew is the key 3. So each will contain the different value. So here just for exemplary purpose. Now once we have hash entirely populated, okay, with all the fields, there may be current, voltage, slew, load, there are multiple fields are there. You extracted your needful 3 things, current, voltage and slew, and if you want from this data structure you can output a CSV file which you can read in Excel. Okay, and maybe you sort based on from lower to higher value of any particular field. Okay, and you can put a threshold and see what values are above it. Okay, so this is one good application of regular expression. For this matching, regular expression is widely used. Okay, and file IO operation discussed in previous episode, you can watch that, and how to write a file, it is already explained. So this is one particular scenario where a file parsing is done for your analysis purpose at the end. Why we need to do that? Say over the 1 year, maybe there are several design cycles, and each design cycle you might have to process 50 such text files. Okay, so it is not possible that if you go and do that manually every time. So you must have a Perl script which does this exporting of one particular text file into a CSV, and then you can in Excel you can sort that and you can very easily manipulate the data. Okay, so this is one example. We are done with this. If you have any question, you can put your questions in the comment box. Now let us move on to the next kind of operation where this regular expression is widely used. Benchmarking. Benchmarking typically is done in VLSI. Why it is done? Because in a design house, you will find that there are multi-vendor tools are used, say from vendor 1, vendor 2 and vendor 3. So you have the similar kind of, say, timing tool. Okay, a timing tool from company 1, then timing tool from company 2 and timing tool from company 3. So for these 3 tools, or so let us keep one tool away, say only you have 2 tools. Okay, so you want to benchmark the results, or it could be that you are making your data over sanguine. Okay, so it has not violated, or it has whatever the violations are coming, they are same in the 2, or you are not missing any violation. So there are multiple reasons why you want to benchmark the 2 outputs of the tool. Okay, so if you missed one particular violation, what happens that when you go in the actual physical design and you go for tape out, after that you may have a silicon failure. No one wants that because that's a very costly affair, and you have to catch this at the very beginning. So generally any design house uses at least similar tools from 2 vendors and they run in both flow. Okay, so that their design is well checked and they are over sanguine that okay, our design is correct and whatever the violation is coming from tool A and tool B are same. So how this is done? We are taking the same example of text file here. It is from tool A, and here I have drawn a container, which means that we have all the data in hash 1, and in the same Perl program, similar way we read the second tool output and populate second hash, and now we are in a stage that we can compare the 2 data. We can iterate side by side the 2 hash and we can compare resistance 1 versus resistance 1 in terms of current. So tool A you can see it is 1.2 microamp, in tool B you can see it is 1.4 microamp. So similar, this way you can see how it is different. We create, then we can compare these 2 hashes coming from tool A and tool B, and we can output in a comparative study. So it could be a text file or a CSV file based on whatever you want to have. So this scenario gives power to your hand. You become very much over sanguine that my design, whatever I have designed, is perfectly checked, and whatever violations, say 10 violation is coming from tool A and 10 violations is coming from tool B, they are very much same and coming from the same particular registers. This is the purpose. So for this, you can use. So these are the two scenarios I have just discussed, and I have experienced such scenarios. That's why I'm able to share with you. Another thing is that here, background, when you are parsing those files, you are using the regex. Rest of the things you can use the for each loop and if condition, etc. All these things. And output will be using the file IO. So I'm concluding this slide. It's done. I think we can move on. So far in these two slides, I have depicted the two different scenarios where we can use PERL regular expressions for a very, very critical kind of purpose, which is very much important in VLSI. Now, there could be many other scenarios and many other combinations where the regular expression can be used. Okay, for automation, even you want to check a file name, you can use it. I have given two explicit examples that are widely used in the industry, and let me go to the next one. So here, whenever we are dealing with PERL, right, we are dealing with string. So let's see something about the string. Something we have already discussed in the first episode, but here we are rephrasing, maybe some things we are rephrasing again. Still we need to go because the regular expression operates on string. Strings aren't technically separate data type. That is, they can be stored in scalars. So in PERL gives you a huge flexibility in terms of dealing with the strings. So PERL do not have any data type. So any variable can store any kind of data, whether integer, real or string. So that is a very beauty of PERL when you are using. String quotes are like the standard delimiter for strings. Everything inside the single quotes can be taken as literally. That means whenever under double quotes, if there is a dollar variable, it will be replaced. But if it is in a single quote, everything inside the single quoted string will be as is. Double quoted strings are interpolated. I just mentioned any variable names found inside the string will be replaced by their value. To compare two strings, we use the string comparison operators EQ, NE, LT, GT, LE and G. So this I have explained when I have explained the if condition already. Example, $animal is equal to camel. It's a pure string. Then $, I love a $animal. Okay, it's within the double quotes. Now this $animal will get replaced and it will become camel and it will be stored in the $. String with interpolation. So here it is interpolated. Now, my $cost is equal to, it cost $100. Now, $100 is not a variable. Okay, so it's $100. So, it should stay as is. So, here we are using a single quoted string without interpolation. And here we are using $CWD and backtick within that we are using PWD. So, the output is a string of PWD and that goes into the $CWD. So, this way the string can be flexibly used in PERL. This is the power of PERL, I will say. And let us start about regex now. A regular expression is simply a pattern which implicitly generates a family of strings expressed in a special notation. So guys, before going to the next point, I would like to mention in the bash series, I have explained very much detail about this regular expression, and SID has come well before the PERL. There are two kinds of engines, so you can go ahead and see that episode of SID in this channel if you want to explore in detail. But here in this episode, I'm covering the necessary things, so don't worry, keep watching till the end. A star Z. This pattern generates possibly family of strings, means A, AZ, AA, AAZ and multiple A then Z. Okay, so this is called regular expression. The matching operator, that is /, returns true if the string it bounds matches with the regular expression that it contains. So we'll see later on. There are two pattern matching operators which are by default scalar and $_. These are pattern matching operator, that is pattern within /, returns true if the string matches with the regular expression which it contains, and the substitution operator, that is s/pattern/replacement/ replaces the pattern with the replacement if the match is found. So all these operators are operating on strings, so that's why we touch base the string variables. Most characters in a regular expression simply represent themselves. This is a good point, but why we are saying this? We'll come to know. Just wait for a while. Except \, pipe, braces, angular bracket, curly brace, caret, $, star, plus and question mark and dot. So these are special characters. So they are not treated in the same way as the other characters in PERL. These are called meta characters and have special meanings. We'll come to know. Star I have already shown in the second bullet in this page. Later throughout the slide, I'll explain. So we are done with the slides. Move on. Meta characters. Caret matches the beginning of a string. dollar matches the end of a string. So basically a string is under a double quote or a single quote, right? So the first character of the string is after the opening single quote or double quote. Caret specifies that you have to match here, and dollar matches with the closing quote or double quote, okay, at that position. That's why these are meta characters. Dot matches with a single character, any single character, okay. Star matches with any count, that means 0 to n of the previous character. So there is one character A followed by star, means there could be any number of A. Plus matches the count but at least one of the previous character. So these star and plus, they have to come next to one particular character and their count has to be matched, which is why these are different. Angular brackets, okay, so these matches a set of character. Sometimes it is called a group. We'll see through the example. Then caret comes in the picture. This matches any character not a member of the set of characters following the caret. This parenthesis or the first bracket. Group a set of characters into a subspec. So we'll see how these are done. So this is a matching group with the first bracket or brace. Now we have second bracket or curly brace. It exact, and the value here is m. That means it exactly matches m times. M comma here means at least m times. There is the maximum limit here. Then if we have m comma n, it matches at least m but not more than n times. So this is all the meta characters that we can use, okay. So here m and n, they are just for exemplary purpose, but here they will be numbers in actual case, okay. We are done with this slide. Let's move on. Meta symbols. We have just covered the meta characters. Now let's see the meta symbols. Backslash d matches a digit, not just 0 to 9, but also digits from non-Roman scripts. These are meta symbols, okay. Backslash s matches any white space character, which can be backslash space or backslash t, backslash r, backslash n, backslash f, and others. This is used for a generic matching for the white space characters. You can use it when you do not know which white space character is there. Backslash w matches a word character, alphanumeric or underscore, not just 0 to 9, A to Z and A to capital Z, but also digits and characters from the non-Roman script. Backslash d is a negated of backslash small d. So these meta symbols have their negated brothers also. Here like backslash d is opposite to the backslash small d. Backslash s is a negated backslash small s and represents any non-white space characters. Backslash w is a negative of backslash small w. It represents any non-word character. The period dot matches with any character but backslash n unless the modifier backslash s has an effect in and explained below. Backslash n is like the period matches with any character but backslash n, but does so regardless of whatever the modifier slash s is in effect. So these all you will see the examples throughout entire this particular episode. So don't worry, let's move on. Pattern matching. So here we generally say pattern matching, but it is actually a pattern and matching the pattern. So pattern and matching. A, B, C, D, E, F matches the exact A, B, C, D, E, F. Now, if it is A star B matches 0 or more A followed by a single B, for example B or multiple A then B. A question mark B matches B or AB. A plus B plus matches 1 or more A followed by 1 or more B, and the examples are AB is the shortest possible match. Other could be 4 times A then B, or A then 5 times B, or 6 times A and 7 times B. So these all can be matched with this particular regular expression. Now dot star or dot plus both matches all the characters in a string. However, the first matches with every string including empty string, while the second matches only strings contained at least one character. Okay. Now within angular bracket A to Z, then capital A to capital Z and 0 to 9, this matches any ASCII letters or digits. So it matches any alphanumeric combination. So these are basically examples. So let us now see some examples by which you will be able to know how you use the regular expression in actual PERL programming. So these are examples we will be going through, and here it is not a single example, multiple example will be there in each slide. So there are two kind of here. The first one is a positive match case. Here we write hello world, and inside if we write the quoted hello world and equal to tilde or tilde, then we have world within the two forward slashes. So this is the case where we can match world with the string hello world, and it's a positive match. So if the return comes true, if it is matches, the return will be a positive one. This if block will be executed and it will say it matches, else it doesn't match. So we have explicitly mentioned the string here hello world, and by condition we know that the if block will be executed. Now this is a kind of positive type of match. If we want to do a negative kind of match, how we would do that? If hello kids and then bang, then tilde, then within double slash we have world. Okay, so this means this string in the left hand side do not match with world, then it will return true. So if executed only when it is true. So in this case, it doesn't match. We know because hello kids and world, by visually we know it doesn't match. So if will be executed. Else, if we have not hard coded this particular string, we may have used a variable. In that case, we have chances of getting into the two conditions, either in the if or in the else. Okay. So this is how it matches. So keep in your mind, there are two types of matching. First one is a positive match, which is in the yellow box left side, and second one is a negative match, which is in the right hand side. So based on the situation, you will choose whatever you need. So let's move on to the next slide. Here again we are seeing two examples. First is a positive match, and here we write $_ is equal to hello world. So these examples are making you also efficient for your interview questions, because here $world, say it can be that how you can match any particular string without using the string in a $ variable or explicit. Okay, so this could be one example here. This could be answered. So here, if we write $_ equal to hello world, means it goes to the default variable $_, and if we write if, then within the parenthesis we write only the word within two slashes. So it will match with $_ only. And here we use else block. So we know the string we have hard coded here, and we know that it will match. So the if block will be executed here. Second, it's also a positive match, but here we are using an explicit variable, $variable, and we write world, and here you are using if the string hello world equal to tilde with $ variable within the double slash. So this is another way of using the regular expression matching. So here we know that in $ variable we have stored the word, so this if will be true and it will print it matches. Otherwise, if we have not anything else, then world, if we write there, right, be a cat. So in that case, else will have operated. So this is another set of example how you can use your regular expressions matching or something like that. These are different questions. This may come as an interview question. You can guess what the question will be. Please feel free to comment. Okay, let's move on to the next example. Here there will be multiple examples. So first is within the double slash we have BA and *D. This in Perl we have the hash, means hash character here as a comment. So the rest of the line is a comment. Match 0 or more A's between B and D. Matches BD or BAD but not BID. Okay. BA plus D matches one or more A's. There should be at least one match. At least it will match with bad. Okay. BA (D) matches 0 or 1A. So you can guess what it will match. Please write in the comment. Now within double slash we have B pipe A then pipe D. This is alternation. Pipe means that exactly it has to match B, A or D. Now we have within the first parenthesis inside the double slash hard, pipe, soft, then ly. So this will match with hardly or softly. So this is kind of grouping. Either the hard then ly will be matched, or soft or ly, that is hardly or softly. Then hello world, and we have equal to tilde O slash matches O in hello, not in world. Remember, it matches with the first occurrence. If it is a non-greedy, right? If it is a greedy, then it will keep on matching. That hat is red. Equal to tilde hat matches the hat, not the hat word, but that. Okay. Here it is a non-greedy matching, so it will match the first occurrence. Hello world matches with world. It doesn't match at all because the W is in small caps. Hello world, and then we have small o and capital W. Obviously it matches because we have the hello's O and world's W in the same fashion in the left hand side. Now here it matches hello world with O. There is no space in W. So it doesn't match because there is no character combination inside in the left hand side. So hello world and then the right hand world and then there is a space. Remember, there is a space. So there is no character combination is there, world, there is space. You have to see that space in the right hand side. That is not in the left hand side. So this does not match. So these are very critical things. These are interview questions as well as you have to keep in mind because you have to be very careful when you are dealing with the regular expression programming in PERL. So let's move on to the next slide. Here will be multiple examples as earlier. So 2 plus 2 equal to 4 equal to tilde. Then within slash we have used 2 plus 2. Now in the right hand side, the plus is a meta character. So it doesn't match. We have a special meaning of plus here. Now 2 plus 2 equal to 4 equal to tilde 2. We precede the plus with a backslash. It matches because whenever you use a backslash before a meta character, the special purpose is now ignored. It becomes a normal. So now this backslash plus is treated like an ordinary plus in the right hand side. So this matches. The interval is 0, 1, then beginning we have angular bracket and then we have closing as a brace. So this gives us syntax error. You can try it why it is giving a syntax error. And please let me know in comment. Now the same thing at the left hand side and the right hand side we have used backslashes everywhere. It matches because they were special characters. Now hash bang user bean PERL. We know the PERL basic path in our installation. It could be different in your case. So how to match that? We have to precede every slash forward slash with a backward slash on the right hand side. Then it will match. Otherwise it will not match because a forward slash is a meta character in regular expression in PERL. C : backslash win32 in the right hand side equal to tilde. That is what is happening here. We have to backslash the backslash, okay, so that it matches. My $4 is house cat equal to tilde $4. So it matches. Next, cat house, cat $4. Again it matches. House cat $4, then within curly brackets, right, $4. Again it matches. Housekeeper, and we have keeper in the right hand side. This matches. Housekeeper, and we have a caret keeper in the right hand side. This doesn't match because keeper not at the beginning of this string in the left hand side. Housekeeper and then keeper followed by a $. It matches because keeper is at the end point of the string and $, is used for the demarcation of the end of a string. Now housekeeper then backslash n and we write keeper then $, and it matches. Why? Because backslash n is a special character. It is not taking it in consideration. So we are done with the set of examples. Let's move on to the next slide. Example 5. Slash within cat matches cat. BCR within the angular bracket and then at. So it will match bat, cat or rat. So item then 0, 1, 2, 3, 4 and so on, and we proceed up to 9 and then we close the angular bracket. This matches with item 0 or item 1 and then up to item 9. So you can understand how this angular bracket is used. What is the usage? ABC equal to tilde CAB within angular bracket. It matches only A because in this group only one alphabet is matched. So that will match with A. Now we have three groups side by side. Small y capital Y, small e capital E and small s capital H. So these can match yes in a very case sensitive way. That is small yes, then yes and then capital yes, etc. and so on. So any combination. Item 0 to 9. So 0-9. So instead of writing whatever we have written in the third line, we can write in the similar fashion items then within the bracket 0-9. So here it means the same. Matches from item 0 up to item 9. Now here again we write 0 to 9 B, X to Z, then AA. Matches 0 AA, then 9 AA and like all this thing. 0 to 9 A to F and capital A to F matches a hexadecimal digit. 0 to 9 A to Z and A to Z matches a word character like those in PERL variable name, and we have underscore here also. Now caret A and within the angular bracket and at, this doesn't match AAT or at but matches bat, cat, 080, %80, etc. Next is caret 0 to 9. This matches a non-numeric character. Now A caret 80 matches AAT or caret 80. Here caret is ordinary. So we are done with these examples here. Let's move on. If you have a comment, you can do in the comment box. The next slide here is non-default delimiters. The // is the default delimiters for a match and can be changed to arbitrary delimiters by putting a quote M out of the front. Now, hello world equal to tilde, we have em, then within double bang, matches world. And here the delimiter is bang. We have used m. In this case, we have to use m. The second one is hello world equal to tilde m, then world. And we have two curly braces. Here the delimiter is curly braces, pair of opening and closing. M stands for matching. And with the double slash even we can use the m at the beginning of the first slash, okay, in the same way. User bin PERL within double quotes, and here we are using m, then within double quotes slash PERL, it will match. Here the slash is not the slash for matching delimiters, it is a normal slash, and the delimitation character here is the double quotes. Slash becomes an ordinary character here. So these are some examples how you can use the not default delimiters. Now in the third example in this page, you can easily imagine when there is a huge file name path you are matching, this kind of delimiters are very useful. How many numbers of backslash you have to use to make a non-special character for slash, okay, in the right hand side if you have to use. So this is very troublesome and you can get errors or something by mistake in the typo, okay, and PERL may not recognize that. In that case, you will not get your desired result. So in such cases where you are matching a long path, this kind of non-default delimiters are very good to use. So done with these slides, let's move on. Extracting the match group. So this is a matching group. Earlier we have used the grouping in a different fashion. Here it is extracting match group. The syntax is different here. Now the grouping meta characters within first bracket or braces allow the extraction of the parts of a string that is matched. Earlier we are checking whether a string is matching or not. Okay, that is a yes no condition. But here if the string is matching and we are matching a substring, how would we extract that substring? So the pair of braces do that, or the first bracket, whatever you call it. For each group, the part of the matched inside goes into the special variables like $1, $2. This is what I have already explained in the first episode. Okay, so these are special variables and these will contain the matches. So if you have 5 matches, the 5 matching groups will be contained starting from $1 up to $5. They can just be used as ordinary variables. Let's see an example here. Extract hours and minutes, AM and PM. So we have my $hour, minute and designation. Okay. Here in the left hand side of the equal to tilde, we have 03:15 PM. So in the right hand side, we are matching is slash, then within the first bracket, we have \d/g. The first, there are 2 numerics here, digits. We are using meta symbols here. Okay. For matching. Next is, you can see that for the minutes, we have also \d/d, but that is covered in another pair of first bracket or braces. Then we have AM pipe PM, so that is AM or PM, and in between there is a space. So we are matching every particular part and we can extract the each substrings here. So $hour we can set as $1, $minute is $2, and $designation is $3. Now we can use this later on. Okay, so this is how we can use the grouping and extraction for substrings. So we are done with this particular slide and example. I think this is clear enough, and let's move on. Matched group example. My $x, the cat in the hat, okay, is the string. And here we use $x equal to tilde caret, then $* is the first one, then 80, then $*, and then we close the string with $. And it matches $1, the cat in the H, and $2 is at. So it has proceeded up to H of the hat in the first case because it is $*, and then it has to match at, so it matching at, and $3 has 0 matches. Wow. So this is a surprise, but you must get used to it and you can practice by printing these variables when you are matching. So that's how you gain expertise in PERL regular expression. Now let's talk about split function in PERL. Now we are discussing here about regular expression. Why suddenly we go for a function, split function? It's necessary because in split function we also use the regular expression. So let's touch base it here. The split function is another place where the regular expression is used. It returns a list of values that don't match a given regex in a search string. So the pattern works here as a delimiter to split the string into smaller substring. The substrings are returned in the form of array. Now my $line is equal to, within quotes we have Linux, then colon DOS, then double colon Windows, then single colon, then BUS. Now my @output. It's array, and we use split functions. In the first argument, we give double slash. Here goes the regular expression, and we have the colon as the special character or the character which we are matching in the regular expression. Okay, and then $line, we have just written it, and split the $line with respect to colon here in the decimeter. It's a very simple function, split. The first argument comes with the double slash, and inside that you put the character with which you want to split the string into multiple substrings, and the next one you give the string itself. So there are only two arguments, and the array will contain the split results. The array output contains Linux, DOS, and there is a blank string. Why? Because there are, after DOS there are two colons, okay, and then Windows, then BUS. $_, next one is the $_ is equal to, this is a test, and my word split with respect to a space. This is same as split and then $_. This is the purpose of showing this line, is that the split can take the $_ by default if you use the regular expression within the two slashes and you do not specify the second argument. That means the split is taking $_ in the consideration of the string on which it has to operate. So this can come as an interview question also. Guys, we are done with the split function here. Let's come to the next slide, search and replace. So guys, if you remember SED, or if you have not remember, you can go to the SED episode of Bash programming in this channel. There we have done the search and replace. That is very, very similar in PERL. Search and replace are performed using S. S stands here for substitution, okay, and earlier we have used M here, which is for matching. So here S, then within the first pair of slashes we have the regular expression, and in the next two slashes we have the replacement, and then at the last we can use the modifiers. Okay, modifiers you will come to know what are the modifiers. The folks who are very much using the SED, they know this kind of expression. The replacement is a PERL double-quoted string that replaces the string whatever it is matched with the regular expression. The operator equal to tilde is also used here to associate with the string with S, then slash, then slash, then slash. If the matching against $_, the $_ equal to tilde can be dropped. That means if we are using only starting from S, then within the three slashes we have our regular expression and its replacement. That means we are matching with the $_. If there is a match, S, then slash 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 returns the number of substitution made. This, if we are catching a value right, this will give the number of substitution. Otherwise, it will return false. So this is the way we are doing the search and replace. Let's see some examples now. My $x, time to feed the cat. Now we have $x equal to tilde S, cat with dog becomes time to feed the dog. So this is a very easy example. Now $x is I battle 4 for 4. Now substitute 4 with word 4. It contains I battled for 4 but for 4. What happens to the next 4 which is in the numerics? It doesn't change because it's a non-greedy operation. I battled 4 for 4. Again I write and then I use S and then use 4 and 4 in numeric and word, and then I use G. Here it becomes greedy and it replaces all the 4s. So it now $x becomes I battled 4 for 4. Okay, now all 4s are replaced with word 4. Reverse all the words in a string. We have $x, the cat in the hat. Now how we do that? We have $x, then S, then we have \w plus within the first bracket, then we use a function called reverse, and then we use $1, and then we do GE as a modifier, and it does the purpose. I would like to ask you to try this thing at your end and mention or not to mention the modifiers and see what the result. Okay, guys, we are done with this particular slide. Hello guys, in today's episode, we are going to install one particular PERL module. This module's name is Moose. So this URL will be provided in the description of the video, and this particular Moose.pm is used in object-oriented PERL. So I'm going to show you how to install this module in your PC. Okay, in case you are using your office computer, that time you have to request your Unix admin provide this particular URL and ask that to install this particular PERL module for you. Okay, but since I am using my own PC, so I'll install it here myself, and I'm going to show you how you do that in your terminal. Okay, so once you reach this URL, so here if you see in the left pane, you can see there is a install instruction here. So if you click it, it will show how you can install. So there are two ways. One is a cpan shell. In that you can execute this, or otherwise you can use cpan-m. Let's begin without any further delay. So here right now I am in the shell, okay, and let me check whether cpan is there. Yes, cpan is there. So let me invoke cpan. Cpan requires configuration, but most of it can be done automatically. So I'll say yes. So I'll do sudo here. Okay, so sudo I have chosen here. So because this Linux system always use a root to install anything into the system, and if I install it as a root, so any user in the system can use it. But for my own PC, I'll be the only one who is using this. In your home PC, if you are installing, so you will be installing for yourself. Okay, so let me check back to the instruction set here. PERL m cpan a shell. Let me copy it and then put it here. Okay, let me check. Install Moose.pl. Let me try this one. So I think it has picked up the install Moose command and it is installing. You can see it is progressing. I think here in my PC, this command, okay, it is asking for the sudo password. Let me give it. So it is now installing the module, PERL module. So this is the beauty of PERL. You can install any module of your choice and which are available in your cpan repository. This is a flexibility of PERL, which I have been keep on saying in multiple episodes of PERL. So you can see a live demonstration here of how you can install one particular PERL module. That is, the process is ongoing. Let us wait for some time. And by the way, which I have not mentioned, that you have to be online. That means you have to be connected with your internet connection to install this from directly from your shell automatically. Okay, using your cpan shell. So let's wait some time more. It's installing. So we have reached to the end, and here you can see the cursor is blinking at the cpan shell, and we have installed, and it's saying sudo make install is okay. So I think this particular PERL module is installed. Okay, so let me now exit the cpan shell. Okay guys, so the installation is complete. Hey guys, welcome to the 9th episode of PERL programming in VLSI. In this episode, we are going to discuss the object-oriented PERL. So far, we have discussed multiple topics and multiple areas of PERL, but this episode is completely different. And in case you have not seen data structures episode, I'll request you, before watching these episodes, please at least watch the data structures episodes. And this episode is kind of different because here the concept is totally different. Okay, and without further delay, let's begin. So in today's episode, we are going to talk about package and module in PERL. Next, we'll go through example of the same. And we'll start from the very basic concept of object-oriented programming. In case you already have this knowledge, it's okay. Otherwise, those who don't have the knowledge will have the concept first. Next, when and which cases the object-oriented programming is used. We'll talk about the details or the different parts of object-oriented programming like object, class, blessings, constructor, destructor, methods, inheritance. Next, we'll go through coding example of creation of class and its object in PERL. We also go through the coding example of inheritance and object creation of that inherited class. And we will close the entire episode with a very easy way of object creation in Perl through Moose.pm. So this Moose.pm do not install by default, and in case you want to install it, I have made a video of how to install the Moose.pm. I'll provide the link in the description. This is the kind of menu for today. Let's start the episode. Perl package and module. Now, before saying anything, the package and the module, why we are looking at this? Because without the package and the module, we cannot write any object-oriented Perl programming. I'm not talking about the Moose.pm. I'm talking about specifically from scratch when you are writing a Perl class and creating its object. So for that, this package and module concept is very, very necessary. Not only this case, in other many cases, when you are encapsulating your programs or your subroutine, that time you can definitely use a package. Here I would like to mention one thing, that object-oriented programming always require package and module. But the package and module is not dedicated to the object-oriented Perl programming. It has its own existence and it can be used in any of the cases where it is applicable. Now, let us start talking about few points. We are well aware of the namespace concept. If you have learned C++ or Java, you might have come across this namespace. Okay. Each namespace has its own objects and table, data structure, etc. like a hash table and all. In Perl, packages are actually the namespaces here. Okay. The default namespace of any Perl program is main. Okay, now we do not write main word in the Perl program, but it exists. Even we do not explicitly say, but it exists. Package declaration tells the compiler which namespace to fix for our variables. So we can have a namespace, that means we can have a package, and in that package, whatever variables or subroutines and blah blah blah, whatever are there, so those will come under that particular hood. So that hood is nothing but the namespace, and in Perl, package is the namespace. A module is a package defined inside a file whose name is same as the package. Now, module is the capsule of the code. So I'm not talking of the encapsulation. I'm talking about a capsule, which you can pop if you're ill, right? Capsulates the whole thing. So this module is a file and it has a .pm extension rather than .pl extension. This contains the package and it is called the module. All Perl modules are contained in a global @inc array. I have touched based these things in the first episode. These are special variables and these are special data structures. So @inc will contain all the modules. A module or package can be included in a program using use or require functions. So far, whatever we have used, right? Like strict module we have used. So that module when we have used the syntax use strict. So you know this already. So we are done with this particular slide. Let's move on. A Perl module. A module is just a set of related functions in a library file. That is a bare definition. And a Perl package with the same name as the file. We have just said that whatever the package we are writing inside the file, that the same name should be given to the file name. Package name and the file name should be the same. I'm not talking about the extension. I'm talking about the name. Next, the file extension should be PM and not PL. I have mentioned already. Now the module definition starts with package, then some module. So this is some module is whatever you can write the module name. Okay, it could be Mount Everest or it could be my own module. Anything, whatever you write. Then we, as usual, we are writing use warning for warning purpose and use strict for the purpose. And then we write all the code, subroutine, etc. And we close the package by a 1, then semicolon. Here, the package ends. So this is the ending statement of a package. So you must not forget this 1, then semicolon. Here, this is the closing point of the package. So this is the syntax of the package. Rest of the things, whatever you have coded in Perl, so far you have seen all the episodes, they can come under the package. Package is basically creating or kind of compacting a set of codes inside a namespace, and that namespace comes from the package. So in Perl, we use the package command here to make the namespace. Both are same. So namespace and the package. In this next slide, we have come already. Usage of custom module, Perl module. Okay. So once you write these Perl modules, okay, PM files, you can reuse. So this is another kind of usage, that is code reuse. So PM can be reused in multiple areas. That is the kind of benefit of the Perl module. Where you can keep it? You can keep it in your current working directory. For any other directory, you can specify it in your chsc. How? Okay, let's see in the next lines. We can set the environment variable, set env, then perl 5 lib, all in caps. Okay, then you give the path where in the which folder you keep all the pm files. So you have defined or written 10 pm file you can keep in this particular folder, and in your chsrc file you can write this one. Again, if it is not perl 5 version, then you can write set env perl lib and then again specify. So it's better you specify both. Then in your perl program.pl, myprog.pl, what you can do, that you can use the statement use some module. We are assuming that in previously, as we discussed, you have written a module which is called some module.pm, and you have kept in the above mentioned directories which I have just shown in the few lines before. And from there, and you are writing your myprogram.pl anywhere in your disk, and then you can use the module. Since all these environment variables are now set, now the Perl engine will look for the module inside this defined path. Next, you can use another way that requires some module, or you can use require some module.pm. Now this is the basic question that is asked in many of the interviews, that what is the difference between use and require. Syntactically, this is the difference, that in use you don't have to mention pm, but when you use require, you can either use or not use. We are done with this particular slide. Now please keep in mind, this is a very important slide and the information, because even if you write a Perl module, if you do not do these things, you cannot reuse the code. And how many times you have to copy your same module into the each and every new working directory? That will be cumbersome, and you cannot modify the code. If you modify code one place and you have to copy it back in all another places. So it's better you keep in a particular area and set the environment variables accordingly, and you can reuse the code anywhere you want. This is generic. This is not for object-oriented Perl. This is in any cases where you are actually have defined a Perl module. Now, in the next case, let us go. We are done with this slide. Let's move on. Package and module example. So we have talked so far about the package and the module. Let me give you example. It's better, right? So here both will be codes. So I have just colored them in a different way. We start. So we assume that this file has a module. This file has a name abc.pm, and inside which we are writing package abc. Then we are use strict, use warning, and sub hello. In hello, what we are doing? Print hello new world, and we are closing it. Next, we are writing another subroutine. It's an inline subroutine. So sub, and then we use the return statement and we add $_0 and $1. These two are special variables, and these will represent the first and the second argument that is given in the addition subroutine. Now we close the package, or rather we end the package with one semicolon. So this is done. We have written this package, we have saved it, and we have kept in the directory we have mentioned in our CSHRC file. In that we have kept. Now we go to anywhere in our disk and we can write any program. So we are writing some myprogram.pl. Inside we use strict and we use warnings, use abc. So now when we put this command use abc, Perl engine will find that particular abc.pm, and we can use the code whichever we have written inside this. What we do here, how we can call the subroutines, we can do in both ways. One is the abc : hello. If we call like this one, the hello will be called. Another one is that inside a print statement we can use. Here we are doing print \n, then 1 + 2 is equal to, and then we are calling the function abc, then : add, then we are providing 1 : 2. So this will call the add function, that is we have written in the Perl module, and it will print the result. So this is the way how you define a Perl module and how you instantiate it and reuse the code anywhere you want, anytime you want. So this is the way. So I think enough information is given of creation and instantiation of that module. So let's move on to the next slide. We are done with the particular Perl package, module, etc. syntaxes and the basics. Now we'll enter into the regime of object-oriented programming in Perl. So here, before doing anything, I would like to mention that object-oriented programming is an altogether different concept. What I could do, that I totally skipped all the concept and directly jumped into the object-oriented Perl programming. But that will be very hasty for the folks who do not know what is object-oriented programming, maybe first time seeing it. So better to touch base the concept. That's why I've included this concept in this episode. This concept. Most object systems have shared the common concepts. Okay. Understanding these concepts will make easier to read an object-oriented code. Why we are going through this? I'll come to the concepts, but before that we have to touch base what is the importance. That's why. So Perl object-oriented, it is completely class-based, and class-based is fairly common. Okay. This same concept of class-based is used in Java, C++, C#, Python, Ruby, and many other languages, which are also object-oriented programming languages. So these are the concept we start. Now we will go to the object-oriented concept. Now we are talking about concept. What all these things are there? Let me bring my mouse pointer. So there you can see there are 6 elliptic shapes, right? Here there are 6 concepts. The first what we start with is the class. Then a class can object. Object is actually a encapsulated data, and the class itself is encapsulated data. Abstraction is the level. Abstractions is the level. Polymorphism, that it could be a multiple shape and figure. So an inheritance is that when we go from one class to its subclass. Okay, so all these concepts stay in object-oriented programming. So this is a touch base of the concepts, what all are there. And let's move on. We are done with this particular slide. Real life, class and object. Now, this concept of object-oriented programming has come from the real life, is inspired from the real life. And you may say, how? This is a picture of a class. Now, this class is a class where students are going. Okay. Now, is there a connection? Yeah, that's because for the same very reason I have picked this picture to get into the concept. Now, in this class, you can see there are a lot of students here sitting. Now, they belong to say standard 5. The class is standard 5 and they all belong to it. So, what is common? So, they all belong to the same standard, and their age, I'm not going to the fractional figure, but in the round figure, they will be all in the same age. Now, whatever they are learning same thing at the same time. So this way they have a similarity. So here all students will be the same. Now the class here, this class, entire class or the standard is a class, and each of the students are objects. Now they can be different. So here could be male student and female student. So this is the basic difference by visual, and merit wise they could be also different. Okay, someone has a good score, someone has so not good score and all. Okay, and so if we go to extracurricular activities, someone he can play a violin, or she can play a piano. So these are their own basic attributes. So they have their own attributes, and that is how they are different. But whatever, say, this is when I say extracurricular activity, this is a kind of property of the class. Okay, so he's playing a violin, but she can play a piano. But if we see the common, that they can have some kind of extracurricular activity that is common. When we make it generalized, it becomes the class, and when we make it specific to each and everyone, it becomes an object. If you stare at the picture and if you look back in your old class days when you were in standard 5, you can recall how you were different from your friends in the class. So this is the concept of the objects, and objects could be different from each other. And the encapsulation means you know something about your friend, but not everything about your friend. Okay, you do not know that what the friend, how many relatives are there, and what the father, where he goes, and how qualified he is. Okay, at that age you may not know these details. So those are encapsulation. So you cannot see those details. Only if you ask your friend, okay, that what is your father's profession? This is a question, and in object this is kind of a method. That's a query. And when you put the query, your friend answered, my father is a lawyer. Now you get an answer, but you have to get the answer from the object by throwing a query. Now these queries are called methods. So this is a concept of the object-oriented programming. So this has been derived from the actual life. Okay, that's why object-oriented programming is much more like the real life. So that's why I have given the concept. I think enough time has been spent on this particular slide, and you can keep wondering about these things when you go through the entire object-oriented section. Let's move on to the next slide. When to use object-oriented programming? When the design system which is designed is large, and or it is small while designing, and it could become a large. So similar to that, when pupils start to register in a class, there may be first 10 student, 20, capacity may be 50, but the seats over time, maybe 1 month or 2 months, the seats become filled up to 35. So, and then some later point, 5 more students came, and the total strength of a class become 40. So this way, the system can be very small, but it can become large. In object-oriented programming, when you are designing a class and object, you keep that concept, there could be similar kind of entries and they can get populated over time. So more seats can be blocked over time. So this is a case where the object-oriented programming comes into picture. The data can be put into obvious structures. So obviously they will be same age, they will have some criteria, they will have some extracurricular activity, they will have some certain amount of merit for a class. That's why I'm relating it. There is a prominent inheritance and polymorphism. I'll come to this later because at this point I don't think there is a good relevant example. I'll come in the later one when I give you the examples. There is a piece of data on which many different operations are applied. Your object is same, but if you ask different question, right, you will get different answers. These are called methods, and methods give you the reply back in data. You may need to perform some general operations based on the data type. So what is the general operation is done every day in the class? Okay, it's your attendance. You remember, okay, we said yes sir or present Pam or something like that. Okay, so these are general methods that will be applied on each and every one every day. So chances are that you may add a new data types later. So I told that 5 students came later and they joined the class. So similar way, your data structure can add more objects at later point of time. The implementation of individual components of the system is likely to change over time. The system design is already object-oriented. Okay, now you are working in a system and it is already have the object-oriented programming. Large number of programmers from multi-site will be using the code and the module. So this is a kind of good concept because today any company is in a multi-site operation. So when you have the object-oriented concept, right, they don't have to go to bother to see the inside. Instead, they can create a data object or use a query to get the internal data. So that means the object-oriented programming is this way more flexible to use. Okay. On the contrary, if it is a procedure-oriented, if they have to know the line-by-line code or at least the methodology or something like that. But in object-oriented programming, you give the list of methods, you give the kind of data structure it can store, and you are done. You can start working on it. Okay, so we are done with the slide. Let's move on. Objects. Objects we'll be talking about. An object is a data structure that bundles together the data and subroutine and operate on that data. So you can find the simile like a student, right? He will have a age, he will have a name, he will have a surname, he will have some parents' name, mothers and fathers, he will have an address, and he will have some merit which he has obtained from his previous standard, and definitely there will be a lot of other things, okay? Extracurricular activity maybe. So it is the kind of all data will be there. Now the objects data is called attributes and subroutines are called methods. So the extracurricular activity I was talking about is attribute, and subroutine that we are putting a question that what does your father do is a method to know, okay, what is the profession of your father. Now next, the object can be thought as a noun, a person, a web service, a computer. So object can be any. It can be any. You can think of the concept. The object represents a single discrete thing. So as I mentioned, class represent the entire class and object is a student. So each unit or each instantiation of that class is object. For example, object might represent a file. This is a generic. I have given a more examples, right? The attributes for a file might include the path, content, the last modification type. If for a computer, if you think of an object, a file can be object and it can have multiple attributes like path, content, last modification time, size, and whether it's a file or a directory. Next, we go to the class. A class defines the behavior of a category of objects. So it's a generic definition of similar objects. A class name is a category and the class also defines the behavior of objects in the category. Okay, there is a basic subtle difference in real life class and objects and in the programming. So in real life programming, you can see that individual people are joining, right? Having the same criteria I brought into the analogy. But in programming, the class has to be defined first, the data structure, everything has to be defined first, and then we populate the class with object instances. Even in school, we have different standards which represent maybe different classes and we populate the students later on. There is a visual see whatever we see and actual what is happening is very similar. But the part which we do not see is that in a school, standards are defined first and then pupils start to populate each class. So the classes comes first, it is defined first, and then the object gets instantiated or populated, whatever you feel apt. A specific object is often referred to as an instance of a class. In PERL, package can be a class, I said earlier, and now the difference between a package and a class is that isn't based on how the package is used. Now, it's a concept. Basically, the object-oriented PERL is a concept, and we'll come to know about a function called blessing, which will make a regular package into a object-oriented class. Okay, that blessing function we'll be talking about. So how it can be there? Package, then file, then my hostname, file, then we right arrow, then new is a routine, and it's called a constructor, and this makes a kind of object. This is basic structure. Okay, this is a class declaration. Okay, and we are not showing up blessing functions here. We'll come in the explicit example. So the concept is here. This is how a constructor means how you construct an object. Okay, because it's a code, you have to construct object, and for that you need a constructor. This is a constructor. So now blessings, this slide will be talking about blessings, constructor, and methods. Okay, so blessing. Most Perl objects are hashes, but object can have instance as per Perl data type and a scalar and array. Turning a plain data structure into object is done by blessing. I was talking about the blessing even last slide or before. So this blessing actually turns a basic data structure into an object. And what is the differences? I'll show some functions that makes a difference between a hash and an object. When a hash is turned into an object, if you do some query, it returns as an object, okay, not as a hash. I'll show. For that, you see up to the end of this episode. We sometimes say that an object has been blessed into a class. That is why they call the function of making a data structure into a class, and they means the Perl guys called blessing function. So the constructor. Now constructor is a particular thing that creates an object. Now constructor means it construct the object, okay, and we'll show by explicit example how the object is constructed. And it is typically my file is equal to file, then arrow, then new. This is the typical in Perl syntax, okay, creating a constructor. And then methods. Methods are nothing but subroutines with which we can query the data. That will operate, go inside and seek the data and come back and give us the data. The object will still remain encapsulated. Okay. The object can contain the data, but the method can fetch that data. Now we are done with the three things. Let's move on to the next slide. Attributes and inheritance. Attributes. Each class can define its attributes. When an object instantiated, we assign values to those attributes. For example, when a file has an object path, attributes are sometimes called properties. So this is nothing but the data. Basically in class we define the skeleton, and in an object we fill the skeleton with flesh and blood. So all the flesh and blood, they are attributes. Okay. Inheritance is a kind of that very similar concept. What you have inherited from your father or mother is your inheritance. Similarly, inheritance means that when you create a subclass, right, it will have the properties that was in the parent class, and it can have its own different attributes and functions also. Like you have something with common with your father or mother, but you still have your difference with them, so that makes you special. So inheritance is that the things that you have inherited, maybe some quality or property or some knowledge or something. So similar concept when a subclass is defined from a class, so it can inherit all the data structures and the methods, everything. We are done with the inheritance here, and here is an example. You can take that file : mp3 is a subclass of the class file. Okay, so this way we can see anything. So all mp3s are file, but all files are not mp3. This is the concept basically. And here the file is called a superclass of mp3. Superclass means superlative power. Okay, so generally our father and mother are superlative, right? So that's why we call a superclass. Now package file : mp3 and use parent file. So this is the kind of syntax. When we can define the subclass. You have to write the second line definitely, that use parent file. So this is a kind of inheritance command, use parent file. Okay, there are other ways, but I think this is a very handy way to define the inheritance. Overriding methods and method resolution. So I'll give an example here. Your father uses maybe hand calculated values, count the prices that for the grocery, and you use Microsoft Excel. So say the goal is same, that you are calculating the expenses of which have been for the grocery, but the methods you are applying, right, are different. So this is called overriding. This concept is overriding. So the object or the subclass may have methods which may override the original method, but the goal remains same. Okay. Inheritance allows two classes to share code. By default, every method in the parent is also available in the child. So it is copied, but you can obviously have in the child, you can have its own version where it overrides the parent's method. A child can explicitly override a parent's method to provide its own implementation. That is what I said. So this is overriding. Now here, overriding doesn't mean that you go and have a collision with your father. Okay, it's about the method. Okay, so don't go in that direction. We are done with this particular slide. Let's move on to the next. Creating a class, student.pm. So here we'll be showing the explicit examples. So get ready. Here we start with our PERL path, where the PERL comes from. Then we define the package student. Next we use strict warnings. And here we define one. It's simple. It's not very complex. We define a subroutine called NL, means it will add a new line. It is not mandatory here. Now we'll go to the construction. This is mandatory. We write sub new, and inside that we write my $class is equal to $_0. So whenever we will be using this constructor, okay, this method is specifically called constructor because it will construct each object instance. And the first argument is the class's name. Okay, so it will go to the class. Then my object is equal to, it is basically a hash. You can see the data structure. The name is the key and the value is $_1. So the next arguments are coming in this way. Then surname is the next argument, that is $_2. And the third is the roll number is $3. So this way all the arguments came and this gets stored in the internal data structure. Now this hash is been made. Now how we can turn this hash into a object with the place functions that we have written in the next line. Place, then syntax is the object, and then the $class. Now if you see the 3 lines, in first line we have defined the class. We got the name, class name from $0, and in the next when we get all the data and we punch the data into a single data structure, and we now are saying that this is a object of the class. The blessing functions does that. Now return object. So here I think we have reached the end of the construct. So this is mandatory. This syntax is mandatory for creating a constructor. So when this code will be used, this is a class we are defining to create an object. In actual practice, this will be used to create each object. So this is a common code. Now we can have different methods. Now say we can set name. Now it looks ridiculous. You have already saved the name, right? Then why we want to do the set name? Say in real life, you may change your name after certain time, which is feasible. So keep this particular set name. So, but in computer programming, it could be that you have made a typo and you need to correct the name. So that's why we are setting this name. Okay. And here we say that my obj, then dash, then right arrow. So you remember this syntaxes from the data structure in PERL, right? If you are not recalling, please go back and see the episode of data structure in PERL. Okay. So it is equal to $1. Why we have given, right? $0 always represents a class. We are skipping that. This is a convention. $0 will always contain the class name when we are in the object-oriented paradigm, and we have to use the $1. So that is name, and then 1. And we continue the code here in the second column, set surname. So surname, we could have done mistake and we want to make it right. So here again, we are writing $1. Now there could be a question. Okay, in previous, in the constructor, you have written that $2 and you are writing $1. So these are not same. So here that was a different subroutine and this is a different subroutine. So for each object-oriented subroutine, the first argument is the class and the second argument is how you choose to operate it. So the $2 is not always need to be the second argument or whatever we have defined. It is subroutine specific. The subroutine for the object constructor, the arguments will be different, and for the rest of the subroutines, the order will be the same. The first argument is class and the next argument how we want to operate. Okay, so if we had 2 arguments, we have written in a structure how we want to do it. And then set role. We could have done a typo and we want to correct it. Then again here $obj then is a role is equal to $1. So you can see that we have done the methods through which we can rectify the data. Now this is called an encapsulation. So you use methods to communicate to the object's own database. Okay. Now next, this was kind of, we are rectifying the data. Now we want to display the data. So we are writing a display code, display method here. actually turned a data structure into a class here by the base function, and the return of the reference is not giving a hash here. Instead, it is giving a student. So Perl is not fooling us. The object-oriented programming is actually turning a hash into a class. Okay, and you can see that this destroy structure has been called 2 times. Why? We have created 2 objects. So when we exit right, we have to destroy 2 data structure, first data structure and the second data structure. So destroy will be called the number of times equal to the number of objects that we have created in our code. So we are done with this slide. Let's move on. Inheritance. So we will create this inheritance here through an example. Before going, I have written the first parent class is a student.pm. Now we can have a separate kind of genre of students who goes for the internship. Okay, those will be a subclass or a subset of the whole group of students who bag the internship in a VLSI company. So that's why I have written this intern.pm. Okay, now how we call it, this inherited class, how we are defining it, we write here, let me bring my mouse pointer here, we write package intern. This is the basic definition, and then we write use parent student. So we are inheriting everything from the student, but there will be something different in the class itself. Okay. So next we use the regular Perl packages, strict and warnings, and next we have the constructor of the child class. Here we write again the sub, then new, and then class as usual the first argument, and next is that object, then class, then arrow, then super : new, and $1, $2, $3. Okay, so you can see here, let me bring my pointer again. So here we are creating the object, and what we are doing is that we are using, this is a class, and then class, then arrow, and we are using super : new. The super means this particular super class. Okay, the superlative class from which we are instantiating. So it is calling that particular function new. Okay, so we are actually reusing the code or inheriting the basic code that has been defined here. We are inheriting the code in this way. This is a syntax you have to put in your brain, and this is how you will write. Let me bring the next line. This is I have commented. This is a kind of overriding. This is overriding. Here I have not override. If you do this right, you will override the new of parent name at the rate then 1, then 2, then 3. Okay, like this. Okay, this is a kind of overriding. Now we write then obj, then company is code. So we have additional attributes here. In the parent, that is in student, this company was not there, because in internship when you will get a company name, right, in which you have bagged the internship, right? So here definitely this 4th argument is coming. Okay, 1, 2, 3, 4. Okay, apart from the class name, I am not talking about it. So 4th attribute here is the company name. These were same as the parent, and this is an additional. So this attribute comes as an additional attribute in the subclass. And now again, what we do, whatever we have written in the object structure, data structure, we are using the base functions to turn that physical data structure into a object-oriented data structure. So first come the object and then come the class name. So now the package is intern, so the class will be a type of intern. Okay, and we use the return statement to return the object. Why use the return? Because this is a subroutine. And next we write a sub display here, and we here again in this line I am instantiating the superlative or the parent display subroutine here by super : display. Okay, and also I am printing the additional. So here what is the benefit of inheritance is that I do not have to write the code explicitly again for all the thing. I just instantiate here display function that has been defined in the parent class. It will print 3 attributes, and for the 4th attribute we have to write this additional statement here, and this will create the display. So here again we call the destructor, and we close this Perl module. Okay, because this is a package, right? And here one thing is that here the display will display the internal data structure of this, and not of this but of this. Okay, but this will display whatever has been defined here. So this is way that we can reuse the code. Whatever we call inheritance means that we just inherit the code and we just right away use it. Let's move on to the next slide. Creating an object inherited class. Now we here start with, it's a separate file, so we again start with the hashbang bin Perl, and this is a path, and then we use intern and use strict. Okay, and here again I am checking whether using the test just again as I've done earlier. So whether to check whether Perl is fooling us or really turning the database into actual object or class. So here now again what we are doing, student1 new intern, then we write a name, surname, roll number and the company name, and next whatever we are doing std2 new intern and then name, surname, roll number and the company name, and we hit the display with the same kind of way we have done. So this display is the display that has been defined in the subclass, and we call student.nl. So here we can also use in this code area, right? We can also use the subroutine that has been defined in the parent class. We can also call it is valid. Next we call the display sub method for the second object, and again we are calling the NL in a different way. Now here we can use two new things, isa and can. Okay, I'll tell how and why these are used. Now we print again here. Let me bring my pointer. There are too much thing in this line. First we print the object name and then we check its reference type, and here we check whether it is a student. This means student1 is a student. Okay, this is an object. We don't know what is an object and what parent class is. So here we check whether it is a student, means whatever we are treating here is an intern, whether we are checking whether this is a student or not. Okay, so we are checking the parent class inheritance here, and we are checking that student1 can display. So I have separated with isa to check the isa status and can to check the can status. Output will be in the next page, so you will have to focus. So here I am using the can statement. It is checking whether we can use the method display. Okay, so next we do the same thing for the another object, and third we again print the hash reference type. Okay, so we'll check whether Perl is fooling us or really making a class or object. And direct change of the object name field. This is another way. Let me put the code first and then expect. So here what I will do, four things. Okay, let me bring the mouse pointer here. Here I am doing the name, directly storing this name, and in the 4 lines I am directly printing the data. So this is also valid. You can do this instead of going through method. Since this is Perl and this is a data structure, you can do it in this way. Let me show what comes when you execute this code. This comes the output. Here we can see the first 2 data structure, first 4 lines of code, first data structure, second 4 lines are from the second data structure, and you can check here it has been turned into a particular class, that is intern. Okay, it's no more a hash. Hash structure has been converted into a intern by the blessing function isa1 here. Isa means we are checking whether it is a parent class, it is a student, and return is 1 means yes, and can is code. So it checks the code exists or not. Okay, so and second case it's is also true, and third print statement it is showing that this is a pure hash. We can see again in this inherited case the data structure have different identity. First have the object oriented identity and second one is a pure data structure. So here we have printed the 4 lines direct access to the data structure that we can also use here in Perl. So now the beauty in Perl is that okay, this is a object oriented concept. I know you have done all the things, all the methods are here, but you have the privilege that you can directly access the data structure. Okay, here and destroy have been called twice here, you can see, because we have created 2 objects. The number of objects we create, the number of times the destructor have been called. So we're done with this slide. Let's move on to the next. In this page we are discussing the Moose package, which is installation I have demonstrated in the episode. You can click on the I button or you can look into the description. Okay, so how to use a Moose package. Once installed, we write our code and then we write our package name. Student2 here we are writing, and we assume that this file name we are writing as student2.pm, and here we write use Moose. How you will see that how this will become this Moose.pm makes our life easy in object oriented regime. It has only 3 statements to create the class. Now let me bring my mouse pointer and explain what is what. Name of the object, this is a class and it has name. That's how you can read. Name is ro, is a str, and default is nothing. This is 2 single quotes, not a double quote. Okay, surname is ro, is a str, and default is nothing. Roll number is a rw, it is a int, and default is 0. So you also define the data types, you get all these details, right, and we close it. So this is a very easy way you can look into the document documentation of Moose for details. I have touch based here. This is in addition to the actual object-oriented programming in Perl, because this is a kind of ready-to-use module for objects and classes, right? And you can create the data structure. Let me show how you now create an object. Here we start our code. Assume this is a different physical file. Use strict warnings, then use student2, okay? And here we write like how student1, then student2, then arrow new, okay? Name, then arrow, then surname, then arrow, then role, then arrow, okay? This is like how we write in a physical hash. So this is where we just write it and it's saved as an object by the blessing functions, all whatever defined inside the Moose. We don't have to care about it. Okay, this is a very straight way. Just you 3-line code for or 4-line code for creating a class, and then in 1 line you create the object. And next create the second object here. I'm using the same data values as that I have done in the earlier example. And then we can just use our direct access to the data structure to print the values, okay, in the same way, right? So if you see here, we end up right here. I have used the direct access of the data structure, then student1, then arrow name, student1, then surname, right? These are hash data structure, but actually this is not a pure hash. It has been converted into an object and class by internal inside Moose. So here I just access the data structure straight away, here also straight away, and finish it the code. And output will be like this. The name, the first data structure is printed here, the second data structure is printed here. So I think we are done with the particular Moose package. You can use it. Installation I have shown already. Welcome to another episode of free and open source VLSI software installation. In today's episode, we are going to install one particular Perl module, which is named file::t. And as you can see here, this is the URL. I'll provide this URL in the description of this video and can easily come to this particular URL. And now, before saying anything, what is this particular Perl module does is, if you want to write a log file, now what is a log file? People saying log file, the concept is that whenever any VLSI idiot tool executes, it creates two kind of log. One is the general log, another is the error log. General log is something that has all the general commands outputs, and if you are calling any particular VLSI tool that throws any kind of message in the screen, it is also get captured in the log file. So this is the general VLSI tools or software does that. But if you want to have this particular feature inside your Perl script, this module file::t helps you to do that. Now in today's episode, we'll see how we can install this in Perl through the cpan repository. And as we come to this particular page here, we can scroll down here. You can see the synopsis of this particular module. So you can go and you can see the description and all the APIs associated with it. You can by your own browse and explore all these options. Today's episode scope is for the installation. So I'll go straight to the point and I'll see what are the install instructions. So there are two set of kind of here you can use. One is the cpan aim, another is the cpan shell. Today we will use the cpan shell. Okay, let me open the terminal now. Let me open the cpan shell. Let me check the cpan. Okay, it is there. So let me execute. Now the cpan, you can see that shell has been opened. Now we have to execute the command. So this is install file::t. Let me copy it from here and I will right away paste it here. So this is the command. So another point is that I am right now online. Okay, so I'm connected to the internet right now, so that all the things will happen through the internet for the installation. So I have just hit enter and it is proceeding. Let me see what is going on. Okay, it is proceeding here. It's going on. Okay, so it is asking for the sudo password or the root password to provide it. Provided the password to the keyboard and you can see that the installation has been done. And here you can see it's okay, saying okay. So this module has been installed. Let me go through the entire log just for a scrutiny if there is something message for us. So let me check. and I think everything is okay. Result shows pass. Okay, fine. Wait. Okay, here it is saying installing Tee.pm and installing file PERL T. Okay, so it has installed the PERL module. In this particular episode right now we will discuss about the automation using PERL. So today our scenario is such that one particular RAR file is there in which there are multiple JPEG files. And all these JPEG file we have to convert in PDF. So at beginning this seems very easy. Okay, I have one particular RAR file and I'm going to unrar it, and through some PDF conversion application will do it. Now guys, stop here. The situation here is far more complex, because for 1, for 2, for 5, for 6 or for 10, it's okay that you do it by hand. But imagine if you are doing for 500 such RAR file conversion into PDF. Okay, we need automation. We cannot do it by hand. If you try to do it by hand, you will get fed up. So this is a practical example and you can try it at your end. And these are all using all free and open source tools. Please watch the episode, and in case you want to know or any install instruction, please write in the comment. I have another track for POS software installation. Okay, so in that I'll include any installation if you need. Let's move on. So goal of this automation, we have multiple RAR files. Here multiple means huge number of RAR files. Now all these RAR files we have to automate to create each corresponding PDF for the respective RAR file. Each RAR file contains multiple JPEGs. Those will go into the pages of the converted PDF, and this is our target. This is why the automation is needed, because the tasks which are cumbersome to do by hand, for 1, for 2 it's okay, for 100, for 500 or 5, for 1000 this will be a mammoth task and cannot be performed by hand. Now here let's move on to the next slide. The challenge is here, we have say 500 RAR files and we need automation, and the challenge is here guys, which I have not spoken about so far, is that the normal log and the error log. So definitely when you are running an automation with huge number of files, there could be mistakes, errors, or the file could be corrupted. You do not know from where you got a problem. So all things which are okay will go in the normal log, and all things which are not okay will go to the error log. So we need all these things to be clubbed into one particular automation, and that is the goal of today's scripting. Choice of our unit tools for this, what we are doing is first is the Unrar, which is a free and open source software, as you can see, by Alexander Rochelle. This can be installed. If you need to install our instruction, you just put in the comment. I'll add in our POS track. Okay, so plus we need Image Magic. This generally comes with the Ubuntu installation, or else if you don't have this in your Ubuntu or any other Linux package, please put me a comment. I'll add in the POS track. So from this particular package, we use one particular binary which is called convert. So it comes with the Image Magic package. Okay. Now all these tools are free and open source tools. So that means you can download and install them easily, and you can do it at your own machine. Okay, without any cost. Okay. So let's move on. Today's scripting, the automation, what we'll do, I'm doing a breakdown here. Also, you can call it a flowchart. First, unrar each RAR archive. 2. Convert all the JPEGs to PDF inside it. 3. Wrapper that can operate on multiple such RAR files. 4. Removal of extracted JPEGs to save disk space. And 5. Dump log for all actions. So this is the kind of breakdown. So let's do the code. So guys, we are at the terminal here, and I have created one directory called codes. So here, let me see what are the content. So here I have multiple RAR files, as I have said, and each RAR file contains multiple JPEG files, maybe 30 or 40 JPEG files, and those are bundled inside each RAR. And I have written the script as I have told you. So this is written in this particular file, makepdf.pl. So let me open it. let me describe the code here. First, as usual, we have our PERL binary, and then we have used string. Then next, in the next 3 lines, I have used one particular PERL module. Its name is file : T, and we have used quoted word T. And this module actually helps you to write one particular log file. Okay, now what is a log file? What I am expecting inside a log file. So in any VLSI or any professional tool, once you run, definitely it will create a .log file at the end, or .log or .list, anything with that name. So these log files generally contain information of all the running processes, details about the processes, and what they are echoing in the screen, all those things. And if something goes wrong, the errors or warnings, whatever we are seeing, they also come. So in this way, we want to make our code as a professional code, and we want such log files. So with the help of this particular PERL module, we are writing one particular make pdf.pl.log. So all the general echoes that goes to the screen or the printf, all those things will go into this log. And if we encounter any error, whether it's error in the Linux shell, or it's from the PERL module, or due to something in our code, or there is some issue in the RAR archive, or there is some issue in the conversion. So there could be multiple error warnings coming from multiple points. So all those will go here in this particular log. Now, as we move to the next part, here we are entering into our actual coding. So you have to do nothing more here. You can just finish these 3 lines, and this will be sufficient to create the log file. And next, we are entering into the actual code. So as I have shown you, in the directory there are RAR files. So I will use this backtick option to list out all the RAR files, and they will go into an array. And here I am taking count of how many elements in the array. If you have not watched the data structure episodes of PERL, please go ahead and see. And here in the next step, I am creating one particular output directory, which will contain all the output files, means all the PDFs. And I am using the system command to create that actual directory, that mkdir command. And here comes the point. In the description, I have said that there should be a wrapper which can operate on each individual RAR file, and after the operation on each RAR file finishes, it can go back to the initial condition and again operate on the next archive. This for loop will do that purpose, and from here till here we have the for loop. And let's see what are the segments inside this, what we are doing. So first, I remove excess characters using the chomp of the file name, or any new line character that is coming into the picture. Okay, here \n will be removed, and here I'm just copying it as the file of the directory, and then I'm using PERL regex search and replace command here, that is then \rar//g for replacing the .rar extension. So the directory will contain the same name as the name of the RAR file, but this RAR extension is gone. In case you have not watched the RegEx episode, so please go ahead and watch it. Next, we are just echoing something in the screen here, that is using the print command. And next, we are making the directory to extract JPEG. So there is a spelling mistake, I'm sorry for that. And here we are using the system command and mkdir to make that directory. And we are using the unwrapped binary that we have shown in the PPT, and with the option E. So this is the usage option, and then we give the file name, that is the RAR file, and the output directory. Okay, and we put a slash so that all the files go inside that directory when extracted. So when the extraction is done, it will go there. Now all this echo will go to the regular log, that is the normal log, or in case there is an issue when we are extracting, that message, error or warning, whatever is there, it will go into the error log. Next, once our extraction is done, we are using this particular convert binary from ImageMagick to convert all the JPEGs inside that particular directory. Remember, at a time we are operating on one single RAR archive. So whatever the files inside the DIR will belong to only one particular RAR archive. So all those will go here, and this is the usage instruction of this convert binary. So first, directory and the files will inside will go, and then we have to specify the output. So output will be .out, as we have defined the common output directory, then the directory name, that is the RAR file name minus .rar, and then we add \n and .pdf. So PDF will be named as like that. And once this is done, our process is done of the conversion, and now as the RAR is inflated, it will consume huge number of the JPEG files which are eating up the disk space. And here we are using our regular rm-rfv command using the system. So once this is done, we have reached to the end of the loop. So these 4 steps, 1, 2, 3, 4, will happen again and again for each and every RAR archive, okay, until we reached up to the last RAR file. And each case will create one PDF. So now it doesn't matter whether we have 500 or 5000, we can run it in using a script. Okay, now once this whole operation of conversion and deletion, space saving, everything that these 4 steps are doing, once we are out of the for loop, we are just echoing that process is completed, files are at the location out. So why I have written, now I know that I am using an extract in the output directory, but this code is created from the user benefit perspective. So any user, when they are using this, at their end they will get proper verbose information that what is going on. So I have made this script in a quite verbose fashion so that user will not get lost. So we are done with the script. Let's close it here. Let me run the script. We will be using /, then the name of the PERL file, and I think I have not given any arguments, command line arguments. So the script is at its own and it will find and do the rest of the things. So let's hit enter and let's see how it is doing. So here now we can see it is extracting the JPEGs and then it is converting to PDF. You can see one by one it is doing. You can see there, I think 30 around JPEGs inside each. So the extraction is done, then converting to PDF, and it is moving. It is doing very fast. Now this can go on and on and on if we have maybe 100 or 1000 numbers of cases. Now here you can see that processing has completed and files are at the location. Now let me do an ls. Here once I do the ls, I find that let me clean the screen now to the ls. So here you can see where we began, we don't have this particular output file folder and we don't have these logs. So let me open the logs again. I have made an alias G for JVim, so I'm using that, and here I open it. So you can see now this looks like your any professional log file. What I have not done here is that I have not given any header section of the log file that is generally comes under any of the professional tools. So you can add your own header section of the log file. Okay, that simply you can do a printf command that way once, that will go as a header. So here you can see these all our extraction is going on. So these are some non-printable characters are there. I think it's we don't need to focus here. And then extraction is done, then converting into PDF, then conversion is done. Now deleting the images. So when we are using the rm-rfb, d means verbose, where we can see when each is going deleted. So also at the end we see the remove the directory 133. Now this same process will go on for all the RAR archives. So you can see here the many of the RAR archive we add, all they have gone through the conversion. Okay, so here I pull it down. You can see all the info, all the printf and all the echoes in the screens of the individual unit tools. They also have been captured in the log file. Okay, so next I close this thing and let me open the error warning.log. Luckily, we don't had any error or warning in this particular run, and hence this particular file is blank. So in case you face any error or something, it will come here. So guys, I think now it's time to go to the output folder. Let me go to CD, then this one. If I do the ls, now here you can see that we had how many number? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 RAR was there. Now here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have corresponding 11 PDFs are here. So it took only few minutes to convert all of them. And what you have to do by your hand, nothing, just execute the script. So this is the beauty of the automation, and this way I have given a practical example which you can try at your end. You can use any other tools or anything like that. Okay, so this is how we can use the PERL automation in many cases. So this even in for VLSI, we run the VLSI tools in the similar fashion we use it. Since I do not have any of those professional tools right now with me, so I have taken a practical case which is feasible for me to run and show you all the things. But the methodology remains same. The coding idea of PERL's perspective remains same. Hey guys, welcome to Tech Simplified TV. After multiple requests, finally here is the much awaited series beginning today with the first episode on interview questions and answers in PERL in VLSI. Today and next few episodes, we will be covering few common areas from where the interview questions are asked in PERL. So stay tuned, stay focused and enjoy the learning experience. Hey guys, welcome back. Let's begin. First, I'll talk about the interview preparation. So whenever you think of interview, right, there could be two specific scenarios that you can take preparation from your side. The first one is generic or subjective. Means when you are learning a subject, any topic, say PERL programming or TCL programming, you are going in depth in that subject. So this is a generic or objective learning. And when you are taking your preparation in this particular way or a generic way, that has a different pattern of preparation. And there is a second kind of preparation for interview, that is specific or JD based. That means you have seen a job description somewhere in any job site and according to that you are applying in that particular job role. So there has been some email exchange and then the company is setting up an interview for you. So this is a JD based or very specific interview preparation. So in the first case, when you are doing a generic or subjective preparation, what you should do, you learn as much as possible from any learning resource that you find around you over the internet, or maybe it's a book. Whatever way you are learning, you learn. And the general way, you take notes of all these things that you are facing and you are learning from different resources. When you gather all these notes together, it will be a consolidated document that can help you further whenever you have to rehearse or when you have to do a retake of the entire thing in future. So this is way of handling when you are taking a preparation from a subjective or generic way. Now let's come to the second way, that is specific or JD based. So in that case, you must scrutinize the JD, say whatever things already you know, and if there is something that you don't know, you must seek the knowledge about all these unknown sectors. And if there is some connection in between your known and the unknown part of your knowledge based on that particular JD, you must bridge that gap and you must establish those connections with your known and unknown areas properly so that when you give the interview, it becomes very much seamless. So this is a generic kind of guide of the interview preparation, what I have just depicted to you, because the series that we are right now doing, that comes in the first category, that is generic or subjective. Obviously, the second one comes to the picture when you have applied to one or more jobs in that case. So things should be very much clear in your mind what you are doing and why you are doing. So when you are going through this particular episode, what should be your mindset, and according to that you are learning. That's why I have cleared your mind with two different types of preparation for an interview, and we are all set to go now. Let's move on to the next slide. Question direction. So guys, before starting any question and answer in an explicit manner, I would like to tell you one more thing. The question direction, it is a very, very crucial thing. It's difficult to visualize. However, I tried to give an infographics that you can understand. One question can be asked in multiple ways from multiple angles. Even if the language, say we are talking right now in English, even we rephrase a single sentence in different way, it may appear different question. However, the underlying fact is very much same as the answer. So when you are taking a preparation, don't just have a kind of lookup table in your mind that, okay, this is the question and this is the answer. You must apply your mind or push your mind to think what else way this question can ask based on whatever knowledge you have, whatever logics you have in your mind. So this is the purpose of this particular slide. We are done with the slide. So let's move on. Question and answers, page 1. The next couple of pages, there will be short question and answers. Each page there will be multiple questions. So let's begin. Hashbang user in PERL, -w. What does the -w means? This is a very common question. It means that the Perl interpreter will issue a warning wherever applicable during the code execution. Sorry for my typo. I have typed PERL, which should be PERL, Perl. This is the warning issue. So it's basically good for you when you are doing the Perl coding. Without this, there will be no warning. And I think there is another module like use warnings that we would use inside the code. Like we use useStrict, there is another warning module, use warnings, that also does the issuance of the warnings. So just now I have give you two angles of the same question. This can also be asked, if you are not allowed to use the -w, how you issue the warning? In that case, your answer will be, I will use the use warning statement, or I will use the warning module. This way, you should cultivate the things in your mind so that you have the full picture or the bird's eye view, how the questions can be asked. Let's move on to the next question. Are the variables in Perl case sensitive? That's a very important question. Yes, the Perl is very much case sensitive. So, if $var, that is in small caps, is completely different variable than $var, where var is in upper caps. The next question is how we can do a single and multi-line comment in Perl. Single line comment, I have shown you so many comments when I have gone through the Perl series in VLSI. Now, however, the multi-line comment, I think I have not shown any example. However, you can do it. Hash is a single line comment. Then what is the multi-line comment in Perl? So this could be another way of asking the same question. So here answer is there. The hash is for the single line comment. And what is the multi-line comment in Perl? One line should be with equal to 4 starts the multi-line comment, and you should not keep anything else in this line. So just this dash 4, not dash, this is equal to 4 and equal to cut. Okay, these two kind of statements will comment out any number of lines in between these two statements. So these can be used as a multi-line comment in Perl. So folks, we are done with this particular slide. Let's move on. What values of a variable is considered as true and false in Perl? Now this true and false is a very important concept. To us, the true and false is different. For a programming language, the true and false is again different. Now, 0 is the number itself is false. The empty string, that is only the two quotes are there, and the string that is 0 within single quotes are false. Okay, these two are false. Unref is false. Anything else is true. So these three lines which we have stated as false are false. There is nothing else counted or taken as false in Perl. Everything else is taken as true in Perl. So this could be even used in a if condition or somewhere else. How to execute a Perl program when you do not have permission of writing in a particular disk? So this is a very important and tricky question. So you don't have a write permission and you have to run a Perl code. How do you do that? By this way. If you write Perl-E, then print hello world, this is an example. So within the single quotes, the Perl code will go, whatever the code is, that will be executed without writing in the disk. This is the only way you can do the Perl code execution without any physical file in the disk. So this could be another version of the question, that without any physical Perl file in the disk, how can you run a Perl code? We are done with this particular question. What is the value by default associated to a scalar when it is declared but not assigned? So scalar variable you have already known, variables in Perl episode. What is the value? Default value. We have not assigned manually any value. So my $var, when it is defined as like this, it contains the value undef. This is the answer. So we are done with this particular slide and questions. Let's move on to the next slide of questions. Came as a repetition, I have just discussed. Move on to the next question. What are the data types in Perl? There is no separate type declaration for integer, real, double or float in Perl. This you might have seen in C or any other language that you have learned in college or maybe in an institute. Like that, Perl do not have any type declaration. Anything can be assigned in the value of a variable. So pi equal to 3.14 and then it continues. It's a real number. $animal is equal to camel is a string. $AB is equal to $A star $B. It's a mathematical operation. $out is backtick PWD is an output from a command stored in $out variable. So folks, you can see that there is really no predefined data types in Perl. Anything you can assign to it. This is another beauty of Perl. So this way, the Perl do not have any kind of reservation. That is what I will say for the types of the variable, and you can flexibly move inside Perl for variable usage. So we are done with this particular slide. So let's move on. State the difference in between my, local and our. So this slide contains single question. The answer will be captured here. Before giving the answer, I would like to mention one thing here, that this question can be asked in multiple ways. That what is the difference between my and local? What is the difference between local and our? And what is the difference between my and our? So you can do all these combinations in your mind. So let's look into the answer. A my declares a listed variables to be local to the enclosing block, file or eval. If more than one variable is listed, the list must be placed in parentheses. Okay, so if we are declaring multiple variables, we must keep inside a parenthesis. Otherwise, we can write my then $variable. In this way, we can define it. A local modifies the listed variable to be local to the enclosing block, file or eval. If more than one value is listed, a list parenthesis must be there. So this is for single and multiple declaration. Our creates a package variable, declares an alias for a package variable that will be visible across the entire lexical scope, even across the package boundaries. So these are the three basic definitions. Now, here I start with the example. So package foo, then our $bar. So this declares the $foo : bar variable. So, and it's the lexical scope. We can then assign $bar equal to 20, package bar. We write our bar equal to 30 and then print $bar. Then again our bar. This will emit warning but has no other effect. Next, we print the bar, it still prints 30. So my declares a variable, and wherever we define it, for that particular scope, it declares a variable. Generally, most of the time we use my. Local is if you are using a block or code. There you are doing some coding, say a for block or if block. Okay, so there you are writing. So you already have a global variable which is declared outside that particular block, and you want to have a local value of it, but you don't have to change it. So in that time you can use local, and our is used entirely for the package in. So this way, these three particular definitions are there. I'll suggest you to go through the series. There you will find examples, and accordingly you will proceed. Go inside the Perl in VLSI series, find out the examples, and in case you have some questions, you can ask in the comment section down below. Let's move on to the next slide. What are the reserved variables in Perl? $A and $B, special package variables when used with sort $A and $B don't need to be declared using use wires or our local, even when using the strict wires pragma. So this is a very important question. Some variables are completely reserved in Perl. You cannot use them when they are used in a reserved mode. The $A and $B, when we are using the sort, they are used as a reserved one. $, the default input and pattern searching space, it's a global variable. So this $, I have given several examples in the series. However, I'll be repeating some of them in a short and sweet manner. The following functions use $_ as a default argument. These are the list of Perl functions. These are predefined Perl functions. They use $_ as a default argument. Now, when you are using $_ as a default argument, you can use it as is, and there you do not need any kind of variables. So you can go ahead and do that. So this is very much clear to you, and the series I have given several examples of $_. The pattern matching operations, that is matching, that is in // or substitution like yes // or the transliteration, that is TR, then triple slash. Okay, all these things uses $_ in absence of the equal to tilde operator. This is a very good question, and I'll ask you to go ahead and search for examples in the PERL in VLSI series. In case you don't find, let me know in the comment. I'll give you the answers. The default iterator variable in a for each loop if no other variable is supplied. So for each loop uses generally one particular variable, that is iterator, right? So that is the main variable on which you iterate the entire loop. So there, if nothing is specified, the $_ will be taken as a default variable. So in all these scenarios, the $_ is used as a default variable. And one good thing of this, and which can be asked as a question also, that what you will do to reduce the number of variables in a particular PERL program so that your memory consumption, that is the physical memory consumption, is less. In that case, the answer will be $_ that we should use frequently. And here are the cases I have mentioned. You should instantiate all of the cases. You must take one example with you so that you can give an example if you are giving a face-to-face interview. Otherwise, if you are giving an online interview, in that case, you must keep an example handy with you so that you can speak it out. These are the reserved variables for PERL, and there are some more. We'll come to them. Guys, I have discussed the different ways of asking particular question. You must concentrate how you can approach a single question, that is a single fact, from different angles. That will broaden your mind and that will alter the thing in your mind so that you will be prepared to face the interviewer. We are done with this slide. Let's move on. We are continuing the answer here. @ within a subroutine, the array @ contains the parameter passed to that particular subroutine. Inside a subroutine, @ is a default array for the array operators pop and shift. This thing is very much important because $_ was a scalar, right? And in PERL we have non-scalar also, that is array or hashes or array kind of variables. The @ is the default variable. The %ENV, the hash %ENV contains your current environment variables and their values can be manipulated by this particular hash or associative array. So from PERL, we want to access the entire system variables that are in the Unix shell. They are defined there. So this, the %ENV is a reserved one. You cannot use this for any other purpose. This is a reserved variable. @ was also a reserved variable. $_ is also a reserved variable. @inc, the array @inc contains the list of places that the do expr require or use constructs look for their library files. It initially consists of the arguments to any -l command line switches followed by the default PERL library, probably user local libpart. So it looks for the command line switches. Next, ISA. Okay, ISA is a specific variable. Each package contains a special array called @ISA, which contains a list of parent classes, if any. This array is simply a list of scalars, each of which is a thing that corresponds to a package name. The array is examined when the PERL does method resolution, which is covered in PERL object. Guys, I have one entire episode on PERL object. Go ahead and watch that. You will understand this particular ISA variable, that is @ISA variable, and you will understand the usage. Now in interview, when a question starts, a question can bifurcate from any answer that you give. So you must be prepared for that bifurcation and going in further details in a different direction from where the question started. So this is another thing that happens inside an interview. So here, that's why I'm giving the pointers where it can be hooked. And from this particular point, there can be a branch out. So you must be also prepared for all those branch out. Reserve variables for argument. Okay, so here we are talking about argument. $, the process number of the PERL running your present script itself. So if you are running a script from Unix shell /something.pl, the $, is the process number. $0 contains the name of the PERL program. So abc.pl you are running, so abc.pl goes to $0. Then digits, $1, $2, etc. contains the sum pattern from the corresponding set of capturing parentheses from the last successful pattern matching, not counting patterns matched in the nested blocks that have been exited already. So this comes from the pattern matching, that is m// or S, triple slash, all these things, that regular expression area. From in that particular area, you have the $1, $2, etc. So get the more details, please watch the regular expression episode. There you will get all the details. Just now I have mentioned that if once you give the answer, the question can bifurcate and go in further details. So it's not always a simple question and a simple answer. It can have multiple branch outs. Then %, the string matched by the last successful pattern match, not counting any matches hidden in a block or eval enclosed by the current block. This is again pattern matching. Please watch the regular expression episode. We will get the details. $argv, that is argv, contains the name of the current file when reading from the diamond operator. @argv, the area @argv contains the command line arguments intended for the script. So these are done. All these things are very good enough. So please focus on each of the bullet, where each bullet expands into a next level of detailing. When you are asked if you give a particular answer, right, you must be prepared for the further bifurcation that goes to details of that specific area. So all these things are reserved variables. I think last 2 slides also I have spoken about the reserved variables. So when you see all those things, we must be also ready for the entire theory. We are done with this particular slide. Hey guys, welcome to the second episode of interview question and answers in PERL in VLSI. In a recent poll, you folks have voted and conveyed me that your learning curve accelerates more with examples. Hence, more examples are being stuffed into this series. So stay tuned, stay focused, and enjoy the learning experience. Hey guys, welcome back. In today's episode, we are going to discuss what is interpolation in PERL, why we use the useStrict module in PERL, difference between top and tomb, both theory and example, difference between concat and join, both theory and example, difference between use and require, how to localize a variable in PERL, how to read a file directly into an array. So folks, in today's episode, we will be discussing all of these topics. So without any further delay, let's begin. What is the interpolation in PERL? As I have mentioned in previous episode, that this particular question or any particular question can come in multiple variants. So when you are going through this particular episode or any episode in this series, keep in mind and do cultivate thoughts in your mind so that how this question can be asked differently. The reason behind, many people understand the thing from different application aspect, and all those aspects are different angles of asking the question. So let us move into the detail. Double-quoted strings are interpolated. Any variable names found inside the string will be replaced by their value. Let us see some example now. My $animal, and we write within double quotes camel. It's a pure string. Now my $, I love $animal. Here we are doing the interpolation with the $animal variable. In a contrast, you can see that my $cost is a single quoted string, and it writes it cost $100. Here $100 means $100, and in the above line the $animal will be replaced by the string camel. This is called interpolation. Also, we take another kind of interpolation here, which comes through the backtick. That is, if we write anything within the backtick, the output value of that execution will come into the string. So this is another kind of interpolation. So folks, these are few examples you can culture and cultivate inside your mind. What else way these questions can be asked? So we are done with this particular slide. Let's move on. Why we use the strict model? Now, this question has another variant, that is why useStrict is a must while using the PERL data structures. Let us see through an example. We start our code with the hashbang user being PERL, then we write useStrict, and then we write a data structure here, and you can see that I'm populating the data structure. Yes, this is a array, and this array is not a direct array. Instead, we have a array pointer, that is referenced array. Hence, the name is my aref, and inside that we have also array of array. That means all those things are array, and those are also referenced arrays. I have discussed these things already in the PERL in VLSI series. You can go and find that particular episode in which I have spoken about the arrays or arrays of arrays or referenced array or direct array. You can go ahead and pick that episode from the playlist. Here, if we write print command with $aref22, what will happen? And we execute the code. And the code will throw an error message saying global symbol @aref requires explicit package name. Did you forgot to declare my @aref at accident.pl in line 9? So when I have saved this particular file, I have saved with the name accident.pl because we are doing an accidental mistake here. So by looking at the line print $aref, it looks everything fine. However, okay, there is another line of the error, execution of accident.pl aborted due to the compilation errors. So this way, the strict module throws an error when something is wrong. To understand what is wrong, we need also the reference what is right. We have to change the print command to print $aref, then there is a dash and then is a angular bracket pointing towards the right and then 2. So this way we actually dereference the value. I have already discussed in the data structure episodes in PERL. For details, go there and see those episodes. So this way we have done an accidental mistake. Let me bring me my mouse pointer. Here we done a accidental mistake that we missed out this particular arrow. I will say arrow symbol. So arrow symbol we have missed out. Rest of the things were fine, and by our glance human eyes this don't appear as any error. However, this is a syntax error in PERL and that should be cached. Because of that reason we use the strict module. So that strict module picked up this error and it has told us that you have done a wrong here. Now it did not say what we have to correct. That is our knowledge that we have to enhance, and that's why the entire PERL series is there for you to learn. So here you can see that the correct one is this. So this way not only the variable scope but also the mistakes are captured by the strict module. So I think it is a very explicit example. We are done with this particular slide. Let's move on. Difference between chop and chomp. Just to remind you, this is a very common question in PERL because the names are very similar, chop and chomp. This question comes, I think, in almost every interview. The chomp function removes only the new line character from the end of a string. This is very important. This chomp line is used for truncating the \n character at the end of a line. Whereas the PERL chop function removes last character from a string regardless what that character is. The last character of a string is removed by chop forcibly. It could be a \n, it could be a \t, it could be any simple alphanumeric character, whatever it is. So that will be removed. So this is the basic difference. Now let us see with an example. Here goes our code in the pink box and our output comes in the black box. Start the code with #, user in PERL, then use strict, then my $var. $var is equal to Mary had a little lamb, then chomp $var. These are two different statements I have clubbed in one single line. However, you can write them in two different lines. So here what I am doing, that I am using chomp on that particular line where the last character is a \m. That is a new line character. Now when I print this, the output comes as Mary had a little lamb. And now you can understand why I have used so many equal signs here. Because if there was an new line present, so this after this thing, all these equal signs would have come to the next line. So that has not come. So that means the new line character has been cut out. Now we again reinitiate the variable with the same string and we operate it with a chop. And we print it and we get the same output. Now here in this case, in both the cases, we have to remember that the last character is \n here and hence we are getting the same output. Now if we have a \t, that is a tab character at the end of the string, and we operate it with a chomp, what happens? It stays. And if we operate the same thing with chop, what happens? It is gone. So by these four outputs, you can see that chomp can remove a \n, but chomp cannot remove a \t. So here you can see that there has been a tab character entered here. So the equal to signs have been shifted rightwards. However, in the chop, it has eaten up the \t character and no space or tab is showing here. And we go to the next example. we write in the same string without any backslash in or backslash t at the last. Now we print it, and what we see that the string is undisturbed. So from beginning to end, the string is intact. Now what we do that we operate the same string with chop, and we print the output here. You can see this chop has eaten up the last alphabet or the last character, whatever you say, or the last placeholder, whatever you say. That thing the chop has eaten up, and you can see that E has vanished from here to here. So the chop has eaten up the E. In this way, by these explicit examples, you have understood what is the difference between chop and chomp. So I have shown you all the cases. However, you can practice with multiple cases and scenarios at your end. You're done with this particular slide, so let's move on. Difference between concat and join. Here, concat and join both are used to teach more than one strings together. Now by this line it seems that okay, concat and join, they are doing the same thing, right? Is it? We have to see. Now concat is used in very straightforward, and it's a binary operator. When we say binary, means this is an operator and it uses two of its input values on which it operates. Join is a PERL function. It's a library function. It is not an operator. To join contents of a list or array into a string. We are done with the theoretical details. Let us see some example. In this box, pink box, the code goes. In the black box, the output will come. So here you can see the first line is has been user bin PERL. We use strict module, and then we write str1 is string variable. That's why I have abbreviated it as str1 equal to happy, and then str2 is space, then birthday. When I'm joining, I have kept a space in between. First, let us see the concat operation. My str3 is equal to str1 dot str2. So this dot operator is a concat operator, and it is joining str1 and str2 together and keeping it inside the str3. And if we print str3, it will give us the output. We'll come to the output later on. Now let us see the join operation. We have an array declared my ARR equal to happy, morning. Morning has a space like this one, like birthday, there is a space also. I want them to be joined, so I have kept a space in between. And by the join operation, what happens that we write str4 equal to join, then here we give a backslash, then space. So you're joining this with respect to space, so backslash space and the rate add. We are done with this one, and then we print. So let us look into the output. First one is happy birthday. So this comes as a happy birthday str3. So here these two strings have been joined, and here these two strings have been joined as a happy morning. Now you will say, okay, we have joined two things. Why we are using both of them? The answer is here you can join multiple strings with concat operator. You can go on, and here you can also go on increasing the length. However, when you are having an array, if you try to do this operation, it will be writing some additional code, like you have to use some for loop or while loop, and then you have to do. However, it's become a very easy and short and sweet method to use join at that particular time. So you can think of other scenarios and let me know. Keep me posted in the comments, and we are done with this particular slide. So let's move on. Difference between use and require. Here in this table, we have side-by-side comparison of use and require. The use, it can load .pm modules file only, whereas the require can load both libraries and modules. For use, we do not need any file extension to be mentioned. Like we have used just in slides ago that use strict, so don't use the extension there. For require, we need to specify the file extension. For use, it loads the file at the compile time. For require, it loads the file at the runtime. Although we do not compile by our hand, but PERL internally does these things. At that level, use is used at the compilation time and require is flattened at the runtime. So use is flattened at the compile time. Whatever you use strict or something, that is flattened. The code is flattened at the compile time, and require, it is flattened at the runtime. So this is the basic difference between use and require. And just to remind you, this is also a very frequently asked question in any PERL interview. So keep this in mind. We're done with this particular slide, so let's move on. How to localize a variable. Here goes our code, and here goes our output. Start our code with user bin PERL, and we write $var equal to 100. So just notice we are not using the strict, because that has some restriction over using the local keyword, and to demonstrate the local keyword here, we are removing intentionally the strict module. Now $var equal to 100, and we can print it at outside, and then we write a array with a QW, that is quoted word function, and we write a for each statement just to iterate. It's just for a iteration and creating a block, nothing else. We use a $element which is picked up from array, and here we initialize local $var10, and here we print number equal to $var and the element that is from array on which we are iterating, and we close the for each loop. So you can see the code, and here we print a \n. That is a new line. It's just for formatting the output. This line. If you look here, the value is 100, and here inside this particular code block, we have localized the variable with value 10. Now let us see what is the output. So first, when this particular statement is executed, the output shows that number is equal to 100. This is at outside. And once we execute the for each loop, right, there we can see that number is 10, and these are the elements on which we are iterating. So this way you can see that we can use a local keyword to localize a variable within a particular code block. It could be for each, it could be while, any kind of code block. And another thing is that we are not using the strict pragma here. So we are done with this particular slide. Let's move on. How to read a file directly into an array. This is a very good question, because if you have seen the file operations, there we use a while loop, and we use iterations of that loop just to populate from a file. Now this question is an interview question. It can be asked that how to read a file directly into an array. Here we go with our code, and here the output will come. So let us start our code. Hashbank user being PERL, use strict. We are also using another module called data dumper. It is used for easy printing of any kind of PERL data structure. I have already given several examples in the PERL in VLSI series. You can go ahead and watch that series. Every now and then in the data structure printing, I have used this, and I think this comes as a default installation in the PERL. Now we write three variables. We initialize two variables, that is my $file. It's a file handle. You can see it's in upper caps. We maintain this particular convention to separate them from regular variables. And also we have my @lines. It's an array which will contain the lines from a file. Here we read a particular file with the open file command, and the content of the abc.txt which we are opening is displayed in the yellow box. The text will be first line a quick, then brown fox jumped over a lazy white dog. So this is the entire text, and there are 1, 2, 3, 4, 5 lines inside the text. How do we read this particular text file in one shot? This can be another variant of the question, how we can read a file in one shot. Here we go. We write chomp my @lines is equal to $file. With this particular single statement, what we are doing? We are reading the $file, the file handle file within the array. Directly, the content of the file is going directly inside the lines, and the chomp variable is removing the new line characters as mentioned few slides back from each of the line. Then we close the $file. Then in dumper, we give the \@line. So this is the syntax for giving a reference to the data structure. With a \, we make a reference, and that reference should be passed to the dumper module. And when we print this or execute this code, the output comes as the array elements that have been printed in shape of a array structure. So this is the beauty of the dumper module. It prints exactly as is, like the data structure when we construct it. So with this example, you have now came to know how you can in one shot read a file with less amount of writing a code. There could be many variants of this question, how you can read a file in single line, how you can read a file without using a while loop, how you can read a file directly into an array. So all these variants could be there. Answer will be this one. So we are done with this particular slide. Hey guys, welcome to the third episode of Interview Question and Answers in PERL in VLSI. In a recent poll, you folks have voted and conveyed me that your learning curve accelerates more with examples. Hence, more examples are included. Today's episode covers Q&A including valid or invalid array, hash formats, and all about referencing or dereferencing of various data structures in PERL. So, stay tuned, stay focused, and enjoy the learning experience. Hey guys, we are back in our computer screen and here is our menu for today. Perl array versus C array. That is the first topic that we are going to discuss. Next we are going to discuss different format of array. I'll provide a list of different formats of array and I will let you to pick the invalid one. Scalar versus $hash operations in array in Perl. Two-dimensional array and array exhaustion in Perl. Next we discuss hash or associative array related questions. Next we will go for the questions that can arise from referencing or dereferencing in any of the scalar, hash or array. Finally, we will discuss what is glob-ing. So folks, here is the menu for today. So without any further delay, let's begin. Perl array versus C array. Now, this is a kind of header in which the discussion may come. However, the question can be asked from different angles. Generally, the college students learn C as their first programming language. Nowadays, in earlier days, generally it was the language basic. However, that is now not in much question. However, the first language that you learn in college, that is C, and somewhere C and C++. So this question will come barging at you. If you are a fresher, then this question can be asked to you. State the basic difference between the array in C language and array in Perl. So here I am going to give you a broader level difference. However, there could be many minute level questions can be asked. So take this slide as a pointer and do your own research so that what are the different angles that from which this question can be asked. In Perl, array or list are of variable length. Whereas if you see the C language, we have to define the array with a static length. Now, in Perl, array or list can be declared without length. This is not at all possible in C language. At the beginning, during the declaration of the array variable, you have to also mention length of the array variable. Now, here could be a question in C that may arise about the dynamic allocation. Okay, I'm not going in depth because I'll have to enter the C language then, rather than I'll stay in Perl. I'm giving you the pointers that you can take and do your own research and be ready and be prepared for your interview question in this particular topic. This length can vary even after creation. So we have declared array in Perl and later in somewhere in the code, we can vary its length, which is however not possible in C. Array or list can contain any sort of scalars, even a combination of strings and numeric etc. That is, it is heterogeneous. Yes, in Perl, we can mix up string and integer, string and real and integer, all those kind of mixtures we can save inside array. However, that is not possible in C. So you must side by side open up your C language book and keep this tutorial in the other side and compare what else are the basic difference between the C array and the Perl array. Next question. You can be asked that is the below is valid or invalid? The statement is mine @array3 is equal to within curly braces, that is first bracket, array1, array2. So is this at all valid? Is it a meaningful line? Or you can be asked what will happen to array3 if we write this statement. So the question can come from different angles. Next, it merges the two array in the right hand side into a single array at the left hand side. So hence this statement is not invalid, it is valid, and this is what this statement does. So we are done with this particular slide. Let's move on to the next slide. Pick up the invalid array. Now, in last slide, I have just spoken that there could be many variation, that is many permutation of combination what we are stuffing into an array. Now, this page contains the question. In the next subsequent slide, we will come at the answer. So let us look into the question first. Pick up the invalid array, and what the arrays are. First one is a simple array that we have 1, 2, 3. Second one, we have one string and one real number combined together inside the array. Now here what we have two variables $b, $c and one constant, that is 21. This is a blank or empty array. Now here we have 1.5. This means there will be increment by integer 1 starting from 1 up to 5. So it will be expanded like this expression. Next, we have a combination of this range operator, that is 1.3 and 11.13, as well as a constant, that is 7. Next we have $b, $c. Next we have an array with all strings as elements. Now we are writing a QW, that is quoted word function, and giving the same elements as we have given in the first line. So this forms our question. So this can be asked you in the question. It could be a oral question or it can come as a written question. It depends how your interviewer sets the question. So far in this series I have discussed many things. So don't expect that everything will be asked in a oral fashion. There could be even a written version of it. There could be a even MCQ version of that thing. So basically people what do when they set the interview questions, they get the main data and transform into a question which is kind of create a puzzling situation to your mind. So that is the purpose of the interview, that in a puzzling situation can you pick up the right answer or give the right answer. That means your basic knowledge very enough strong or strong enough to counter those puzzling questions. So that's why in this series from the beginning I am saying there could be multiple angles or multiple ways a single question can be asked. If your mind is in an alert position and your mind knows that I know the answer, however the question can be different, then you will, after listening to the point or after reading the question, that is after listening to the question or reading the question, your mind will give a pause and it will think, is that particular question which I already know the answer. Your mind can connect the question and the answer. The answer is in your mental database and the question is coming from your interviewer. So this way the thing can go and you can actually win your situation, win your exam, win your interview. So here what happens, this is a question and there are all sort of variations we have given, and the question is whether any of them is invalid or more than one is invalid. Let us see. Now before going to the next slide, what are the thoughts coming in your mind? So theoretically go into everything and check? No, you are right now doing the preparation of the interview. You are not giving the interview right now. So your preparation, you have the 360-degree flexibility of trying a PERL code in the PERL interpreter. Do this whenever you have a thought about some question or answer. Go ahead and write a PERL program and execute it in the PERL shell, that is PERL interpreter. We are going to do that in the next slide. Here goes our code, by the pink box. First we have the hashbang user bin PERL. Next we are using strict, we are using dumper module, and we give some value to $C and $B and we declare it also. So this part will not be there in the question. So this could be a tricky part also. You can answer that if it is A, B and C is declared, there will be a situation. If B and C is declared and not assigned, then it could be a different situation. And if they are defined and assigned to a value, then there could be a different scenario. So from one single line, there are 3 different cases I have already discussed. So now let's proceed for the next lines. Now here array 1. Then I just keep on adding them because you already seen these things, no need to narrate them. And after writing this up to this one, because this already in the question, what I do, I use the dumper module to print the different arrays so that I can check which one is invalid. So PERL interpreter is the best one to do the judgment. Once you practice during your interview preparation, right, then you are quite confident that okay, this will happen or that will not happen. Obviously, definitely you go to the PERL documentation and read in detail, because the theoretical background that you have to also represent apart from your practicing. The practicing the code in the interpreter gives you first level of confidence. The second level of confidence comes when you go to the PERL documentation and read in detail. So once we execute this particular code, what we get? First array 1, array 2, array 3, second array 5, array 6, array 7, array 8, array 9. So I think I have missed out array 4. However, array 4 was also in good shape. So I think array 4 I have missed out, but in the actual code I have printed out. If you execute, you will get all these outputs. So here, after we get all the outputs, we can see that there is no array in the provided list are invalid. So all of them are valid. So there is no need to worry. So you keep all these kind of variants in your mind, because when you are going to give the interview or when you are giving a written exam, this interpreter or this video will not be waiting. So you have to memorize everything. But right now, when you are watching this video, you are preparing for the interview. You can go in a 360-degree flexibility. You can go try out the code. You can go ahead and read the PERL documentation, everything you can do. But in actual, that is your stage performance, that is when you are giving the interview, at that day, at that particular time, you have to keep everything inside your mind. So folks, I think we are done with this particular slide. Let's move on. Scalar versus $hashing. array. So scalar is a function, Perl function, and $hash is another way of reaching to whatever the scalar gives. So let us see what they are. So the question can be that state the difference between scalar and then add the array, and $hash then array. So what is the difference? Scalar function gives the array length, that is how many members are there in the array. Next, what the $hash then array gives the index of the last element of the array. So if there are 5 members inside the array, it starts from 0 and goes to 4, right? However, now counting from 0 to 4 will be 5. However, when we use the $hash, we will get 4. That means the output is numerically different. In first case, it will be 5. In second case, it will be 4. However, they are interpreting the array. They are giving you the almost same data about an array. However, their method of detection or the output is different. However, both are related to the array length. So go ahead and try out this in a Perl code, and don't forget to comment down below. Now let us move. Please let us know if this is valid. This is the second question. It's another question. So we have given two strange notations, that is $array, and then within the rectangular bracket we have -1 and -2, and you are being asked whether it is invalid. You can go ahead and define an array and write a Perl code and try out. That is the first thing during the preparation stage that you have to do. Just don't read the books, because it's code. It's a code, you can practice it. Go ahead and practice it, and that will actually pin the thing inside your mind in such a way that it will never delete. Now next thing is, both gives the element of the @array from the backside. So it is another way of reading the array elements, not from the front side but from the backside, that is from the last element. So for your knowledge, I'll suggest you to write a Perl code, simple Perl code, define an array with 5 elements, and then go ahead and print these two things. So print without the minus symbol and with the minus symbol, so you will understand the difference. It's your task, do it. So you're done with this particular slide. Let's move on. Two-dimensional array. Hey guys, don't you think this slide looks a bit stranger? Yes, because when you are in interview, right, the things that will puzzle your mind and you have to come out of the puzzle, that is the main thing inside the interview. So you know the concept of two-dimensional array from your C language. However, in Perl, what is it? This question can be asked in different fashions. So when you see this particular line that is @array 2,4 is a two-dimensional array, so immediately your mind goes back to some time point backwards and have the C array concept where we defined a two-dimensional array. However, this looks the same. However, Perl do not have a two-dimensional array. No, this is called array slicing in Perl. So the question can come from a different perspective that state the difference of array slicing and two-dimensional array in C, while the array slicing is in Perl. So many directions the question can come from. Now we have an array here. Here if we write that the array 2,4, it is not the two-dimensional array. It is $A2 and $A4. So here in the array we have 1, 2, 3, 4, 5 elements, and the index value 2 and the index value 4. These two elements will be there with this array slicing, that is @array 2,4. Now how we can get it? We write a sub array, right? That is, we write a my @sub array equal to @array 2,4. This will give the new array that will contain the jackfruit and mango from the above original array. Now we write another sub array, that is @array 2.4. This will give 2, 3 and 4, and the elements of the sub array will be jackfruit, grape and mango from the original array. So if you see these two things, these two examples, even the question can be asked in different forms. So either one of them or both of them can be included, and this question may come from any angle. So you have to cultivate the angles inside your mind, and that's why you are getting armored for the interview board or interview table. This one is done. The next question: how you can sort an array, numerical ascending or descending order. If you recall that in C you have some algorithm like bubble sort or something to use in way to do the sorting. So that question can be looked here your C language bubble sort or something other sorting algorithm that can be clubbed with the question. So get prepared for that also. That gives a different angle of approach that an interviewer can ask about this question. Now, just in Perl, what we can do, we can use this syntax. Then that is in the left hand side will be the sorted array, and we will use a Perl function called sort, which in curly braces takes an argument that decides whether we are doing the ascending or the descending sorting. So A and B, alphabetically A comes first and B comes second. So this will be the ascending order sort, and right hand side will be unsorted. And again, if we write the reverse, that is B comes first here in the curly braces and A goes in the next position. So you have to write the syntax as is. You should not change anything. You should not use other than A or B, because A and B are reserved variable. I have mentioned earlier also, there are some using variables. Here you can see the example of a using variable in Perl, and you cannot change a reserved variable. Do not use any other syntax or other variables here, or do not try to even declare these A and B, because these are reserved variable. You can just go ahead and use here in this sorting algorithm. So if you write the alphabetical coming first, that is A at the left hand side and B at the right hand side, it will be ascending order sorting. And if you write $B in the left hand side and $A in the right hand side, it will be descending order sorting. So you can keep the alphabetical order in mind, and hence you remember whichever is in the alphabetical order, it will go in the ascending order, and which is reverse of it to the reverse, that is descending order. We are done with this particular question, so let's move on. Array exhaustion. Now folks, for beginning anything, what is array exhaustion? When you are doing some process and the array get exhausted because of some process or some operations on that array, it is called the array exhaustion. So the question can come in this way, that tell me what are the LHS values in each of these case. My $first, $second is equal to @array. Then first, then @rest, then array. So you can see in the first line there are two scalars. In the next line we have first one scalar and then one array, and right hand side we have the same thing, that one array. In the third line we have the reverse. The first element is an array and the second element is scalar. Now the right hand side remains the same. Answer: first, second, and right hand side is equal to @array. So before going detail in the answer, there are three lines, that is first, second, and third. So these three are asked to you in the interview. Right now you are doing the preparation, so you must gather the knowledge and store it in your mind. You can try it out with the code. That is the first thing I have already said to you. And then pin all the things in your mind and get ready for the interview table. So answer begins with the line, first line. I have already displayed this one. The first and second are assigned to the first and the second element of the array. This happens to them. You go ahead and try out with the code and let me know in the comment. Now in the second case, what happens? $first is assigned to the first element of array and the rest is assigned everything else. So rest of the array will go and sit inside the rest array. In the third case, we have the first element copy and then the $dummy. What happens? In this case, $dummy is not assigned. Now this is strange. You say, okay, in the first cases, the first and the second, they got justice and this is an injustice. No, it is not injustice. It's a code works in that way. Array are variable length, so copy has no reason to stop, because in the first element we have an array, entire array goes to the copy and sits there, so nothing left in the right hand side, and the $dummy is unassigned. Hence the $dummy ends up with the undef, since the copy eats up the entire available array. You can go ahead and try out with the code and print everything. This question, the prime topic was, or the main theme was, the array exhaustion. However, this question can be asked in multiple permutation combination of these three statements and asked you without even mentioning the array exhaustion. So you must be prepared for all of them. You're done with this particular slide. Let's move on. Hash or associative array related questions we are going to discuss. Here, first question, how you can access a key value pair at once, that is using a single command. That is a one-liner. This is the way. So here we can write y $key, $value, each then %hash. And here what we get key, then $key has a value is equal to $value. Okay, so key and value is there and they will come from the hash with the function each. Let me bring my mouse pointer here. So you can see here we have used the each function on hash and we are using the while. So this is true up to the point hash is just exhausted. In the next iteration, it will become false and it will come out of the loop. That is while loop. So here the key value pair is coming out. So print $key is the key and $value is the value. And we close it. So the first question is done. The second question is how you can convert an array into a hash and vice versa. So conversion of hash into array and array into hash. First, if you write my @array in the left hand side and put a equal to sign and on the right hand side you write a hash, percentage hash, any hash, it converts a hash into an array. Simple. Next, if you do the opposite, that is if you write the new hash that is on the left hand side and array on the right hand side, it converts the array we have just created in the previous line back into a hash, provided in each case the elements in the array are even number. So this question has a catch and very important point to discuss, that is if the array has even number of members, only and only in that case this vice versa conversion is possible, otherwise it is not possible. So we are done with this particular slide and two questions. Let's move on to the next slide. Here we will be discussing about referencing and dereferencing. Let us see the questions. For unknown reference, how you can check what is the corresponding data type? This can be asked for a tricky question or even for an experienced Perl programmer. You are debugging a code and there you are having some reference and it's a kind of nested code. There could be multiple Perl files which are interconnected and talking to each other and you do not know from where this particular reference came. In that particular situation, how do you conclude what type of reference this variable is carrying? So whether it is carrying a scalar reference or whether it is carrying a array reference or whether it is carrying any hash reference. So how you can conclude? So I have given already two different way of approaches of the same question. There can be many other approaches or how the question is represented to you. The answer is we have to use a Perl built-in function called ref in the following way. Print, then ref, then scalar ref, then there could be array ref and there could be hash ref, okay, and constant ref. Sorry, the last question came. So this way, if you print any using the reference function, if you print any reference, it will immediately say what type of reference it is. So you can use this simple method to determine what type of reference is there in the code or is given to you. Now let's move on to the next question. How do you dereference scalar, array or hash reference variable? So we are talking about dereferencing. Means we will be getting the value where this reference is pointing to, the stored values at that particular location. For scalar, we can use my $dereference values. That's why I written deref is equal to $scalar ref. We add a $sign to the scalar ref. Next, for array, what we write? @ symbol just before the $array ref. So you can see for next one, for hash, we have percentage $hash ref. So in the three examples, it is very clear to you. For scalar dereferencing, you can use a $, symbol to dereference it, and array, you can use an array symbol, and that is @ symbol, and for hash, you can use a percentage symbol to dereference it. Now, these two questions in this particular page can be combined. That for an unknown reference, you have to determine its reference first and then you have to dereference it. What will be your Perl code? Try the code at your end and let me know. I can give you some hint that you can use the ref function at first and based on the value that you give, you can do a regular expression matching and then you can have some if-else conditions to dereference it. So I have given the hints, you can write the code because this particular tutorial is just to enable you with the Perl expertise. I think sometime rather than giving a direct example, giving a pointer and doing your exercise at your end makes you much more stronger. Here we are done with this particular slide and two question and plus their combination. So let's move on to the next slide. Here in this slide we are continuing the question from referencing and dereferencing. How do you dereference an anonymous array elements? accessing a value. So here, if we are using an anonymous array, if you are not familiar with the anonymous array, go ahead and watch the data structure episodes of PERL in VLSI series in this particular channel. Access the playlist, and in the playlist you will find it by the thumbnail as well as the title, everything. So here, first what we do, we print the $array_ref, then we put an arrow symbol and then 0. So this is accessing a value. Then $#ref, then we put an arrow and then key, assigning a value. So this was accessing a value. $array_ref, then 0, then equal to January. So it will set the 0th index element of the anonymous array with the value January. Now #ref, then arrow, then key, and then we write the value string. It will set the value of the corresponding key in the anonymous hash element. So this way we can access a value or assign a value for anonymous array elements. So I have given both array and hash examples here. So let's move on. Without using the loop, how can you print a complete data structure in the STDOUT? This is a good question. Generally, what we do when we have a language, C language knowledge, what we do that we use a for each or for loop. C don't have a for each. C has only for loop. We use the for loop to iterate on the array and print the elements. However, in PERL, there is a for each loop, but that is again a loop. We can use for as like we have used in C. However, in PERL, we have a smarter method, and in practical programming in industry, we use this module every now and then. We have to use data : dumper, this particular module. And when we have to use the print command, that is print, then dumper, then reference of that particular data structure. So this way it will print out the entire data structure. In your STDOUT means in your terminal. If you don't know, we have 3 input-output system, that is STDIN that takes your input, keyboard input, STDOUT that throws into your monitor on normal things, and third one is the STDERR that throws errors and warnings into your monitor, that is shell, that is terminal. This way you can use a smarter method or a shorthand method, whatever you name it, to print out in data structure in PERL directly into the Linux terminal or STDOUT. So we are done with this particular slide. Let's move on. What is globbing? The name doesn't suggest anything. First of all, you have to know the details. What is the definition of globbing? The expansion of a file name argument patterns into a list of matching file names. How? Let us see with an example. If we write my@files and then we give this particular syntax, that is home/docs and star then .c, exactly as the syntax. It gives a list of the files ending with the C. They are residing in the docs folder. Similar way, if we write the glob function, that is my@files, home, then docs, then star.c, it will list up the C files and give it back to the @files array. So here, this is the purpose of the glob operator, or definition you can say. How we can use it in actual code. So we write a while loop and then get my $file and then star abc.html, and then each HTML starting with the name abc, we can go and print ahead and we can close it. This is the way using the diamond operator you can use, or you can use the glob and then can take into my @files and then you can use it. So there could be combinations. So I let you decide what combinations you would like to think and do the combination and different angles of this question so that you are prepared for the interview table. Then for each my $file abc star.html. So here you can go ahead and print it. So you can use it with the for each loop also in this particular way. I have given you the syntax. You can go ahead, try out, and let me know what is your outcome in the comment box down below. So we are done with this particular slide and thorough example. Hey guys, welcome to Tech Simplified TV. In today's episode, we are going to install 3 PERL modules in our local machine from cpan repositories. These 3 modules enable us to deal with the read or write operations for MS Excel files through PERL programming interface. So sit tight and watch the video till the end. Hey guys, welcome back to the computer screen. In today's episode, we are going to install 3 different modules which are needed to operate on any Excel file. So first one is parse Excel. It will read the Excel, and then other 2 are write Excel. So these are three different modules and we will go through them for the installation process. So here I have my terminal ready. Let me go ahead and check whether the cpan binary is installed or not. We can see that the cpan binary is already there in our machine. So what we will do, we will now look into the module. So here you can see the first module is spreadsheet : parse Excel. Don't worry, I will provide these three URLs in the video description from where you can directly reach to these pages. So here if you go ahead and see, it's a parser. Parser is nothing but a program that reads a file, the file which has particular set of format and specific delimiters. Now Excel is a proprietary file, and to read that we need some additional modules in PERL. The first one is the parse Excel. That means you have already one Excel file with you which you want to read. This particular module will help you to read the Excel file through the PERL. So here you can see that we are in the cpan website, and here the details of this particular module is presented. So there is a parser, there is workbook, and all those things are there. If you go down, right, here are some examples which also you can follow. And it is a description, and I think in a detailed manner each and every function is explained here. So we will cover the installation today. So let us go back to the initial point here, and in the left pane if you scroll down you will see the install instructions here. And one more thing, I am online right now, so my internet connection is there already, it is running. And here I can see if I click this install instruction, these pages come out. Here before copying that, I would like to start the cpan shell. So our cpan shell is ready, and let me copy the install instruction. So here I have pasted the install instruction and I hit enter. So you can see it has started to fetch the respective file from the repository, and it is progressing for the installation. So it is asking for the root password. Let me provide it. I have given the root permission for the installation. In Linux, for any installation you have to provide the root password. This has finished. Let me check back. I think it has finished properly. There are a lot of files here and there. You can see the final message is okay. It has been installed. So this particular module has been installed in our system, so I'll close it. Now let us move on to the next module. This module is a spreadsheet : write Excel. So this means with the help of this particular module, you will be able to write the Excel files. And just to remind you, the Excel file is a proprietary file. So here this module will help us to write it. So you can see here all the methods are there. These are displayed. If you click them, you will get the description, and if you go scroll down, right, you will get some examples too. Here are the examples which you can use for quick start. Here you can see the file produced by the module is compatible from Excel 97 up to 2007. So you can see here is another note. This module is maintenance only mode, and in future only occupied with bug fixes. The newer, more featured API module is Excel : writer XLS, which we have already for our installation. So here you can see a quick start guide is there, and here the methods are there, and they are explained in detail. Let me go back to the initial point. And if I scroll down here, right here, if I click on the install instruction, I'll see here the install command. So what I do, I copy this and let me paste it here. So you can see the installation has started and it is proceeding. And I think we are done here with the installation because it is saying okay. And here let us go back and check whether any suspicious message or something like that. If it is not, then it has been installed. I think it is okay. So this particular module is also installed. So let me close this one. Now let us move to the third module here, which is a more up-to-date version as per the note that was already there. Here you can see it has methods here to manage the writing process, and here are also some formatting methods are also there. So I'm not going in details. Let me go for some. Here you can see there is some example which you can use to do a quick start. You can see methods are described. So this way you can go ahead and explore by yourself. Here, let me go for the install instructions. I go there. Let me copy this line and I paste it in the Append shell. So I'm online and you can see it has started to fetch the files from the repositories and it is installing them. And one more fact is that since we have given the sudo password for the first package installation and we have not closed the particular terminal, it is not asking anymore. Now we are operating as a root for the installation. You can see this has much more files going on and on. Let us wait for it to complete. So folks, here the installation has completed. You can see there are so many modules. Those were installed and so many files were fetched from the repositories. Let me close it. So today we have installed the first one, the parse Excel. That means we'll be able to read the Excel file using this module. The write Excel, which is now in maintenance mode. However, we have installed and we'll use it. And also we have installed a much more advanced module to write Excel, which is Excel : writer XLS. The goal of today's episode is done. We have installed the 3 different modules to play with the Excel file.